Thank you. It's a real pleasure and an honor to be here giving the Pufendorf Lectures. Today I'm going to read a lecture because it's, although it's on a theme that I've been developing, it's really the first time that I've gone through some of the pluses and minuses in what I feel is some detail, and I wanted to make sure that I could say them correctly. Next meeting, I think, depends a lot less on the right formulations and more on the ideas. So tomorrow I won't be reading, but today I do want to read to try and get it as right as possible. Doesn't mean they're intricate arguments, it just means that it took me a bit of time to make sure I was saying the right things. Now, whether you are in the US, the UK, or the Nordic countries, or the World Bank, if you are a policymaker or an analyst, you will be urged, indeed usually mandated, to pursue evidence-based policy. I think you're not so much mandated in the Nordic countries, but certainly you're urged, and there's a very active Campbell collaboration for the Nordic countries, which is really pushing evidence-based policy. Now, as a recent report commissioned for the UK Department for International Development explains, the search for what works, hence for a demonstration of the causal basis of interventions for the production of desired effects, is at the basis of the movement for evidence-based policy. I forgot, there is Title I. This movement argues that policymakers should take decisions based on evidence rather than on ideology or in response to special issues. Interests, sorry. That's the end of the quote from Diffid. Now, if evidence is going to play this crucial role in improving policy, we had better be clear just what evidence is. And that's what this first lecture is about. I will focus on evidence for effectiveness predictions, predictions that a well-defined policy will produce a targeted outcome here for us if we implement it. Randomized controlled trials, or RCTs, are touted as gold standard evidence for such claims. But there is a catch, and one that the evidence-based policy community is worried about. And I'm quoting now from one of the spokespeople for the movement. There is a risk that with concentration on or assumed superiority of experimental or quasi-experimental methods, approaches will come to be considered less effective or somehow inferior. Interventions not suitable for these approaches will come to be considered less effective or somehow inferior and therefore less value for money. So that's the worry. So it is asked, can non-experimental and qualitative evidence support effectiveness predictions? How and how strongly? Now, I shall argue that this way of raising the questions already takes far too much for granted. I propose we start much further back by asking, what makes RCTs evidence for effectiveness in the first place? What makes them evidence at all? My first two lectures offer an answer to this question. I start by proposing a theory of evidence that answers this question, a theory of what makes one fact evidence for another. This theory goes by the label, as you see here, the argument theory of evidence, and it's not original with me, it's just I've resurrected it because I think it's the right theory for these problems. So tomorrow I shall move specifically to RCTs, illustrating the argument theory of evidence and applying it to figure out when they can, that is, when RCTs can count as evidence for effectiveness claims. This will involve us in a discussion of what I call causal roles. RCTs are most useful when the causal role that the policy plays in the study setting is one that it can play widely. This is in part what can be meant by ascribing a causal power, or in my language, a capacity, to the policy. The third lecture is about these kinds of causal powers, how they differ from and underwrite causal laws, and why they are so useful to us. The last lecture focuses on causal powers in what I call nomological machines, which can also underwrite causal laws. In this final lecture, I will take up an older topic of mine that I've returned to because many false hopes for policy effectiveness based on what is thought to be excellent evidence come from ignoring lessons about the underlying structures or the nomological machines. The discussion of nomological machines will return us to issues of RCTs and their evidentiary power. What causal role a policy plays depends on what nomological machine is at work. RCTs thus typically provide evidence of effectiveness in new sites only if the behaviors in the new site and in the experimental site arise from the same underlying structure or nomological machine. Okay, so let us turn to the question for today. What is evidence? More specifically, under what conditions is one empirical claim E evidence for a second empirical claim H? I note from the start that evidence is not a natural kind. There is no correct theory of what evidence is, as there might be a correct theory of what an electron is. When this is the case, our account of what makes for a good theory should be responsive to what needs the theory addresses. The theory I propose started as a theory of evidence for use, in particular for use in making reliable predictions, especially predictions about what results will be produced by actions we consider taking. The argument account is not confined to this context, however, but should fit anywhere we face the same needs, including the warranting of empirical claims by scientific methods. A central problem I see everywhere that evidence-based policy is on the tapis is that the way the term evidence is used lets in far too much. And it does so while at the same time purporting to be very restrictive by subscribing to the highest standards of rigor. In response, my theory of evidence is demanding. That is because I agree with a common supposition. It is common and I think reasonably supposed that a piece of evidence for a hypothesis should weigh in favor of the truth of that hypothesis. It is with this in mind that I offer stringent criteria. I want criteria such that once a fact meets those criteria, we are right to allow it a place on the scale. My criteria rule out as evidence much that is currently lauded in evidence-based policy discussions, and that is all to the good, I shall argue. So here is the central tenet of my theory of oops, it's all come on at once. Well, doesn't matter. The central tenet of my theory of evidence is that if you aren't doing arguments, you aren't doing evidence. Okay? And so, evidence equals facts recorded in good arguments, and it's not evidence unless there's evidence that it's evidence. Okay. Now, how do I get to the doctrine summed up in these slogans? I start with the observation that for evidence about the truth, that for evidence that a hypothesis is true, we need true claims, that is, they have weight themselves, that, in accord with my desideratum, matter to the truth of the hypothesis. So, no claim is evidence for H unless it genuinely weighs in favor of H's truth. That, I claim, is always a conditional matter. Evidence is not a three-place relation. E is evidence for H. It is rather it's not a two-place relation. It's rather a three-place relation. So it's not E is evidence for H, but rather E is evidence for H relative to A. Okay. And what's A? A is a good argument. So here's my proposal. There we are. This is the proposal actually written, not in a slogan anymore. The argument theory of evidence maintains that empirical claim E is evidence for empirical claim H relative to argument A. That's the only concept that makes sense to define in this context. And it's relative, and it is evidence relative to argument A, or relative to a sequence of arguments. If and only if E is a premise in A, which is a good argument for H, or E is a premise in A prime, which is a good argument for a premise in a good argument A for H, etc., etc., etc. Okay, where a good argument is valid and sound. Okay, the premises are true and the conclusion genuinely follows from them. Now, I am inclined to suppose that validity is characteristic only of deductive arguments, where true premises ensure true conclusions. But I'd be happy to go along with some kind of inductive logic if you can show me that it will also serve the purpose. But I'm going to talk about deductive logics. Okay. Now, two parallel lines of defense support the argument theory, okay, of evidence. One ontological, the other epistemological. And that's because evidence is Janus-faced. On the one hand, it has to do with the truth, with truth and truth trackers, with what facts there are and what other facts can ensure these obtain. I should note here, though, that I take a generous view of what facts include. In particular, facts can be expressed by general claims, like Maxwell's equations, or the claims of the general theory of equilibrium in economics, as well as by singular claims like the cat is on the mat. Okay. On the other hand, evidence has to do with our attempts to arrive at truths, with our hypotheses about what facts obtain and the further hypotheses that provide warrant for them. The two lines of reasoning are obverse sides of the same coin, one expressed, to use Rudolf Carnap's terminology, in the material mode, and the other in the formal mode. Okay. Let's begin with ontology. Okay. Facts have logical relations, and nature must willy-nilly be consistent. So some facts or sets of facts are sufficient for others. If the first obtains, the second cannot fail to obtain. Or perhaps there are objective probabilifying relations in nature, and I'll come to these much later. Okay. So that's one fact then. One fact F sub E is evidence for a second F sub H. Then if Fe is a necessary member of a set of facts sufficient to ensure Fh obtains. Okay. Note that sufficient to ensure X obtains is not the same as brings about X. It means just what it says. The one set cannot obtain if the other fails. Now, if you were brought up in the tradition of Hempel and Nagel, as I was, you may well be more comfortable with the formal mode version of the parallel lines of defense. Evidence for a claim is supposed to contribute to warrant for the truth of the claim. What contributes to warrant for the truth of a claim are reasons. And what makes some claim E a reason for another H is that E figures in a good argument for H. And good here equals valid and sound. The premises are true and the conclusion genuinely follows from them. Okay. Deduction provides a clear sense to what it means for a conclusion to follow from a set of premises. It is the formal mode counterpart to one set of facts being sufficient in nature to ensure that a second obtains. Okay. So the demand that an evidence claim figure in an argument, a good argument, valid and sound, may seem strong. I actually make a stronger demand when it comes to practice. Not only should there be a good argument from E to H if E is evidence for H, but we should not count E as evidence until that argument is displayed. Okay, that's a very strong ideal, but I'd really like to urge that we approximate it. This is part of what I intend with the slogan, "It's not evidence till there's evidence that it's evidence." Of course, I mean, that's just a truism given the argument theory of evidence, but I mean to stress it that we should display the argument. C.G. Hempel's account of explanation also, Hempel's account of explanation, it also demanded validity, okay, and it also majored on deductive arguments. Hempel, though, allowed that many good explanations in science are enthematic. In particular, they are often not completely laid out. Now, when it comes to evidence for scientific claims or policy predictions, I think that can be a mistake. Both science and evidence-based policy get their grand status in part from their claims to rigor. And as a way to ensure rigor, nothing beats laying out the arguments and looking to see how good they are. Okay, so let's skip all of that. Okay, I stress the importance of arguments because arguments, like chains, are only as strong as their weakest link. A valid argument, this is all trivial for you folks, a valid argument with 9 premises known to be true and 1 known to be false does not make its conclusion 90% probable. So a body of evidence that nails down 9 of 10 premises is not enough for warrant. Indeed, if the 10th premise is known to be false, okay, the argument is no good at all. And what's been offered as evidence is irrelevant to the truth of the conclusion. Hence my third slogan, it's not evidence till there's evidence, it's evidence. This means that for good practice, you should not count E as evidence for H without good reason. That is, good reason that supports that it appears as a necessary premise in a good argument for H. Okay. Let's see, yes. Of course, you can bet that there is such an argument without having a clue what it is. You're betting, though. That's not evidence-based policy. Or you can, in good conscience, agree that there is such an argument if an honest expert assures you she has such an argument to hand. But the standards of rigor and explicitness on which science and evidence-based policy base their reputations require more. They require the display of the argument. Hiding what it takes to flesh out the argument is not only poor science, it is, I think, morally culpable. So I advocate the use of what I call argument pyramids. I'm going to illustrate this. Mystery stories provide good examples of the importance of each and every premise throughout the argument structure. And I'm also going to illustrate using a mystery, the importance of the arguments for each of the premises, as well as what an argument pyramid looks like. Consider Freeman Wills Croft's Inspector French, who is always at pains to lay out clearly the arguments that support his conclusions. In one of my favorite stories, Inspector French has become convinced, on the basis of a body of seemingly good evidence, that Carey murdered Ackerley. We can reconstruct his warrant for this in the form that I advocate, okay, that of an argument with explicit premises and explicit sub-premises, diagrammed in an argument pyramid that looks like this. Premise 1 in French's argument concerns motive. Ackerley, French argued, had cottoned on to a major fraud that Carey was involved in. This was backed by compelling evidence for 3 claims. Fraud had been committed, Ackerley had raised suspicions about it, and Carey was responsible for the fraud. Okay. This last was supported by evidence that Carey was in a position to perpetrate the fraud, that he had income otherwise unaccounted for, and, very importantly, that he had committed suicide when it looked as if the fraud might be revealed, despite Ackerley's death. Okay. Now, there was equally good evidence for premise 2 concerning opportunity. Carey could have committed the crime. I won't tell the whole story. The check mark, oh, they're missing. Goodness. There's supposed to be check marks in all these boxes, and they've somehow disappeared. Okay, so the check marks that aren't there are supposed to, mean the check marks that aren't there would mean that French had good reasons to back his claim about Carey's opportunity. But opportunity and motive by themselves do not support a conclusion of guilt. French, though, had a third premise. Premise 3, they're in the next picture. In fact, I think this picture wasn't, no, okay. The picture is in my notes and doesn't seem to be in the slides. That's the problem. The picture that's in my notes isn't the same as the one in the slides. Sorry. Anyway, you've got the point. You fill in these check marks. Okay. Now, let's go back, though, to where we were. So we've got some of the boxes filled in. Okay. But opportunity and motive by themselves do not support a conclusion of guilt. French, though, had a third premise. Premise 3 laid out the method. This was a step-by-step narrative of how Carey was supposed to have carried out the murder. This narrative was supported by good evidence that Carey was at some of the right places at the right times, and French had established by time. This is one of those nice stories where everything is timed to the last minute to see if you could be here or there at the right times. Okay, so French had established by timing distances and estimating speeds, Carey could have been at the other places in the chain when needed. French had a way to fill in all the boxes in the argument pyramid all the way down. Okay, but I won't do so. Wait, you know, if I don't find this other slide, you're going to be really puzzled. Let's see if it's not. Nope, sorry, it's just not there. So, okay. I'll have to explain to you what the slide should have. The slide is meant to have little roots coming out of the bottom of these, and then I'm going to explain the roots to you in a little bit. So it's supposed to have checks. By the time we're finished, it has checks all the way through and little roots coming out of the bottom. Okay. Now, as I say, Carey had a way to fill in all the boxes in the argument pyramid all the way down. But I won't do so since you don't want to hear about the mystery. You want to hear the philosophy. Okay. Together, French's 3 major premises made a compelling argument for Carey's guilt. Okay, so those 3. Then it was revealed that Carey had not committed suicide, but rather was murdered. French immediately reported this to his superior. And here's a record of their conversation, beginning with a question from French's superior. Okay. This is going to mean an upset to your theory, Inspector? French nodded. Complete. I've got to start from the beginning again. Is it that as bad as that? I think so. This murder of Carey makes it unlikely that he killed Ackerley. And if he didn't kill Ackerley, the whole of my theory goes west. So the whole theory fails. There is no longer compelling reason to think that Carey murdered Ackerley. But what about all that evidence French had painstakingly gathered? Well, it was no longer evidence at all. It was no longer evidence that Carey was the killer. Without the premise that Carey committed suicide, you can't move on, because the suicide was an essential prop for the assumption that Carey was responsible for the fraud. Okay? And without the suicide, the other evidence is too weak to justify this assumption. And without motive, opportunity, and the existence of a possible method for carrying out the murder, without motive, opportunity, and the possibility of having opportunity and method are not enough to support the conclusion that Carey was the murderer. It's still possible that he was guilty, okay, but French no longer has evidence to support that. Evidence is a 3-place relation. The measurements of distances and times are evidence of Carey's guilt, yes, but only relative to French's entire argument. When one of the necessary premises in that argument fails, those measurements are no longer evidence at all. As French says, his whole theory goes west, as in this picture. Okay. Now, so that's an illustration of an argument pyramid and the argument theory of evidence. There are a number of immediate objections one might have to the argument account of evidence. None, I believe, undermine the account, but let's look at some of these. On this account, given my demand that it's not evidence till there's evidence it's evidence, the job of warranting a claim can never be finished. Warranting a claim requires warranting the premises of a good argument for it. And to do that, you need warrant for premises and another argument for each premise in the first argument, and so on. So, warrant never ends, it seems. Well, yes, that's what follows on the argument theory of evidence. But it does not seem to me a problem. That's what life is like, right? It's what good, honest evaluation requires. Of course, we do stop somewhere. We have to. And that's what I was going to say if you noticed. No. So they're supposed to be. Back to the picture, there we are. There's supposed to be roots growing out of the bottom of these, okay? And what the roots growing out of the bottom boxes in the diagram of French's argument pyramid, what they're supposed to indicate is that the claims on the bottom are taken as well established. To the extent that our stopping points are not ones we can take for granted, at least for the nonce, we must be wary of our conclusions. That's why it can be worthwhile to have a variety of different plausible defenses for the same conclusion. Okay, so let's get back to where we were here. Objection 1. Okay. Now, we all know from Otto Neurath that in reasoning we are like sailors who must repair our boats at sea without ever putting into dry dock to build from firm foundations. So we will always have to trust to some claims we take as true, at least for the nonce. But we should not make our situations worse by neglecting our argument pyramids. Without laying out all the premises and all the arguments, we don't know how leaky our boat is. Okay. So that's objection 1, and I don't find it objectionable. I think to have a different view is simply to make a mistake about the metaphor of the sailors at sea. That is quite right. Okay. Now, the second objection is that the argument account implies a number of what might be thought oddities, and to all of which I have the same answer. Yes, these facts are indeed evidence, though they may not be evidence that's very useful for us. Okay, so let's look at these in turn. Anything true is evidence for a logical truth. Any claim at all is a premise and a good argument for a logical truth, so anything is evidence for a logical truth. Okay? Yes, and so it should be. Anything is evidence for a logical truth. Still, I wouldn't advise spending much to buy information about other facts in order to warrant a logical truth. If you know a claim is a logical truth, you don't need to buy information about other facts to warrant it. And if you don't know that the claim is a logical truth, okay, you will have trouble warranting that the claim is implied by the fact you buy. Still, if I don't know H is a logical truth, but I am assured by you, who are an expert, that if E then H, then E is surely worth learning, okay, even if H is a logical truth. Okay, so that's the first. The second is that things like A and B is evidence for A, arrow B and A is evidence for B, etc. Yes, they are. But we know that conclusions of arguments are no more warranted by the argument than the premises. So we're not going to be led astray here in evaluating the warrant for a claim. Okay. Third, everything is evidence for itself. That's okay too. Any claim does speak for itself. Again, though, we know that conclusions of arguments are no more warranted by the argument than the premises, so we won't be led astray here either. Okay. So that's objection 2. Now there's a third objection. The argument account employs a flawed theory of relevance. It lets in as evidentially relevant just the kinds of things philosophers have been at pains to rule out. And then this kind of complicated example I'm going to give. But first let's consider the canonical example. So the canonical example is John Jones takes birth control pills. Surely this is not evidence for his non-pregnancy. Okay? But I think, to the contrary, that it's excellent evidence. Okay? look at the argument. Nobody who takes birth controls gets pregnant. Well, it's not really true, but that's the assumption. John Jones takes birth control pills, therefore John Jones does not get pregnant. Given 1, 2 speaks, and speaks compellingly for 3's truth. What better basis could the truth of 3 have? To suppose that John Jones's taking birth control pills is not evidence for his failure to get pregnant is to conflate evidence and explanation. And that's just a mistake. Okay. Now, another objection is that if all arguments are deductive, then a number of things that might seem odd follow. Now, the first one is that there can't be both evidence for a claim and evidence for its negation, because evidence claims must be able to participate in good deductive arguments, and there can't be good deductive arguments for a hypothesis and its negation. Okay? That's okay too. It can still be reasonable to say we have evidence for H and evidence for not H when there are results that can figure in plausible arguments for H and results that can figure in plausible arguments for its opposite. That's just what we say, right? When we don't know. What matters is that we recognize that the results can only count as evidence relative to some good argument, so that we don't just let the result weigh in without commitment to the existence of these arguments. Of course, if there are good arguments that are not deductive, and hence the truth of the premises does not guarantee the truth of the conclusion, then it may be literally true that there is evidence both for H and evidence for not H on the argument account of evidence. But again, that is as it should be. Okay. Another objection is there can be no evidence for false claims. As soon as you know there is evidence for H by lights of the argument theory, you know that H is true. Right? Again, that seems to me no problem. The problem is coming to know that E is evidence for H. Okay? This is a serious job, and one of my concerns with the evidence-based policy literature, as I shall explain tomorrow, is that it does not take the job seriously enough, all the while boasting that that is just what it does do. Okay. Now, although I don't think our ordinary locutions count for much in efforts like mine to make precise an everyday concept like evidence so that it can serve specific scientific purposes, I'll just note that often we do use the term evidence in a way that supposes there's no evidence for false claims. If I am accused of cooking the books or murdering Ackerley, I might very well respond, but you couldn't have evidence for that. I didn't do it. Okay. So, okay. Anyway, that's, I think, enough on objections for the moment. In my final section, I should like to compare the argument account with one other, that of Sherry Rausch. I mean, I should also talk about Peter Ackenstein as well and his explanatory relevance account of evidence. But I have done this in print elsewhere, and so I won't rehearse all that here, but do the new thing with Rausch. Now, I pick Rausch and Ackenstein as the two relevant folks to comment on here. Not Ackenstein because he's been worried about evidence for a very, very long time, and very strangely, when he was starting writing 30, 40 years ago, philosophers of science didn't talk about evidence, and nobody talked about evidence except Peter Ackenstein and followers of his. You know, suddenly now we recognize that it's a topic that we've been neglecting. Okay, so that's Ackenstein, and Sherry Rausch, I think, has thought very deeply and has very interesting and useful things to say about evidence. Okay, but it's not just that they're both very interesting that I pick these two. I pick them because they are concerned, as am I, with a theory of what counts as evidence, what facts ensure others are true, not a theory about our entitlement to make, endorse, or use fact claims. Okay. So the other major alternatives besides, I think, Ackenstein and Rausch. You might know lots of others that I'm just not familiar with or have forgotten about. But the other major alternatives, besides these two, characterize evidence using probabilities. And push come to shove, their probabilities must be subjective, degrees of belief. So, okay, so let's see where we are. So evidence in the sense supposed in evidence-based policy and in the sense required, evidence in the sense supposed in evidence-based policy and in the sense required for establishing scientific hypotheses has nothing to do with belief. Okay? It has to do with the truth of empirical claims and with other facts that ensure that truth. So subjective probabilities have no place in the characterization of evidence for these purposes. Though, of course, they may, if there are any such things as subjective probabilities, okay, they may play a legitimate role when it comes to our estimates of whether one claim is evidence for another. But they certainly, subjective beliefs should have nothing to do with characterizing whether one fact is evidence for another. So I'm going to discuss some of my objections to probability definitions of evidence. The first is that, as I say, evidence doesn't equal justification of belief. Okay, that's what we've just done. Now, second is that even where one is concerned with justifying belief, so it's not the concern of the kind of theory of evidence that I'm looking for evidence-based policy, the kind of theory, objective theory of evidence that I think matters for in looking for evidence for scientific claims. Okay. But if you are concerned with justifying belief, I don't think it's appropriate to characterize evidence in terms of subjective probability, okay? Because that puts the cart before the horse. Okay? Degrees of belief must come from somewhere. And if we're anywhere in the neighborhood of rationality and science, reasonable decision making, the degrees of belief should hopefully come from rational consideration. So take the probability of H given E. Okay? The rational way to settle on a value for the probability of H given E is to consider whether E is evidence for H and how good it is as evidence. And then that would help you figure out how much probability, right, E confers on H. Okay? But then that requires some account of what makes E evidence for H independent of our subjective probability for E on H. So I think just that all these attempts to use probabilities, subjective probabilities to characterize evidence, they not only fail because, for me, because they're not characterizing the sense of evidence that we need to get a grip on for science and policy, but also they just don't do the job even when you're interested in justifying belief. Okay, so let's turn to Rausch. Like me, she is keen to keep the enterprise of theory of knowledge and the enterprises of theory of knowledge and theory of evidence separate. And I'm quoting from her now. The notions of evidence that I am aiming for are objective in the following sense: that E is evidence for H is understood as holding in virtue of a factual relation between the statement E is being true and the statement H is being true, not in virtue of anyone's believing that this relation exists. And that's the end of the quote from Sherry. Her basic idea is this, and I'm quoting her again: intuitively, good evidence for a hypothesis is a discriminating indicator of the truth of the hypothesis. And that's the end of the quote. Now, a discriminating indicator for her means some appropriate probabilistic analog of H is true if H is true if E is true, and false if E is false. That is H if and only if E. Okay. Now, formally, Rausch's account of evidence requires that for good evidence, the probability of H given E is high, okay, And in order to satisfy what she calls the leverage condition, Rausch in addition requires that the likelihood ratio be greater than 1. And moreover, she adds that it's highly desirable that the probability of the evidence claim is high. Now, there are a number of reasons that I do not adopt Rausch's account, hinging primarily on the fact that it is still too much of a hybrid between an account of evidence, just the objective account that she herself wants, and an account of how to justify our claims to knowledge, which she claims she's not discussing. Okay? The first place that our accounts part company is over what Rausch calls Bayesianism. I think she has a non-standard use of Bayesianism, but at any rate, here's what she means by it. For her, this does not mean a subjective interpretation of probability. So she uses probabilities, she thinks they're objective, okay? Rather, and I'm quoting from her, the Bayesian makes the idealizing assumption that all statements of the language in question possess probabilities. This is in contrast to the approach of classical statistics, in which it is denied, for instance, that hypotheses have probabilities. That's Rausch. Okay. Now, for the objective notion of evidence that Rausch and I both have in view, though, it cannot be probabilities of statements that matter, but rather probabilities of facts. And I do not see that there generally are such objective probabilities. Probabilities for facts arise from chance setups, which are a special kind of, well, what I'm going to talk about in the last lecture, nomological machines. And while nomological machines are not all that rare, those that count as chance setups appear to be a small subset. Okay. So I don't think that objective probabilities are all that widespread, and certainly not as widespread as evidence is. Okay. Then I disagree with each of Rausch's conditions in turn. Okay. First, P of E is high. Rausch insists on this in a debate about whether evidence should be surprising, which many, Bayesians especially, require. Now, her discussion at this point repeatedly refers to degrees of belief, despite the fact that she is embarked on an objective theory of evidence, but suddenly you find her talking, the whole discussion is in terms of degrees of belief. Okay? And I think that's a clue that she reverts to degrees of belief. If we are thinking about license to accept H, there are a variety of reasons to value observing consequences of H that were not expected beforehand, surprising evidence. Okay? Like worries about accommodation, rather than novel prediction, or the demand that H have content that goes beyond summarizing what's already known. So there are reasons when you're thinking of our knowledge claims to want evidence to be surprising. But notice that I say here not expected beforehand, right? That has to do with subjective probabilities and our claims for knowledge, which are not relevant to the objective notion of evidence. On the objective side, E should be true, not objectively probable. High probability of E only comes in as a demand when we consider whether we should accept that E is evidence. Consider an example. Okay. So I wanted to, I'm trying to think about this and whether, how to illustrate it. So I tried to find a case where I actually believe there's a chance there might be objective probabilities. Since I'm probably at the limiting end of thinking there aren't many objective probabilities, if I think there might be some here, I assume that this might be a good example for the rest of you. Say you have 3 coins. The first coin, for the first coin, the probability of heads is 0.2. Okay? For the second, the probability of heads is 1. That is, the second coin is 2-headed. Okay? And for the third coin, again, the probability of heads is 0.2. Okay? Now, imagine the following chance setup. And this is a chance setup that's going to be in place from time t1 through up to and including time t3. Okay? So what we do is at t1, at the first time, you flip coin 1 in a totally random way. Okay? Then at t2 you have choice. if coin 1 turned up heads, you flip coin 2. And if coin 1 turned up tails, you flip coin 3. And then what happens is that at 3, well, you flipped coin 1 and you're going to get heads for sure, or else you flip coin 2 and you'll get either heads or tails. Okay. Now, consider E. Okay. E is the claim that coin 1 shows heads at T2. I'm sorry, I used H in two different, good, I've got rid of the H's. H sometimes means heads and sometimes it means the hypothesis. So, okay. So the evidence claim now that I want to consider is coin 1 shows heads at T2. And H equals heads occurs at T3. Okay. Now, the probability of E is 0.2. And that's low. But E is compelling evidence for H, because if you get heads at time t, at time 2, you're going to flip the two-headed coin and you're going to end up with heads. Right? So E is compelling evidence for H, but it's got very low probability. Okay? Now what I want to underline is that it is compelling evidence not despite its low probability, but regardless of its probability. Even though E has an objective probability, that objective probability is irrelevant to its status as evidence. Okay, and that's what this example is supposed to show. Okay, sorry. That's so. And the example, I don't think the claim is just confined to this example. I think it'll be true anytime you have a chance set up that the probability of the evidence claim has got nothing to do with whether it's evidence or not. Okay. So what would I say about this case? Here's what I would say, is that C1 shows heads at T2 is true, if true, is evidence not for H, which was under consideration, right, but for H prime, which is a claim about the objective probability of heads at T3. And it's evidence for the claim that the objective probability of heads at T3 is 0.2. Oops, I think I've got that back to front, don't I? Anyway, this I think is the right thing to say and is what follows on the argument account. Okay. Now, given E. Right. So the likelihood, so that I think is my objection to P of E having to be high rather than E having to be true. Okay. So let's return to the points of difference. Okay. The third is leverage. Okay. Now, Rausch demands that the likelihood ratio is high, and this is an aid of what she calls leverage. She tells us, and I'm quoting, evidence provides leverage on the truth of claims about the world. Specifically, knowing that the evidence statement is true is usually a lot easier than knowing that the hypothesis statement is true. And we use the former to help us make progress on the latter, where we could not have made progress directly. End of quote. Okay, now Damien Fennell and I have elsewhere explained problems we have with thinking the likelihood ratio can provide leverage in the way that Rausch wants. Okay. But those are technical arguments and I won't rehearse them here, but rather what I want to do is just make the more general point that I've been making now for a bit. I don't see how to justify any condition that demands leverage for an objective notion of evidence. Okay. Suppose E, if true, is evidence for H. I agree there's no point in spending a lot of money to learn whether E is true or not as an aid to deciding whether H is true, when it is much cheaper to learn H directly. But that has nothing to do with whether H is evidence, E is evidence for H or not. It has to do with where we're going to put our efforts in trying to learn H. Okay. Again, that has really to do with knowledge and not with evidence, and not with the objective theory of evidence that Rausch is hunting for. Okay. The last thing is that she demands that the probability of H given E is high. Well, suppose this is so, that P is an objective probability and E is true. Then the objective probability of H is P of H equals P of H given E. And on the argument account, E is good evidence for this. That is, that P of H equals P of H given E. And that is so whether P of H is high or not, or whether P of H given E is high or not. Okay. For Rausch, okay, so I think that if P of H given E is high, P is an objective probability and E is true, then we have good evidence that P of H is high, right? Because we have a deductive argument that P of H is high from premises that are true. Okay. So I'm happy with that we have evidence that P of H is high. Okay. But for Rausch, these three facts are also evidence for H. Okay. Now, this is a case of purely objective probabilities. So I don't really quarrel with Rausch's assumption. I just think I wouldn't want to adopt it. You could add her stipulation as part of an objective count of evidence without, I think, doing damage to an account, it being an account of objective account of evidence. But I think it would be misleading. I don't think we have evidence that H will obtain, just that it can, or might well. More precisely, that it has probability P of H of obtaining. Now, there may be no harm in adding Rausch's requirement to the argument account, but it will mean that there can be good evidence in the fully objective sense for false H's, not just evidence we mistakenly think is good. And if we do add this requirement, then evidence cannot provide the same assurance of the hypotheses as it does on my version of the argument account. Okay. Now, also note that this requirement would play a different role in the argument theory of evidence than it does in Rausch's. For Rausch, this requirement is part of what secures the relevance of E to H. On the argument account, that is secured by arguments linking E and H. And the demand for argument should be enforced here as elsewhere. Okay? We should still demand a good argument, valid and sound, for the claim that P of H equals whatever it is, that it's high. And we had a good argument for that. Okay. And you should then have, I think, not only a good argument for it, but the associated argument pyramid. Okay. Now, there's one further feature on which Rausch and I differ, but not, I think, disagree, and that's on discrimination. For Rausch, E should track H. Bracketing issues about probabilities, this means E should be true if and only if H is. That's what I mentioned at the beginning. Now, the argument account requires only, or the argument account as I've put it forward, requires only that H be true if E is. Now, one could perfectly well add Rausch's demand. Evidence, after all, even objective evidence, the notion of objective evidence, is not a natural kind with fixed criteria or a fixed extension. I do not wish to opt for Rausch's stronger notion, though, since it is far stronger than what seems supposed in the evidence-based policy literature and in the bulk of scientific cases that I am familiar with. In particular, it would undercut the claim that positive results in an ideal RCT are evidence for causal claims, since positive results imply a causal connection between treatment and outcome. Okay, so that's okay. The evidence implies the hypothesis. But negative results do not show that there is no causal connection. So if you accept this as an additional condition, you're going to rule out you're not even going to be starting to play the game that the evidence-based policy people are playing, and I don't think that's where their major mistakes are lying. Okay. So now, there's a summary of the differences between Rausch and me. This is enough for today. Next lecture, I will provide a detailed example that puts the argument theory of evidence to work. In particular, as I said, I'm going to put it to work to show how dramatically to improve the rules for practicing evidence-based policy. Now, recall my desideratum at the start for theory of evidence. Okay? A piece of evidence for a hypothesis should weigh for the truth of that hypothesis. Advocates of evidence-based policy are concerned with just this desideratum. They police what gets on the scale to weigh in favor of policy predictions. As I shall illustrate tomorrow, they allow on the scale, right, only claims that are, as evidence, only claims that are true, as in this picture, or very, very likely to be true. They stick in a bit of epistemology there, right? Okay. But they really want to allow on the scale as evidence only claims that are true, as in the picture. But truth is, I mean, that already follows from what I've been saying, but truth is not enough for evidence. Imagine you had available the entire encyclopedia of unified science that lists every feature there is, borrowing the one you're predicting. Okay. Now, that would not help you estimate whether your policy prediction is true or not. You need to know not only what facts are true, but which facts are relevant to the truth of your prediction. The evidence-based policy rules vet for truth, but they are a poor guide to relevance. That's my worry. I claim that we cannot just drop claims on the scale because they are true. They must be relevant, and their relevance depends. You can't just drop them on the scale. They're not on the scale just because they're true. Their relevance depends on these arguments, okay? And it's only once the argument is secured, okay, that the evidence claim can be cut loose, as we see here, and fall on the scale. Okay. Only then can it weigh in on the prediction. Okay. So my closing thought is that, and I'm going to try to convince you of this next time, I claim that the argument theory of evidence has real bite, and it bites just where it should. Thank you.
All right, so thank you very much. I'm trying to understand your argument theory of evidence. So I just wonder what you would say to an example where it seems that you have evidence in an intuitive sense, but there seems not to be a deductive argument which would make it evidence in your sense. So let's take a case where you have the evidence is that John's fingerprints is on the crime scene. And the conclusion will be that John was there at the crime scene at the time of the crime.
Well, I take it, I mean, I would only buy that if I were prepared to buy that, at least in this case, fingerprints couldn't have gotten there any other way. And if that's not a fact, then I think his fingerprints aren't evidence that he did it. So, and if it is a fact, I have a deductive argument. I mean, there is a deductive argument.
Yes, but usually there would be other ways the fingerprints could have. Yeah,
so then I think it's not evidence. I think it's possible evidence, and it's really only evidence that he did it. Yeah. That it's really only evidence that he did it if they couldn't have gotten there any other way. Now, it's of course, now what we've done is we focus your attention on just what you need to find out. Could they have gotten there any other way? And so it's a strong claim about the restrictions on what it takes to be evidence. It's not just evidence because it could be, or we think it might be, or it's the kind of thing that we typically call evidence in ordinary discussion, because that's a loose ordinary concept. It's yeah.
So what would you say to a similar case where you have the weather report on TV indicating that it will be rain tomorrow? So that would be a case where a kind of similar case.
Exactly the same about all of them. That you don't, that it isn't evidence unless there's a deductive argument. That as soon as I, bring your attention to the missing premises, if I tell you those premises are false, I think you'd be inclined with me to say, well, looked like evidence, but it isn't, right? So that's what I'd say about it. But the other thing I want to say is that even though I'm now appealing to your intuitions of what you'd say or what you'd think, I do want to keep stressing that I think intuitions are about what you'd say or what you'd think is a bad way to do philosophy. at least in these areas, because what we're dealing with are these ordinary language concepts that serve a number of roles and work in a number of different ways, and they're not precise enough to use in genuine scientific or policy contexts, and so we need to, as people say, precisify, make them precise in some way or another. This is a way of making them precise that I think does just the job we need, which is to provide a story about objective theory of evidence, and that has points you to just what you ought to be doing, which is before you claim it's evidence, look to see whether the missing premises are actually true.
I have a quick follow-up. May I take that one? So, can I interpret you as delivering an explication of evidence in Carnap's sense? I mean, you're giving a kind of a reconstructed notion of evidence which is supposed to be fruitful and more precise and so on, and the fruits of this will be seen later. Is that the way you're thinking about this?
Well, I think that the proof of it isn't seen later. The proof of it, well, I mean, it is seen in the fact that it does the jobs that I think need doing. And there to provide a theory of evidence that that is the right kind of theory to be using an evidence-based policy, and for claims about evidence about scientific claims. Again, it's a strong theory, a restrictive theory. I think that's the way it should be, because both science and evidence-based policy pride themselves on that scientific claims and their hypotheses and the evidence claims and what you're doing is explicit, right? That's the Popperian ideal, and rigorous. And we've got both now.
Thanks.
Sure.
I like that you defended a deductive version of the argument theory of evidence. So the question is rather specific. Well, let's see. So a good argument, a deductively good argument, which gets you to good evidence or good evidence claims, does it contain a ceteris paribus clause explicitly? And if so, what does the clause look like? And do we know that it's true, or do we assume it as true?
Deductive, I don't believe in that was part of, I think, maybe I'm not addressing the right question, but that was part of what I hope to address by mentioning Hempel and enthematic arguments. I think, no, there's no ceteris paribus clause in a deductive argument, and I would really much rather, I think there can't be a ceteris paribus clause in an argument that establishes that E is evidence for H. Now, when you give a rendition of an argument to convince me or the scientific community that E is evidence for H, you might leave stuff out. And certainly you're going to have to leave stuff out somewhere in that pyramid. And then you might say those are ceteris paribus clauses. I wouldn't call them that. I'd say they're just premises that where there are gaps. You might fill it in with one. There might be one way to fill it in. There might be another way to fill it in. But there's a gap there. So I wouldn't call them ceteris paribus. I'd call them gaps in the argument. And I like noting that there are always going to be gaps. They're not only that we have fine stopping points. There's always going to be gaps in the argument. And that really matters, because you shouldn't be so confident that you've got evidence when you've got gaps in the arguments. This just isn't evidence on this account unless there really is an argument, and so it isn't evidence unless there is an argument. Can't be gappy arguments aren't arguments. Now there's an addition, my kind of moral, intellectual demand that you lay out the argument, and then of course you can't really meet that demand, and then there'll be ceteris paribus, something like ceteris paribus clauses, or not ceteris paribus clauses, but there'll be something like, well, I'm not so sure about this premise, but I think we can fill it in some way. Yeah.
Thank you.
Sure. And sometimes, I think that there's been a whole lot of work on robustness. and where you and loosely, right, the kind of general claim that everyone's either attacking or defending or precifying is that that if you've got a whole bunch of quote evidence, none of which assures evidence or none of which is that points in the same direction, that's better, and the evidence is produced by independent means, that you're much more likely the conclusion to be true. And I think that a version of that is that sometimes we're able to construct a lot of different possibly good arguments. And you think, well, I'm not really sure this is a good argument. I'm not really sure this is a good argument, but I'm pretty sure at least one of them is a good argument. So at least one of them, if one of them is a good argument, then I do have evidence.
Okay, I was given the word. Can you put on the slide close to the end where you compared your reviews with Rausch's? Yeah,
yes.
Yeah. You have in your account that the evidence is true. Now I take it for granted that we agree that no empirical statements we can for certain know is true. Therefore, if I should apply your view in a concrete case, I must say to myself, don't apply it until I have come to the conclusion that I regard the evidence is true. And that's the way to handle it. And then, well, in a way it seems to come pretty close to Rausch's view that the probability of the evidence is high because, since as a philosopher I know that I can't know that it is true, I can only know that it is probably true. So there are to me, you leave out, so to speak, the personal account. How shall I apply it? Just by saying, in my theory, in your theory, the evidence is true. When I shall apply it, I have to say to myself, I should regard it as true. So could you say some more words about this feature?
Yes. So now I have to stand in the lights, yes. It's just that I can't see people when the lights are shining in my eyes. If I stand, is that okay? Well. Oh, I see. The real light wasn't in my eyes. No, it was in my eyes before. But what's happened?
You're looking up. It was.
Ah, thank you. That helps. Well, I was looking up a little bit because I saw some of your faces. I saw people making faces, and someone thought. Yes, I agree that there's first the issue of what is evidence, and then there's the issue of under what conditions am I entitled to think that something is evidence? And I also agree that it's never going to be the case that I could absolutely conclusively know that something's evidence. So there are always going to be two stories, right? One is what is evidence, and then the other is under what conditions is one entitled to think that there's evidence. Now, people get off and running then on subjective probabilities for this job, but I think it's wrong for this job. So if they get off and running on it for this job, I have got a whole story I don't believe in for why you shouldn't use subjective probabilities there. But that's the job of warranting our knowledge claims. That's exactly the job that Rausch says she's not engaged in and that I'm not engaged in. If you take this as literally doing the job she says, then following your line, right, my epistemic probability has to be not that E. In order for me, right, to be epistemically justified in thinking E is evidence, for me, if I believe the subjective probability stuff, I would say then the epistemic or subjective probability of E is high. For Rausch, you would have to say the epistemic probability is high that the objective probability of E is high, because she's always talking about objective probabilities. And So, I mean, she is literally talking about objective probabilities. And I think that's one of the problems with the account, is that it goes back and forth between half an account about the objective relations that make something evidence, and then slips into aspects of, yes, but evidence is something that we should use. And I'd be very unhappy, at any rate, even, as I said, even in cases where there's objective probabilities, I'd be very unhappy requiring that the objective probability be high for just the kind of cases I cited. Now, if you want to require that I'm not entitled to believe it's evidence without the subjective probability being high, I'm not going to quarrel with that today. Wait a second, please, so I can look at you and get a drink.
Yep.
Yes.
So, the question is about deductive arguments in scientific argument or inference. So there is a well-known critique of Hempel's models by William Drey and Jon Elster and others, that if you want to apply it in the social sciences or in history, you will find that there are very few explanations of that kind. Now, you are not talking about explanations, but you still have the deductive argument patterns. So my worry would be that on your account there is very little evidence in history and social science as well.
Okay.
Is that
a
consequence?
It's a consequence. It's not a consequence that there's very little evidence. It's, of course, a consequence that there's very little stuff that we have very good reason to think is evidence, right? But it's not because of the analog with Hempel, because what goes wrong in the Hempel case is that one of the premises is meant to be a covering law, and we don't have covering laws. But I do think that I have local truths that imply other truths in history, like who. I shouldn't use that example. I'll tell you what I sorry. I'm going to tell you what I thought. Who used up all the loo rolls, the toilet rolls? There were 6 of them in the house last week, and now there's none. Okay, the missing loo rolls make me think that my daughter's come back for a week while I was away. And it's the missing loo rolls are evidence for my daughter's having spent the week there. Why? Well, because here's the deductive argument, right? Emily would have used 6 loo rolls. The house was locked. Nothing was missing from the house. Loo rolls don't self-destruct. Etc. These are the only reasons that the loo rolls could have disappeared. Right? The house was not broken. The house was not broken into. Loo rolls do not self-destruct, etc. The only one that's left is Emily did it, and I like that kind of argument. I like having to insist on you have that in history, because I think it shows how. I mean, as soon as you have to focus on what the missing there, it doesn't have to be, but you focus on what the missing premises are, and then suddenly you say, oh, well, there's something you didn't think of, and that really, those missing. What kind of evidence is that Emily was here? I mean, there's a much more, we would say, plausible explanation. So I think that there are lots of deductive arguments, and historians give something that looks like. They actually have I don't mean have in mind, but that would be reasonable to construct deductive arguments. Whether all the premises are true and one has evidence for all the premises, that's the problem. And I think, I'm going to talk about randomized controlled trials. I mean, I'm only probably just repeating myself. I don't know that I have any arguments for this, but I've been doing a lot of work on causal inference, and in the cases of causal inference, I think in our standard methods that we're happy with for causal inference, and the ones that don't quite do it, but almost do, I think the easy thing to see is that there are fairly straightforward deductive arguments here that really show that if the method could have been carried out in the ideal, you know, the plug was, in the physics examples, the plug really was plugged in, right? That if you could do it in the ideal, then the causal conclusion follows deductively. And in these here, either there's not a deductive argument that you can see, or the deductive argument has such a big missing, premise that's hard to, you can always make a deductive argument, of course, but it would have such an implausible or impossible to take seriously premise that you wouldn't be happy with it as being likely to be a good argument. Okay. Yeah.
Unless I've missed someone, I don't have any more questions on my list. We have plenty of time. Joe? With your slogan, it's not evidence unless there's evidence that there is evidence. I take it as a very nice, catchy slogan. At the same time, of course, there has to be something to prevent an infinite regression. So we don't want it to be the case that, well, evidence that there's evidence, that's a kind of evidence, so what's the evidence that there's evidence that there's evidence? And you acknowledge, as I understand you, that there are some things that we just take to be evidence without pressing further. But I wonder if there isn't more of a threat of something like an infinite regression there than you're quite allowing for.
I think not, because I didn't allow that there are things we just take to be evidence. I allowed there are things we just take to be true. Okay. Now, it's not evidence that there are two things going on, and it's not evidence. It ain't evidence unless there's evidence it's evidence. One is that it just seems to me to follow from the definition, right, that it has to be a premise in a good argument which is true and valid. Okay. Now, when you get down to, I'm sorry, I really messed up about not having the slide with the roots on it. But when you get down to those, if you take them, they're true. After all, at any point, you've got true, and true claims are, this is this trivial thing I mentioned, true claims are always evidence for themselves. So, in a sense, everything has evidence. Every true claim has evidence because it's evidence for itself. And now, that's what's the case about what is evidence and what has evidence and what kinds of things are evidence for other things. So, in one sense, there isn't evidence unless there's evidence that it's evidence. It follows from the definition, but it's kind of harmless about the state of the world. Right? But when I also then said, I then take it to be a mark of good practice in science and evidence-based policy to lay out these arguments. Okay, that's a separate. That's a one I didn't go into so much, but I think that's what's demanded by claiming that you're doing evidence-based policy and going around strutting around and saying we're really we've got these, you'll see, these rigorous standards and so forth. Which these guys do. There are these evidence hierarchies, and some people have been known to say, if there's, with RC randomized controlled trials at the top, and some people have been known to say, look, you can array all the putative evidence there is below that, but it's not evidence. Nothing but RCTs are evidence, and once you've seen what RCTs, don't look at anything else. That's stupid. Okay, so those guys have very high standards of rigor and something. Right? And if you're going to have those high standards, then I say it's part of the game that you be explicit and rigorous, and so you should lay out these argument pyramids. That's the game, and that's what you should be doing, and it's culpable not to do that. Now, at that point, we get to the possibility of an epistemic infinite regress, and then you do just, I think, you do have to epistemically plump. Right? You say, okay, this is true. That's my stopping point. Right? Where I take this is true, so I'm entitled to take everything from there up.
Or I believe this is true.
Yes.
The other concern I have, which is possibly related, is that I think oftentimes when we're evaluating arguments, we have this notion of a gold standard being mathematical proofs. And I think whenever we're doing arguments in any other field than very formal mathematics, that it gets very problematic to say what is a valid argument and what's not.
Yeah, I agree. I mean, so deduction is the standard, but it's sometimes hard to evaluate if you're not using just ordinary kind of Aristotelian logic, right? Because I think predicate calculus is a sort of silly. I mean, it doesn't render what we do in ordinary language. And it is interesting. I find interesting that my economist colleagues feel that they're dreadfully rigorous because they do all this mathematics. And now, if you go to an economics theory seminar, you have to be a really good game theoretician, not just a good economist. You have to be good at a certain kind of funny mathematics, and they, fancy kinds of game theory. Now they pride themselves on their rigor, but if you then ever actually look at it, once you get outside the tiny little model, they're just have no rigor at all in the way they talk, and it's very difficult to reconstruct anything that looks like a rigorous argument. I don't know whether that reinforces your point, that it's...
I'm not sure either, but I'm inclined to agree about the economists.
Yes.
Thanks.
Yeah.
I don't think we have any more questions, so thank you very much.
Well, thank you. Thank you all. And RCTs, I take it, as you know from yesterday, are randomized controlled trials, not rational choice theory, which I also talk about because at LSE I'm embedded in a internationally distinguished choice theory group. I wanted to start by telling you about two stories. One is about the Bangladesh Integrated Nutrition Project that was taken up on the model of a similar project that had been successful in Tamil Nadu. The idea of the integrated, well, first of all, there's widespread child malnutrition in Bangladesh, and in particular in the villages where the project was tried out, as there had been in Tamil Nadu. And the idea of the integrated nutrition program is that even given scarce resources, many of the children in these regions could be better nourished if they were nourished differently from the resources available, so that there are, so it is said at least, some mistakes that people are making in feeding their children. One is, I think, a perfectly reasonable desire of mothers to feed down during pregnancy because it's supposed to make delivery easier, but it's not good, not so good for the newborn child or the unborn child. So there was this program to educate mothers about better ways to serve their infants and preborns' nutrition needs. And it went along with a supplemental feeding program that is providing supplemental food for the families where even the resources available didn't reach to the level that would provide enough nourishment for the children. And this project was tried out in Tamil Nadu. Tamil Nadu had at the same time a number of other projects to improve childhood nutrition. Childhood nutrition did improve dramatically in Tamil Nadu, and very good post-hoc studies, not RCTs, but post-hoc evaluation studies carefully carried out, attributed a large part of the success to the integrated nutrition program. The integrated nutrition program was then adopted in Bangladesh on much the same model, and it didn't work at all, and even after 6 years, the nutrition levels for the young children were not any better than they had been before. Okay. That's story number one. Story number two is one about bicycle helmet laws. So if you do case control studies and just intuition, things you know about heads and bicycles and accidents, you'd expect that bicyclists wearing helmets would reduce head injuries. Okay. But in places, some sample places where helmet laws were introduced, there were time series studies, again, that wasn't introduced by a randomized controlled trial in which you made half the bicyclists wear helmets and forbade the other half to, which would be ethically unreasonable. Forbidden, happily, in most places. They were time series studies, though, of places where bicycle helmet laws were introduced. And as you see, jurisdictions that have implemented helmet laws have no noticeable change in rates of head injuries. In fact, in some of them, the rate of head injuries went up rather than down. So those are the two stories I want you to keep in mind. Okay. Now, in thinking about whether a project has worked or not, the gold standard for evaluation is supposed to be the randomized controlled trial. So if you're implementing a new policy in much of the world, you will be urged to implement the policy in a way that allows it to be evaluated by a randomized controlled trial. And there are, of course, ethical considerations and practical considerations that will stop that, but worldwide, Western worldwide, there's this big drive to evaluate projects and to make sure they're evaluated by randomized controlled trials, which are taken by many to be the only way to be sure about causal conclusions. And what you want in your, to know about your policy is that if there was an improvement, the policy caused it, not just that things improved over time. So are RCTs the gold standard? And if they are gold standard evidence, what kinds of claims exactly are they evidence for? Okay. So what I want to address today is what does it take to make a good, a positive result in a very good RCT, for instance, on the integrated nutrition program in Tamil Nadu. What does it take to make the results from the Tamil Nadu study relevant evidence for what will happen in Bangladesh? Okay. Or what will, if you've done a study of bike helmets, one of those case control studies that we had in the original cases of on bicycle helmets, what does it take to make those studies relevant to predicting about what happens if you introduce bike helmet laws here? Okay, that's the question. And not surprisingly, having spent yesterday defending a theory of evidence, an argument theory of evidence, I'm going to look to the argument theory of evidence to provide for us an answer. What does it take to make these studies evidence for the success of the policy if we roll it out here? Okay. Now, let's think about causal principles for the study population. Okay. So I begin by assuming that causes do not produce their effects by accident or by hap, that at least in any areas of the kind we're really hoping for here, where results are in any way predictable, causes will produce their effects in accord with causal principles. And so suppose that the y is going to be our outcome variable. Suppose that y outcomes in the study population are indeed determined by a causal principle, and I'm going to use this simple linear form. It really is as general as one needs, but nothing I say and the simple result I'm going to show you, it holds for more complex functional forms as well. But let's do the simple one because it's easy for you to see what's going on. So suppose that y is produced by a causal principle like this. The C equals right, means that the quantities on both sides of the equation are always equal, or always equal in the study population, and moreover that the ones on the right-hand side are causes of those on the left. And next meeting I'm going to talk a lot about what it is for something to be a causal principle. But let's just go with our intuitions at the moment. Okay. So suppose this, that the outcomes in the study population are determined by a causal principle, and that there's a probability measure over these variables, alpha, beta, x, and w. X is going to be our policy variable. Okay. So start with those suppositions, which are the standard suppositions, because they all use all these guys use probabilities. They talk about effect sizes, which are mean values. Mean values presuppose probabilities. So these are two assumptions that are built into the methodology. In the methodology, I mean, you don't even have doesn't make sense to be doing RCTs if these principles don't hold. Okay. Now, the standard outcome that's measured in a randomized control trial is the treatment effect, or sometimes it's called the average treatment effect, and I always forget whether I've decided to put the average into the definition of it or not. Okay. So the treatment effect here, see, I have defined it as an average. Expectation is an average or mean. It's the expectation of the outcome in the treatment group minus the expectation in the control groups. You know, so in a randomized control trial, two groups, right? The treatment group gets the policy, and the control group doesn't get the policy. It either gets business as usual, or a placebo, or an alternative policy, and it will make a difference, of course, what you're testing against. But that's not the issue for the moment. So we'll assume that the treatment, the value of the policy in the treatment group is little x, and the value of the policy in the control group is x prime, and this is just the definition. You look at the difference between the means in the two populations, hoping, right, for a successful policy that the mean is bigger in the treatment group than in the control group. Okay. So as I say, that it's just the difference between the average in the study group and the control group. So what? I mean, so this is, we define this quantity, right? What interest is it? Well, here's what you're supposed to have done in a randomized controlled trials. You're supposed to have randomly assigned, to have a large study population, and the study population is assigned randomly to either the treatment or the control group. The random assignment of individuals to treatment and control group is supposed to assure, it doesn't assure, but it's supposed to, it aims to assure, and if it's a large enough, very, very large population size, it makes probable that all the other relevant causal factors are distributed the same in the treatment group and in the control group. The random assignment makes sure that whether you get the treatment or not is probabilistically independent of any of the other causes, and the other causes here are alpha, beta, and W from our causal principle. So if, I suppose I should have put the, yes, here's our causal principle, and if X is probabilistically independent of alpha, beta, and W, it turns out a little arithmetic will show you that the treatment effect is just equal to the average of the betas times the difference between the treatment and the control. And if you want to do it really simply and call the treatment 1 and the control 0, then the average treatment effect just is the average of those betas. Okay? That's what it is, okay, mathematically. So if the average treatment effect, you measure it, you have to take the average in one group versus the other. Of course, you have, actually, it's more complicated than that. You don't just look at the actual averages on the finite frequencies. You usually have to do a lot of statistical correction, and then you measure how likely you are to have actually gotten the real averages rather than from the finite frequencies. But anyway, all of that, let's imagine you actually have got the real average. If it's bigger than 0, then obviously X is a cause. If this is bigger than 0, then obviously x has to appear in this equation. And moreover, beta has to be bigger than 0 for at least some of the individual units in the study. Okay, the individual units might be people, they might be villages. In the case of the Bangladesh and Tamil Nadu Integrated Nutrition Program, they were families. Children. Okay. So if the treatment effect is bigger than 0, then you can see that that shows you something about the causal principle. It shows you that the treatment, the policy really is a cause and a causal principle, and moreover that at least for some units the betas were non-zero. Okay, so positive RCT results show. I use the language, this is just to make it sort of simple, that the policy can play a causal role in producing the outcome under the causal laws for the study population S. So the study population, we'll call it S. We talked about the causal principle that governs the production of the outcome in the study population, and what we've learned about is something about that causal principle. And it can play a causal role. That means that it's actually there in the principle. That's all I mean by can play a causal role. And then what we've also learned is that the requisite support factors for it to play a positive role obtained for some u's in S. Now I'm going to call those betas support factors. I'm going to explain why I call them support factors in a minute, but the betas are support factors. Okay. So all I mean by X can play a positive causal role in producing Y is that, as I said, it's genuinely there in the causal principle. Now, looking forward to discussion for tomorrow and Friday, if X can play the same causal role widely, I say it has a stable capacity. I'm not going to talk about that very much today, but it's actually the other way around. This isn't the definition of a stable capacity, but if something has a stable capacity, it can play the same causal role across a wide variety of causal laws. Okay. So, now, that's what happens in the study population. And what we've learned from a positive RCT results in the study population is something about the causal principle that obtains there. Okay? Now, what about the target? Okay. The policy won't work in the target unless the study and the target laws share the causal role. So we've learned something about the causal role of the policy in the study population. That's totally irrelevant to the target population unless the target and the study share the same causal role. Okay? And then the other thing is that when you're in the target situation, some of the units in that target must have all the supporting factors necessary in the target situation for the policy to play a positive role there. Remember what we learned was that X was actually in the equation for the study population and that some of the betas were non-zero. Okay. Now that's totally irrelevant unless they share the causal role of X, and moreover over here some betas are non-zero. It's a little more complicated, I'll explain in a minute, but this is the support team that has to be there in order for X to play its role in the target situation. So let me now explain why I call these betas support factors. Probably many of you already recognize that, but let me talk a little bit about support factors and causal cakes. And just use an example. Homework. This is from a study by a colleague in North Carolina, colleague Harris Cooper. Homework, assigning homework can produce higher test scores, and it regularly does so in studies. So we have to refine both the cause and the effect more carefully if we're talking properly. How much homework, what kind of homework, when, where, under what circumstances, and what kind of test scores we're interested in. But for the nonce, just let's summarize it. But, homework can produce higher test scores, and it does so in some RCTs. So, but it doesn't do so without support, and that's what Cooper's work is there to tell us about. So he tells us that homework, for instance, can produce higher test scores, but only if we also have motivated students, students with a reasonable amount of ability, study space, supportive family, consistent lessons, work feedback, and some other stuff that he hasn't quite figured out. Okay. These are called causal cakes. Actually, epidemiologists call them pies. Okay. I don't like to call them pies because if you have a pie and you take out one piece, you might think you've got a pie left, or you've got quite a lot of pie left. But the whole point about support factors is that if you take out a piece, you don't get the result at all. Now, I mean, of course, you might well, if you take out one of these pieces, get some improvement in test scores. So it really depends on what level of test score you're aiming for. But to get the predicted expected level of test scores, Harris Cooper says you need not just homework, but you need support factors. If I had longer, I'd show you that there are also other causal cakes that include homework and don't have some of these, but they have something else. Okay, so there are a variety of different causal cakes that improve homework, but there's no causal cake that will give the improvement in test scores that has homework in it that doesn't have any of these helping factors. Okay. Now, as I say, I call them causal cakes rather than causal pies because I think of pancakes. And pancakes need, at least American pancakes, they need a rising ingredient, they need flour, they need milk, and they need eggs. And if you take away any of those ingredients, you don't get pancakes at all. Okay? So I call these causal cakes rather than following the epidemiologists who call them causal pies. Okay? So the point is that the other ingredients are necessary to ensure that the homework is properly effective. Now, this talk about, so the betas in the, sorry, I should have gone back then to the, I'm not very good at putting the, remembering. Here's our causal principle. Okay? The support factors then are what are named by the betas. If these don't have the right values, then X just simply doesn't contribute anything. Okay, so essentially, think of that as not having the support factors is beta, the betas are 0. So what beta represents in one fell swoop is all of the support factors, all of those other ingredients in a causal cake. Okay, so I'm going to show you somebody else who worries about totally independent, separate language. Somebody else who worries about these support factors. Ed Leamer, he's famous for writing a paper a long time ago called Taking the Con Out of Econometrics. And recently, in a discussion of the use of RCTs in economics, they are all the rage now in development economics, which I'll talk about tomorrow and Friday. Leamer wrote a paper called Taking the Con Out of Economics. Okay? And here's what he said. I love this because it was exactly on the same point I've been trying to make about support factors. He said, the overall treatment effect, that's our beta, is not a number but a variable. Often if you look at these equations, I mean, I was careful to put a U after the beta, so it gave you the idea that it might vary across the units, but usually the U's are left out, and people think of the betas as being fixed parameters and not as being variables that name real things like student motivation. Okay? So the overall treatment effect is not a number but a variable that depends on the confounding factors. Confounding factors for him then are things like student motivation. If little thought has gone into identifying these possible confounders, it seems probable that little thought will be given to the limited applicability of the results in other settings. Studying the average treatment effect, Leamer claims, is a little like the lawyer who explained that when he was young, he lost many cases he should have won. But as he grew older, he won many that he should have lost. So on average, justice was done. Now, philosophers, I hope you're all familiar that all I've been stressing is something we learned from J.L. Mackie a long time ago, is that causes are Inus conditions. They're Inus conditions for contributions to their effects, but I want to run through that so you make the connection that this is all very, very familiar. It's interesting, it's very familiar to us, but it's something which is just not really noted much in the evidence-based policy literature, which is why Lemur has to write it in a paper called Take the Con Out of Economics. So an Inus condition is an insufficient but necessary part of an unnecessary but sufficient condition. Okay? Now, notice that I say causes are Inus conditions for contributions to their effect. I'm going to talk about contributions again tomorrow, but roughly, sort of contribution is, if you think about Mackey, Mackey talked about two valued variables, causes and effects. The causes are either there or they're not. The effects are either there or they're not. And then he wrote formulae like this. E occurs if and only if A1 and C1, or A2 and C2, or blah, 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 where C1 is the salient factor, the thing we call the cause. And A1 are all those auxiliaries that are necessary for the salient factor to work. That just means the A's are the helping or support factors that in the equation got represented by betas. So maybe I should have used B's here to be more reminiscent, sorry. And what you have here is that each of these is sufficient for E to occur. Okay? None is necessary because there's always more than, what they say, more than one way to skin a cat. If you don't have this, you could get E by that. That's just like having other causal cakes for getting improved student scores. You don't have to have homework. You can have, there are a large number of things that Cooper suggests as alternatives where homework won't work. But one of them is better teaching. It's not that teaching is usually bad, but better teaching can help. Okay, so the thing is that when you've got these two valued variables, E is actually just a sufficient condition. Each of these is a sufficient condition for E to obtain. And none of these factors, this is a necessary part, right, of a sufficient condition, which sufficient condition is unnecessary for the cause. So that's the Inus condition business. And this is the two-valued analog of the formula CP I wrote down, which is one reason why I wanted to write it in that simple form. So in each case, these are sufficient for E to obtain. But now when we have a continuously varying variable, or a varying variable, more than two valued, things get a little more complicated. And these factors are sufficient, each of them, for getting a contribution for Y's, to Y's value. And if you didn't have any of them, you wouldn't get any contribution, but as soon as you've got one of them, you get some contribution to Y's value. So contribution, okay. Let's turn now to the issue of evidence, which is where we were trying to go. Recall, evidence is a three-place relation. Okay, E is evidence for H relative to a good argument, A for H. So what's the argument that makes RCT results evidence that the policy will work here? So we've got an RCT result in Tamil Nadu. What's the argument that makes that positive result in Tamil Nadu evidence that the integrated nutrition program will work here? What's the argument that makes, it wasn't an RCT result, but what's the argument that makes the case control studies had they been randomized control studies, what would make the argument of the randomized control studies on bicycle helmets relevant to there in Minnesota, relevant to what happens here? Okay. Well, positive RCT results imply, okay, remember, I'm just going to rehearse what I showed you. The policy plays a positive causal role there in the study population. It's right there in the equation. And there was a good distribution of helping factors there. Okay? Good means that we didn't really talk about the fact that sometimes the the very policy you have in mind can produce negative results as well as positive ones. And if that's the case, then you don't get a positive average unless the good effects outweigh the bad effects. If it doesn't produce bad effects, it just sometimes doesn't produce any effects, then you'll always get a positive effect size, but it might not be very big. If the distribution of the good betas isn't if you don't have many of the good betas, you're not going to get very strong positive results. So positive results imply these two facts. Okay, so here's the RCT argument. Okay, Y in study population, which is what we're going to assume, Y in the study population is determined under a causal principle of that right form. If there's a probability measure for the study population, then random assignment of U's to the treatment and control. All right, that gives you that the treatment effect in the study, and the treatment effect in the study population is greater than 0, you can conclude something about the study population. So this is the RCT argument that I sketched. I just wanted to lay out so you can see that I have an argument here. I have an argument that has the positive results as one of the premises, and the conclusion. What conclusion can you draw? This is about the only conclusion you can draw, filling in other true premises. So this fits exactly the argument theory of evidence, but it shows that this is evidence for that. Okay. Now I want to join that. Remember, what we're trying to do is to get all the way from positive RCT results there to expecting success here. So I've only gotten a little way of the way because I'm still talking about there. So how do we get over to here? I'm going to concatenate the RCT argument with something I call the effectiveness argument. And you can imagine what it is, right? The effectiveness argument starts with the premise the policy plays a positive causal role in the principles determining the effect in the study population. That's what we want to use as evidence. Okay. Well, if the policy can play, which would be can play, the same causal role here as there, and there's a good distribution of helping factors here, then the policy will produce a positive effect size here, a positive treatment effect here. Okay, this is just sort of trivial. That this says that if X appears there in the causal principle there, X will appear in the causal principle here. This says whatever the helping factors for here are, we've got some of them. Therefore, the policy will produce a positive effect here. I'm sorry, I switched from treatment effect to effect size. I'm sorry. Okay. So now you can concatenate these two arguments, and if all the premises in both the arguments are true, then you have a good argument that will take you from positive results in an RCT to the prediction that the policy will work here. Okay. If all the premises are true. Okay. Well, there's a lot of discussion about real RCTs and when the effects of real RCTs are true, and when the RCTs are done well enough to guarantee the premises in the RCT argument. What there's essentially no discussion of is these two premises. And without these two premises, you can't get anywhere. You can't get out of the RCT population unless you've got premises like these. And the question is, where are they coming from? Okay. So this is my picture of how you get from positive results in the RCT to the fact that your policy will contribute here. The result in the RCT is leveraged into evidence for X, the policy will contribute here, first by the RCT argument and then by the effectiveness argument. So what happens if the premises in either of those arguments fail is the whole thing comes toppling down. I like these toppling down pictures, you realize, right? Because all this heavy stuff, and then suddenly it's just lying on your toes. Right, okay. Okay, so bicycle helmets. Let's go back to applying these lessons to bicycle helmets. What went wrong? Well, missing support factors. Okay? Remember, we had these case control studies in intuition. We might even have had some RCTs. Helmets reduce head injury. Okay? The time series studies, though, show that many jurisdictions that implemented helmet laws don't have noticeable change in the rates of head injuries. And is this a contradiction? No, because what the case control studies were doing, just like an RCT, is they're giving evidence on one ingredient, okay? Not on the whole cake. We studied one ingredient, but we didn't look at the other factors that have to be present. So we didn't look at premise 3 in the effectiveness argument. And what the conventional explanation is that helmet laws, when they were introduced, they didn't just improve the wearing of bicycle helmets, but they disimproved one of the helping factors, which is how careful the motorists are being, and also another of the helping factors, which is how careful the bicyclists are being. So rather than improving bicycle safety by the very implementation and rolling out of the rules widespread, we did change as it were, the salient cause, but we also changed other factors in the cake. So we didn't here have an assurance that the support factors necessary for the policy to work in the new environment are indeed in place. In fact, our very action of making the widespread eliminated support factors that would have been there otherwise. Okay. So, similarly, what went wrong in Bangladesh? Well, what went wrong in Bangladesh, I wouldn't have put so much as a matter of the helping factors or the support factors being missing, but rather that the policy didn't play the same causal role. It just isn't it didn't play the same causal role in Bangladesh as it had in Tamil Nadu. Educating the mothers is simply not in the causal principle in Bangladesh as it was in Tamil Nadu. So let me explain that. The causal principle that we relied on, the very one that had been shown to hold in Tamil Nadu, didn't reach to Bangladesh. It was a true causal principle, and it held in Tamil Nadu, but it simply didn't, that causal principle didn't cover all the way to Bangladesh. And there were two problems. Okay? The first is men and mothers-in-law. Okay? So here, the World Bank post-hoc evaluation is done by Howard White, and Howard White tells us the program in both Tamil Nadu and Bangladesh targeted the mothers of young children. But mothers are frequently not the decision makers and rarely the sole decision makers with respect to the health and nutrition of their children in Bangladesh. Women do not go to market in rural Bangladesh. It is men who do the shopping. Okay? So you educate the mothers about what the children should eat, and the guys do the shopping. Okay? Older brothers or husbands. Okay? And for women in joint households, meaning they live with their mother-in-law, as a sizable minority do, the mother-in-law heads the women's domain. That means the mother-in-law is in charge of who gets what. So you educate the mothers about what the children should be given, and the mothers-in-law decide what the children should be given. Okay? So mothers simply do not play the same causal role with respect to nutrition outcomes in Bangladesh as they did in Tamil Nadu. Okay, so conclusions, which are very straightforward. RCTs may indeed be the gold standard for establishing it works somewhere. It works there in the study population. And we can, if you could do an ideal RCT perfectly, we've got a deductive argument that shows that getting a positive result really does indicate that the policy plays a positive causal role. It actually appears in the causal principle for the study, and that the helping factors are there in enough cases. So RCTs are indeed, I think, a gold standard for establishing it works somewhere if only we could do them perfectly. Okay. Okay. So they can provide you with a solid departure point when you're trying to reason from about whether a policy will work over here. But you can't pave the long road from it works here to it'll work there, and it'll work for us with gold bricks. Okay, so thank you.
Yes. Could you just go back to the slide where you had these what you needed to be able to move from here to there? Where was it?
Yes.
This one, yes. This one, no. This one, yes.
Yes.
So 2 and 3, this is what you need to be able to move from there to here.
Yes.
So my first question is, do you think you can? Because you have those from question mark, question mark, question mark. Is it possible is it possible to move from here to there? And how do you do that?
I don't think you can do so. So one of the lessons is doing more and more RCTs doesn't help. There's some hope. Okay, doing more. You asked a big question, right? Doing more and more RCTs will definitely not teach you anything about the helping factors. I mean, of course, you can do something with the RCTs that you're not actually allowed to do, but which would be stupid not to do, which is to do some subgroup analysis. So you can look to see whether or not in the Tamil Nadu population, I mean, if you were only, in the bicycle population, right, you could do some subgroup analysis and see that maybe in areas where, or among groups of people where the bicyclists are, like me, extremely risk averse and are going to be careful even if they are wearing a helmet. You might be able to notice that. Seeing it in the RCT is no guarantee at all, because we know very well that you will always find accidental clumpings, and that's data mining. But you can use the you can look at the RCT data as a sort of clue to what the helping factors might be. So we're just talking about the helping factors so far, but it's not so good a clue is understanding how and why the policy works. And that requires a very different kind of thought and analysis and theorizing.
So are you saying that we put too much faith into those kind of RCTs? We should do other kinds of...
We should definitely do other kinds of investigative research, because you really do. You can't make a prediction about what's going to happen here if you don't know what it is that enables the causal factor to work. So so you need to do that, and it's not something that will ever come to you from an RCT. It requires whatever it takes to understand what's relevant. So one of the examples is I use sometimes is you have a load of rubbish in your driveway, and you want to move the rubbish. And there are good RCTs that tell you if you hire an industrial magnet, you're more likely, it moves the rubbish more often than not. But what you need to know whether it's worth your hiring the magnet is whether or not what you're trying to move out of your driveway is a bunch of cardboard boxes or an old car, because the industrial magnet needs as a helping factor that it's ferrous material that it's moving. How do you do that? You don't do that without theorizing. And now what does it mean to theorize? And what's the whole network of activities that help you? That's a whole question for scientific methodology and philosophy of science, but it certainly isn't something done by doing RCTs. It is the case that if you've got a very good hypothesis about something that's a helping factor here, then it's just a cause. All those pieces in the cake they're all causes, they're all Innes conditions, so you can actually do an RCT on it. Once you've got a candidate beta, okay, for this population, you can do an RCT on it in this population. It doesn't tell you whether those will be the helping factors over there, of course. But that was only half an answer, but I've been talking so long.
But can I just ask just a small question? So and I think this is perhaps not even possible to answer, I don't know. But I was thinking, suppose that you have a good understanding of the whole cake in a situation where you've done this kind of RCT over there. And then what you're saying more or less is that one factor at least is that it's not just the cause of it's not just the cause that matters, it's the whole cake that matters here for us to know if we will get the same result. So, and what I was just wondering, what exactly does that mean? So does that mean that you're saying that in order to learn something from an RCT coupled with information about the whole cake over there, we need to know that we have the same helping factors? And what does that mean? Do they have to be identical helping factors, or is it enough that you can kind of in some way find out if their contribution amounts to the same kind of degree, or they help as much? Perhaps they're not the same, but they help to the same degree as the helping factors over there. What do you think is needed?
Well, I think, I mean, regret that I think all this is really hard. And that's the human condition. It doesn't mean you shouldn't try to do policy and you shouldn't bet and so forth, but the first thing to note is what you said, that the very same policy could be effective in two places, but with different helping factors. So in the Bangladesh case, supplemental feeding was a helping factor. Teaching whoever's in charge isn't going to help about what to feed the children if they don't have any food to feed the children. Supplemental feeding was a helping factor that was necessary and sufficient in Tamil Nadu. Supplemental feeding turned out not to be the requisite helping factor in Bangladesh. It wasn't the helping factor for a very strange reason, is that the right helping factor, there was a shared helping factor. I'm sorry, here's not a good case because it's a case where there really is a shared helping factor. It would be the same if only you identified it properly. So over here, the supplemental feeding, the food that was offered, called supplemental feeding, was actually given to the kids. Over here, the supplemental feeding, exactly the same thing, that was, they thought it was the same helping factor that was given to the kids. That's not the helping factor that really, that's not the name of the helping factor really. The helping factor is getting the food into the kids. Over here, there's food leakage. The food either went to another member of the family, or it went to that kid instead of another meal it would have had. So, I'm sorry, there is a case where there's helping factors at one level of description were the same. So at least they were the same. We just didn't recognize what that level of description is. But there are lots of cases where the helping factors simply aren't the same at all. And how do you know that? Sorry, you have to really, I think, understand how the cause operates, and then you could see what kind of thing is necessary. And it's not till you understand something about magnetism that you know that sometimes the magnet works, sometimes it doesn't. Well, you've got to know what the helping factors are. Again, there's a case where the helping factors are universal, but how you get when they're not universal, you really do have to understand how it works and why it would work in the local situation. And there's nothing for it but the hard work of trying to figure it out. I mean, the RCTs are like it's called sometimes in literature silver bullet. Gold standard and a silver bullet. I like this. I'm not sure whether being gold is better than silver or not, but at any rate, it's a silver bullet. And there just aren't any silver bullets. There's no kind of shortcut to hard, complicated, no manual for it, scientific work. I mean, there's a manual for RCTs, but there's no manual for how you do the hard theorizing and detailed investigation. I mean, what do you have to do to find this out? I don't know. You have to do real science. Sorry, that's trying to sort of explain how I see it. Ingvar, are you going to ask the same question again?
No. I agree with more or less. I think, as I've understood, I agree, so it's no criticism. The question I'm going to put forward, I think I even can guess your answer, but it would be nice to hear what you yourself are saying. And if some medical people have not fooled me, they have said like this, that, the RCTs are no longer regarded as the golden standard. Now it's so-called meta-analysis done by the groups called Cochrane groups. And for those of you who don't know it, it's merely that some people sit down, take a lot of RCTs done with respect exactly, more or less exactly the same kind of disease or the same kind of treatment and so on. And then they look upon that. Sometimes they come to a result that cannot be found in any of the specific RCTs. So I would simply like you to say some words how you expand this position of yours to apply to meta-analysis as well.
Yes. So it's not just the Campbell collaboration. The Cochrane collaboration. For social policy, the analog of the Cochrane collaboration is the Campbell collaboration, and moreover, there's 50 at least, or 100. I mean, if you just look worldwide, there's must be hundreds of different agencies that now demand impact evaluations, and because they demand them, then they have to write down some rules for what you won't get the money unless you're going to do an impact evaluation. So they have to write down what a good impact evaluation is. Right? And that's an RCT. But then very often these, if you want to have really good knowledge that the thing has worked somewhere, and then you want to have a meta-analysis of a number of RCTs. What a meta-analysis does for you is it gives you a larger study population. Some of the pharmaceuticals pills can sometimes relatively easily be tested on large populations. A lot of medical interventions cannot be. So there are small new hips or new bits of surgery that have to be done in hospitals where, etc. So, and certainly the social policies are usually done on small samples. So and the small samples, you could just be seeing, independent of any flaws in the setup of the RCT, which flaws are very difficult to eliminate because of the difficulties of just doing real science. But even if everything were done perfectly, you could still be seeing a statistical anomaly. You flip a coin 10 times and you could get 10 heads in a row. And so that's all. What's a meta-analysis is, it kind of makes an artificial large population out of all these small populations. It throws them all together. There's a problem because none of them really have the same treatment exactly the same treatments, and they didn't measure exactly the same effects. So you do a lot of statistical, they had different dropout rates. I mean, there's an enormous amount of statistical correction that goes on in doing a meta-analysis. So the first thing to note about meta-analyses is that the manual isn't objective. And so a lot of people who've compared meta-analyses on the same studies done by different individuals or different groups, it turns out that different statisticians take exactly the same set of studies and their meta-analyses come out with very different results. So that's the first thing, is that you don't have this kind of promised level of objectivity. Right, that there's no judgment involved. It turns out to be very sensitive to judgment. But moreover, I mean, what you see is what you get's exactly what you put in. So what you find out is you don't know that, this is a long story, right? You don't know that each of these populations is governed by a single causal principle. So you might be getting a mix of causal principles. So what you'd be getting is an average over the effect sizes in each of them. And if you get positive results in the meta-analysis, it means that at least one of those causal principles, the policy played a positive role in. And you, in some sense, you have a bigger population, but in another you don't, because unless they really are all governed by the same population, you don't really have the appropriate kind of population. I mean, with same causal principle and same probability measure, you don't actually have the right. Your study population, which is supposed to be just, all clumped together, the statistical methods only work if they actually have the same probability measures, and there's no guarantee of that at all. I mean, the probability measures are, I think, as likely to be diverse as are the causal principles. But okay. But there may be an expert on meta-analysis in the room.
You mentioned the level of description as essential here. And to take very small examples, you mentioned head injuries without specifying whether it was the frequency or severity. A more typical example might be if you give kids math problems to solve at home and you get a successful result in a controlled trial, you are likely to report that as the success of giving homework. Then someone else interprets this as asking the kids to memorize historical data or something like that. So you go unnecessarily abstract in your description. And this is maybe not a philosophical, but a social problem, really, that people tend to report it. And I have a specific case in mind, namely the idea of quality in education, which to my mind is such an unnecessary abstract description of a lot of things, and which has great impact on actual social policies. So my general remark here is perhaps not much of a question, but rather the asking for your comments on how do we describe things on an adequately abstract level in order to still make it possible to transfer from one application to another, but not giving a wild ticket to go everywhere.
That's my answer is all these questions essentially are the same. It takes real science. So there's always there. Just to expand on Banks' remark, there are two pulls. One pull says, look, if you've done an RCT and you want to institute the policy elsewhere, you'd better be absolutely faithful to the details of the treatment as it was described in the RCT protocol. So the point about an RCT is that it is manualized, and one of the points is you're supposed to describe in operationalizable detail what the treatment is so that you're sure everybody really got the treatment. You know what the treatment is and everybody got it. So you've got fairly concrete descriptions of the treatment and very concrete descriptions of the outcome. Again, that's part of doing a rigorous RCT, that you stick to the protocol, that you've got operationalizable, clear, concrete protocol. So one claim is that what's been tested is, as you said, the effect of doing these kinds of math problems at home, and it raised these kinds of scores on this kind of a test. Right? And if you want to export it, you better be, fidelity is the word, you'd better do exactly the same thing and only expect results about exactly the outcome that was in the protocol, because that's what's been tested. Right? We didn't test homework, right? We tested this specific kind of homework. So that's one argument, and there's a push then to fidelity. Then the other side of it, though, is that usually things that are very, very, very concretely described are not the level at which at which you find general truths. So that normally, in order to get something which is going to hold somewhere else in an interesting way, you have to have a more abstract description of it. So I think that the example of the supplemental feeding, right, the very concrete description, which was in the protocol, give them so many calories, which mixes protein and so forth and so forth in the right way, and give it to them Mondays, Wednesdays, and Fridays. Hand it to the mothers Monday, Wednesdays, and Fridays. That wasn't the description. There actually was a description that was, could travel. That if you did it here and there, you did that same thing here and there, which is make sure the children ingest those calories and that amount of protein, etc., right, which I think is a more abstract description, because over here, right, just giving the mothers the food to take home constituted doing that, and over here it didn't. And so you need first to know exactly what's the level at which which you can find something general enough to cover the two cases, and then you have to know what constitutes the concrete operationalization of the more abstract concept over here. And how do you do that? That's the work of real science. That's the sort of standard example I use is if you're doing this is stupid. It's a very diagrammatic example. But if you're doing experiments on motion subject to no forces, so you want to know how bodies subject to no forces travel, and you're doing them here, experiments, you can do any number of experiments and you'll always get the same result, is that they travel like this. Right? They travel on a Euclidean straight line. Now, if you move to a spherical geometry, that simply does not travel. Right? That result is local. It's local to Euclidean geometries. If you're on a circle, on a sphere, then bodies subject to no forces travel on great circles. And if you're on a saddle, right, they'll travel like this or like that. And there is something that you can learn on the Euclidean plane that's true everywhere, that bodies subject to no forces travel on geodesics, on the shortest distance between 2 points. But you don't, how do you learn that? Again, that's what real science, that's what we do in real science, and there's no scientific method for how to do it. But you have both to learn that it's geodesic, which is just the right description, and then what counts as a geodesic on your new funny geometry. Go ahead, Bengt.
Thank you very, very much. I'm very happy that you made the distinction between RCTs and real science, because I'm so worried about RCTs being considered gold standards. They're not that, because they are by definition only looking at the superficial result, superficial in relation to the observational level you have. And they, by definition, disregard working mechanisms, which are put there in place by real science. So in order to get somewhere, you need the two, and you need the two in a way that they really connect.
Yes.
Thank you.
And can I just make I suppose I'll talk about, maybe I won't talk about this, but working mechanisms, has a lot of different meanings, and sometimes when medical people talk about the mechanism, they mean what I would mean by the causal pathway. And so, how does it happen? Well, it does this first, then this, then that, then that, then that, then that. And of course, you won't get the outcome unless the helping factors are there at each stage. So understanding the mechanism in the sense of the causal pathway is really important. But there's another sense of mechanism, which is the kind of Bechtel, MDC, Cartwright sense of being some kind of underlying causal underlying structure that enables this causal pathway to happen, that Bangladesh and Tamil Nadu have very different socio-cultural economics underlying structures, and that's why the causal pathway from educating the mothers to child nutrition is enabled to happen over here, but it fails over here. So I think you need to understand the mechanism in both senses, and that otherwise you're just not doing proper science yet. We're getting on with it, but
Thanks for an interesting lecture. as someone who works within drug development and with clinical trials on a daily basis, I think it's very reassuring to hear that your lecture and your doubts, the doubts you're raising about the current prevailing methodology of randomized clinical trials as being the golden standard. Because I think that there's also in the academia, there's a big concern within the industry, pharma industry, that the RCT methodology no longer works. It's sort of outlived itself because there are so many kind of flaws in the ways it is being used, and most of all, I mean, one thing is the lack of generalizability of the groups, and another one being the extreme placebo effects that are seen, particularly in studies that are done in the US for many reasons, possibly for patients being paid quite a lot of money to participate, and possibly for the kind of patients that are used in those trials. What do you think would be the perspective? It's quite interesting to hear from a philosopher's point of view, you as a philosopher. What do you think will be in the future? I mean, you're hinting at subgroup analyses, you're hinting at data mining to try and really get behind the standard kind of clinical trial outcomes that we have. Do you think there will be some kind of, I mean, I've read sometimes now in journals speculating that the current development within data management and advanced software, that there will be ways to, in huge populations, to try and identify potential effects in a more naturalistic, with a more naturalistic background, so to speak.
Yeah, well,
what do you think is the future? And the regulatory authorities, I mean, they're so stiff on the RCTs. So it's quite difficult to change.
I think those folks are off and running doing that. I think that I wouldn't want to put very many of my eggs in that basket, because I really do think, following Benk's suggestion, that you make headway by, but this is probably because I have this background in physics, where we know things and we know, well, I do think that you're going to make headway by by re-allowing information about mechanisms. So, you know, one of the things that, not for you, but when you export that, so he's describing problems in the medical settings themselves, but when you export the medical hierarchy, for, you know, with RCTs at the top, etc., to social policy, you've dropped off a whole lot of what's happened already in the medical test, because it's so expensive to test anything that you don't bring a new product to you know, a last stage RCT unless you've already done all this other stuff and have a lot of high prior personal probability that it does work. And in the Campbell collaboration, when you're doing social policy, there's no indication that, you know, the RCTs are to be put on top of all this antecedent information. But now, when we've got the RCTs on top of it and they're still not good enough, then I think I think you've got to loop back. One of the things you have to do, you shouldn't stop looking at large datas and data mining, but you should loop back and really start reinvestigating exactly what the causal pathways are and what the theory behind the causal pathways is. And you're not allowed to use theoretical derivation as evidence in any way, and that's mad, I think. And the reason, and I take it, one reason is we're in this period of not trusting, and theory seems to be much more manipulable in the hands of the theoretician than the statistics are in the hands of the statistician. But I think that's just a problem, a scientific political problem you have to solve.
And I guess a problem for the authorities, regulatory authorities also.
That's what I meant. They have to solve it. I mean, that they're not encouraging us to look just where we need to look, because everyone feels it's that if you allow that kind of putative information, it's too easily manipulated. So you've got a kind of problem of honesty versus effectiveness of your evidence. So I think you should look over here. You should do much more theorizing. The well-established theoretical claims should play a much better role, but there's the problem that they're much more easily manipulated for profit and self-interest, and so there's a practical reason not actually to do the very scientific enterprise that can help us.
It's a lot of money wasted. I mean, it's $1 billion and
yes.
in each development of each drug, and frequently they fall on the last, just before the finish line.
And then there's all the problems about, you only monitor for side effects over the short term. You don't know how to. They're not very good. RCTs are not a device for monitoring for side effects. You have the regulatory agencies have to make you do it in some other way, and the side effect thing is not done in a way where you can show that what you're doing to look for side effects is actually likely to turn them up, etc.
It's a question, of course, what to believe and not to believe, and what to trust and not to trust. And you put up a title here, randomized controlled studies. But the interesting thing is that people have different inclusion-exclusion criteria when they are going to go through studies. And I just review a paper. They had 2,663 papers they were looking into. And at the end, it was an American study, came out with 3 papers, and 2 of them came from the same author. And from that they were based. And the problem here is that, they put up, conventionally you have to fulfill a number of criteria. One is, for instance, you have to mention when the study was performed, from the 1st of January to the 31st of August or something. If
Sorry, I missed the last few sentences.
You have to state exactly when the study was performed, and if
yes.
you have forgot that, the study is out of the comparison. So this has become a problem, and we had another study with people in UK, and then they were evaluated 263 papers, and they come up that there was only 6 that were supposed to be valuable to include. But then we come to another problem, is that if you don't know who is doing the study and personally don't know the person, so you may question, because in that case 2 of the 6 studies that of the 263 fulfill the criteria came from Plovdiv. And you know, of course, what Plovdiv is? No. We spoke to somebody in Harvard, and the woman that was from Plovdiv. So we said, we have some collaboration with Plovdiv. No comment, nothing. Everybody knows where Plovdiv is, so that's a joke now we have. But that in that particular case, this clinic was they were investigated person without electric lamps, so whatever they said was nonsense. So that is another thing. How should we track down and identify the quality of the person who produced studies and data? That's a problem.
It's a problem, and it's one that usually I take it when you were talking about studies that it sounds to me like what I would call a systematic review. So when you look at these evidence hierarchies, what kinds of things are good, we not only have at the top meta-analyses of RCTs, but systematic reviews. And then a systematic review by something like the Cochrane or the Campbell collaboration has rules for what kinds of studies it will count as good studies that they're going to review in order to tell you. So a systematic review is supposed to review all the good evidence and see how it weighs up, or hope it all points in the same direction if it doesn't explain what's going on. But as remarked, the criteria for a good study are so strict, and in particular they really do require randomization, that by the time the review's been done of the studies, you start out with hundreds of them and end up with 5 or 6 to review, which has a number of lessons. One is the lesson that a lot of studies are flawed, which we know. Science is really hard. Sometimes people are being dishonest or concealing things, but sometimes it's just that studies are hard. But the other thing is that the criteria then are telling you not to look at the other 270 studies because they weren't good enough. Only these 3 meet the high standards, and that seems mad to me. I mean, that's just not doing the hard job of looking at all the evidence and figuring out what should follow from it, which is a hard job, but of course, again, it's not, you can't do it mechanically. And then we have the issue of trust. Then the other issue is, and I've been in trouble with this at a Nordic Campbell collaboration meeting years ago. I didn't get invited anymore. The fellow who was really defending these systematic reviews said, here's what used to happen. You ask somebody to write a review of the literature. Where do we stand with respect to drug abuse among 13-year-old inner-city British kids? And you ask somebody to review, to write a review of where we stand, what does the literature show, and it would be, it's always a guy, right? It'd be a guy who'd go, and what he does is he's go to his file drawer and he gets out his papers of his friends that are in the file drawer and writes a review of what's in those papers. We now have rules for how to decide what studies should be in the systematic review. And then, well, I noted that exactly the thing you mentioned, that many of my friends in physics, in particular a couple of really, really good experimenters I know, that's just what they do and just what they think they should do. They go to they're good experimenters, they know who the good experimenters are, and when a good experimenter gets a result, they believe it. So I have a friend who spent 25 years putting gyroscopes in space to test a specific implication of the general theory of relativity. And 3 years before the outcome, somebody else did not exactly similar, but testing the same kind of consequence of GTR. And Francis said, okay, it's settled. I mean, we all thought it was settled anyway because he believed the GTR result. But why? Well, that guy's a really good experimenter, right? And so, anyway, the physicists, many of the physicists I know right, trust to some experimenters and not others. How do they know? I don't know, just the way you know when you hire somebody or admit a graduate student, but it's not something that you can manualize. And so then you're back to the issue of trust and who's in control, whose friends are getting the right to make these decisions. I think we have the same conversation that I had with, oh, he's gone already. Anyway, at dinner last night about hiring somebody you know, right, versus an open and free competition. Right, which going through the manual and the open and free competition, because you've got only a handful of evidence, has the drawbacks of accuracy, but fairness and here if you're really good and you know the right people, unfortunately, it probably means that you know the guys who are doing it well. So it's one of those, again, political scientific trade-offs, I think.
That in my opinion, it's really scrutinized and criticized by the Cochrane, mostly because of it's really like mixing a strawberry pie with an apple pie to get this. So yeah, but I have two other comments. Actually, the helping factors, these are also a result. Just as important. Also, it's also a result, just as important as the primary results.
Yes.
So identifying the helping factors is also a result. And I also have a second comment that if you look at in life science, that they're moving more outside UK, US, and Europe for these RCTs. And in your discussion, maybe you don't need to answer this, but what will it be in the future for the RCTs if it's moving to other countries? Is it also from here to there?
Absolutely, it's from here to there, and there's a kind of assumption that people are people wherever they are, and so you can test drugs for Upper East Side New Yorkers on people in Indian villages, and I think that's. I want to see the evidence that people are people with respect to this drug, this outcome, right? This population. And the other, of course, is that you're getting. There's always the. We never do RCTs on a sample of the target population, partly because, in principle, that's not possible since time passes and the target population, but even as it is, and when you're and when you're exporting the drug trials, there's all the problems that people raise all the time, that the study populations won't have some of the other relevant other diseases that affect how this treatment affects this disease. They won't have some of the other drugs that people are taking. There's a catalog of problems with taking your trials elsewhere apart from the ethical ones.
So the future doesn't look so good for the RCTs.
Well, it doesn't look good to me. I mean, the ethics committees, I hope, are getting certainly at LSE when you want to do social tests. Right? It gets very complicated about the ethics committees for doing a trial there, whether or not it's meant to find out about there or it's meant to find out about here.
Thank you for some very interesting lectures, and I would just like, I'm an economist, I would like to make some comments from the social science point of view, which is rather different from the medical trials, etc. Because we have, always had problems because it's very rare that we can make real random controlled experiments. But at present there is an extreme hype in economics that you should be doing things that are similar to that. And I think we have 3 different areas where one is that you actually make controlled experiments. For example, you look at differences in risk behavior, often with student population, etc. So that is fairly close to random controlled experiments, but still has the problem, could you extend this and apply it to other kinds of populations and student populations, etc. But perhaps more interesting, you have this area where you're doing experiments, and where, for example, Esther Duflo is one of the main figures who've actually pushed a lot to do controlled experiments in development, economic development situations. And she is trying to do things with, development projects, etc. And I think it's very good in the sense that you can learn about what's happening. But at the same time, I think she is actually doing the things that you are talking about, because she is not only looking at the coefficient, the betas, etc., but she is also trying to find out the embeddedness or the cake, other factors. What kind of areas are these experiments taking place in? And for example, if you look at her recent book, Poor Economics, she's also making a lot of interviews. And also, as interesting as the positive results when you get the effects you wanted, or the results you get when you don't get the effect that you wanted, because that makes you go into the underlying social culture, the culture of the poor, and find out why did it not work the way we expected it to work. For example, your Bangladesh case is. So I think it's very good that you're doing this, but at the same time you have to use these other kind of methodological approaches to understand what's going on and the character of where they are taking place. Another area which is presently also in economics...
But before you go on, because I'll forget, because I've already got 2 comments. Okay, but wait, hold your third. First, I tend to be popular with suddenly with some of my economist colleagues because I actually think that I can prove that certain, with the right kind of background knowledge, you can get equally good causal conclusions out of econometric by econometric analysis, and that's econometric analysis on population data, not on study data. And it just really depends on how much background knowledge you have. But in some cases we have background knowledge, and demanding that you do only RCTs. The Campbell collaboration, if you look down the list, standard econometric methods are nowhere on the list. I mean, it's not that they go down through really, in a sense, very, very bad attempts to do statistical comparisons between one group and another, where you've got no control at all over what the confounding factors are in the two groups. And they don't even have econometric analysis in it. And most of the medical people I know never heard of it. So one thing is, I think that there are powerful tools in economics, is only if you're allowed to use background factors. That's the first thing. Second thing is, I don't actually believe you about Duflo. I mean, on the one hand, yes, I mean, she's a serious person who's really there and gets in. I mean, all the Jamil Poverty Action Lab people are on site and really cares. My friend Angus Deaton, whom I work with on this, says these are the good guys, right? But the story about we have to do RCTs, and then if you look at the RCTs, most of them are really, really flawed for internal validity. The demand that you do them, given they're very flawed for internal validity, and you need all this other work, and the other work has got no manualizable rigor to it, that's, I just can't buy that you should be pressing. I mean, of course, other things being equal, it's always nicer to have another study in RCT, but the suggestion here is we should. Well, actually, she does say, right, the World Bank should only fund things that have been RCT'd. And that seems to me a mistake.
Yeah, I would say that's actually on the agenda in Sweden today, because the Ministry of Development is going out saying that all Swedish development aid should actually be result-based. So if you interpret her in the terms of what we've been discussing here, she's actually demanding that all Swedish development aid should be based on RCTs, which I think it's not going to work, and it would demand enormous things. So I don't think that is. So I think that's been an oversell definitely in this area. The other thing about economics is that, in terms of the old econometric techniques, what everybody's looking for now is trying to find situations where we have so-called natural experiments. And there again, I'm fairly skeptical, and it's sort of, to me, is the character of, where you've mislaid your keys and you're looking under the street lamp. So it's only under the street lamp. So there's only in certain areas, certain time periods, when you change the Swedish school system in the early 1950s, etc., where you can find these street lamps and natural experiments. So again, I think there's been a misplaced emphasis on only being sort of allowed or being published if you're doing these natural experiments, and sort of scoping out the old econometric techniques, which I think still has a room, because they can cover more time periods, they can cover whole populations, etc.
Yes. So I also worry about that because not only is there the problem that you then investigate just the cases where you can find the right characteristics of the instrumental variable or the right characteristics for a natural experiment, but then you have the problem that we started with, which is that's always on the non-target population. It's on, as you said, something that happened in Swedish schools in 1950, and surely things have changed. The tyranny of method here is, I think, really having a bad effect. On the other hand, I do want to keep stressing, I really do believe in this story about the argument theory of evidence, and that if you're using more conventional econometric methods, then, and you really want to draw causal conclusions, there are going to be some pretty strong premises about other causal factors at work, whether you've included them all in your study, whether they're certain independence in the error terms. Anyway, there are different ways to get causal conclusions out of an econometric model, but they all require strong input. And now that's not a reason at all to throw them away. It's a reason to do them and to make clear what the other premises are, so that you can hedge your bets. But that's exactly what's happening with these RCTs. They're done as well as people can do, and they're hugely flawed. So when you're trusting that you've found out a causal conclusion from them, you're also you're betting, and you should hedge your bets. But it seems to me that it's very odd to. It's very odd to only find out the results, the kind of results that could be found out by a particular kind of method because you like that method, when there's a lot you can find out by other methods. Okay.
So I have a question about the causal concept that you assume.
Johannes, I'm sorry.
Yeah, no.
I have to move. I can't. You're exactly where I'm looking at the light.
Yep. So the causal concept that you assume for instance, in the effectiveness argument, and it leads to problems that's quite obvious when you look at premise 2 and 3 with external validity. So I guess the Einer's condition concept of causation is very good in combination with RCT, because you can prove causation, you can get internally valid causal conclusions fairly easy with that kind of causal concept.
Yes.
But then on the other hand, that's not the only causal concept available. You could have selected another causal concept which perhaps would have made it much more difficult to prove causation by using RCT, but on the other hand might have simplified the picture when it came to questions of external validity, for instance. For instance, if you had adopted a union causal concept.
A union causal concept?
From David Hume,
oh.
Where causes are sufficient for their effects. There is a law. Of course, you cannot prove that kind of causation by doing a randomized controlled trial, but if you find it, then you will have no problem going from one country to the other, for instance, because
yes, absolutely, and that you don't have to have a causal concept. If you've got an absolute regularity that holds everywhere and every when, it doesn't matter whether it's causal or not.
No, but it could, my point is, it could that could have been what we meant by causation, and it was once upon a time. But now, for some reason, we have another causal concept more in line with
we have a causal concept that's both weaker and stronger, because it's you don't assume that it has to be a uniform regularity. There could be, you could have probabilistic theory of causality that I'll talk about next time. And also, in my view, right, you can have very local causal principles, and I think I understand in many cases why those local causal principles hold. I know why I call them causal. I'll talk about that tomorrow. But I have another causal concept, which is the concept of a causal capacity. And a causal capacity is something, if you know about it, right? A mass, I'm going to use this example tomorrow, but a mass, it attracts other masses no matter what else is going on. Right? But you can't find out about that, as you say, in an RCT. Right? But then how do you find out about it? Well, you do some RCT, you do something that's the equivalent of some experiments, but how do you find out that it makes this contribution everywhere? Well, that was hard science. But it is a different, I agree with you. My view is that it's a different causal concept, and it's really important to make clear that it's a different causal concept because it has both different, it requires different methods to be entitled to attribute a capacity or a Humean regularity than the ones that we typically do in the social and biomedical sciences. And also, you can draw different conclusions from them. And in particular, both the Humean absolute regularity and the causal capacities, you can draw conclusions much more widely. So I agree. There are a lot of different causal concepts. That's just what I'm going to talk about too tomorrow.
Okay.
I mean, exactly that. I'm going to say, look, there's causal laws and there's capacities, and I'm not going to talk about Hume, but we can...
Okay, then we end it.
Okay, thanks. Yeah, it was very interesting, this question that you brought up about whether we should mechanically follow a manual, or whether we should trust trustworthy people, both in science and in other areas of life. So, well, there seems to me to have been many attempts to mechanize science. So the inductivism, that seems to be one such an attempt to create an inductive logic. And the randomized controlled trials, that's another attempt to mechanize science. So many of these attempts, they have failed, obviously. But still seems to me that hasn't this drive towards mechanization of science also done much good? That, I mean, you can go too far in the other direction also to just assume that, well, the trustworthy people, they are really trustworthy. But
well, yeah, the trustworthy people have gotten their knowledge that they're trustworthy about from somewhere. Yeah, so...
So, yeah, so what's your general picture of this? I mean, my take would be that, well, this notion that we need some rules in science, there's some truth to that, even though, well, we can't have that rigorous rules as some people might have thought, but yeah.
Well, I think you can imagine, I waffle. I think that you need, that if you have rules, they have to be very abstract. Otherwise, they simply bind you to do things which don't make sense in special cases. You see that in bureaucracies all the time. But if they're very abstract, then you're back to there not being a rule about what constitutes the concretization of the rule in this case. So it's just like geodesics. Right. You don't rules have to be expressed in the language of geodesics, not in the language of Euclidean geometry, or else the rules will just give you bad results in new cases. But you have to figure out what's the right level, and then you're still left to the nice thing in physics. Very putatively, it's not true, but the nice thing that's supposed to be the case in physics, that is in the old language of Hempel, is that the theories have internal principles, like F equals ma, and then they have bridge principles. And F is a very abstract term, force, but it tells you exactly, given a situation, what force function you can write down. So there are rules, putatively, rules in physics that tell you when you're at this level of abstraction how to get back down to the concrete case. I can write GMM over R squared if I've got two masses. I can write Q1, Q2 over R squared if I've got two charges, etc. I say geodesic, and I know sphere, great circle, geodesic, Euclidean plane, Euclidean straight line, etc. In those cases, it's not a problem that you write the rules in an abstract vocabulary, because you've got rules for how to climb down the ladder of abstraction. For most cases, as in doing scientific method or legal cases or regulation, you don't have those. So you inevitably going to have either get inaccurate results or rely on judgment at some point. And that's just, again, the human condition, I think. But I think it's a problem, as I understand it, this is a problem with regulation and laws in general, right? That they need to be interpreted. Yes.
So my background is in biology and not in philosophy, but so what I'm wondering is, because in many clinical trials in medicine and how people interpret them, they often interpret them that the effect is the effect in the treatment group minus the placebo group. And as a biologist, to me that doesn't really make sense, because I'm thinking that the placebo enables the effect of the drug, or that they are in fact interacting. So in what sense do you think it is correct then to say that the effect of a drug is the effect of in the treatment group versus or minus the placebo group?
I agree with you that if there's a placebo effect, it's very likely that you're getting the the treatment group. I mean, that's the point. The treatment group isn't getting just the treatment; it's getting whatever we mean by the placebo effect. It's getting the two of them. This one's only getting the one of them. If there's a difference between the two, you think it's got to be due to just the treatment. Of course, it's interacting with the placebo effect, but that's the reason you want to subtract off the effect size from the placebo group.
So these enabling factors that you're talking about, are they additive or are they not additive?
In the RCT, the W's, I don't have I'm not allowed to use the board. In the RCT, right, when you calculate the treatment effect or the effect size, the W's cancel out, because you're getting the average of W in the treatment group, the average of W given X, and the average of W given X prime. Randomization is supposed to make W and X independent of each other, so you've got the average of W on both sides, and they subtract out. So the confounding factors that are relevant to the measure of the effect size are the ones you said, the interactive ones, the betas, which are formally interactors. Thank you. Again, today, some of the things I want to say, I think, need to be said in just the right way, so I'll read the bulk of what I'm going to say today. Yesterday, I talked a lot about RCTs. Now, RCTs establish causal laws, and that's what everyone agrees. Now, if you've ever participated in constructing or evaluating an RCT, or even just seriously thought about social science method and biomedical science method, you know that RCTs are hard to get right. And it's no easier to establish causal laws with other methods. It's not any easier to get it right with other methods. So knowledge of causal laws is hard to come by, and it's expensive. Yet we make enormous efforts to obtain it. So what's the use of knowing causal laws? I always suppose that knowing causal laws helps us to change the world, in a very immediate way. We can read off from the causal laws ways to manipulate the world to achieve the effects described in the laws. Nor have I been alone in this supposition. It is, I think, at the heart of the now very trendy manipulation theories of causality. Okay, but this assumption is mistaken. And that's been devastating for me, because I started this enterprise at the beginning of my career when you weren't allowed to talk about causality, and I began to do so because I thought that causes were effective strategies. So I've been devastated to recognize that they're not. Okay. Knowledge of causal laws cannot play this special role, and today I will explain why. But first, I have to give a very, very, very lengthy explanation of what causal laws are, okay? Because we're philosophers, and we do really want to know if we're going to evaluate this. Okay, so I will also then provide one special case where causal knowledge can be used in the way envisaged, and that's the case where we know about capacities. You can also use it in the way we envisage. when nomological machines are at work, and that's what I'll talk about next time. Okay, now causal laws, as I see it, have a number of specific features. The first is they are population situation relative. They describe relations that hold among quantities in a particular kind of population and particular kinds of circumstances, though this relativization is often left to context, to supply. The second is the primacy of singular causation. The causal relation, and this is my reading on them. Some of the things I think it would be odd for there not to be universal agreement about. Some of the things are my way of making sense of it, and some of the things that are just my way of making sense of. If you can make sense of them in some other way that still gets the things that I feel we have to agree on I don't really mind. Okay, but I think that really we should take singular causation as primary. The causal relation reported in so this gives us something, the understanding of what causal laws really say. The causal relation they report is not primitive. It's not an abstract relation between universals, for instance. Rather, causal laws describe what singular causal processes will or can occur in the specified circumstances. And then, in keeping with the fact that a causal law reports what singular causal processes will or can occur, a causal law picks out at least one complete set of causes. The specified set is enough to produce the effect, and nothing more need to be added. And that's the work that's done by the equality sign. Remember, I've written down a paradigm causal expression for a causal law, CP, the causal principle, and it has an equality sign in it, and that the right-hand side is enough for the left-hand side is what you see in the equality sign. That it's causal is what you see in that little C that comes in front of the equality sign. Now, the laws may be either deterministic or probabilistic, okay? And there are factual effects. So causal laws specify what effects will obtain when the specified causes obtain. They do not describe counterfactual effects that would or could obtain were the causes different from what's specified on the right-hand side. Now, this may sound odd to stress, but it's something that Jim Woodward's manipulation theory doesn't agree with. Okay. Nor do they presuppose that the specified causes are produced in any special way. Okay. It's just if it tells you that when you've got the causes on the right-hand side taking their values, that causes the effects on the left-hand side. So they don't presuppose that the specified causes are produced in any special way unless that is stated in the description of the situation to which the law is relativized. Because after all, they're all populations and situation relative. So consider CP, right, the one we've been looking at. And imagine that CP works in S. So CP says that in every individual unit, U in S, whenever alpha of U takes the value A, beta of U takes the value B, X of U takes the value little x, and W of U takes the value W, this causes Y of U to take the value, this causes Y of U to take the value A plus BX plus W. I think that's fairly straightforward, okay. Now, this account of causal laws has a number of virtues. So let's look at the virtues. First, it tells us what causal laws say, which is something hardly anybody else does. Okay. A lot of people give some criteria that causal laws should satisfy, but they don't actually tell you what causal laws say. Now, it tells us what causal laws say. Many contemporary treatments of causality in philosophy of science do not do so, including common versions of the probabilistic theory of causality, related Bayes-Netz theories, and some versions of manipulation and invariance under manipulation accounts. consider the probabilistic theory of causality, and let's just look at yes-no variables, which is the way it's often treated. Okay. One fairly good attempt at formulating a probabilistic theory of causality says this: C causes E in a test population K for situation S, if and only if in S the probability of in S holding K fixed, C raises the probability of E. Okay. So what's K? Okay. A test population, K represents any test population, and a test population is any population or any situation in which all the other sources of variation in the probability of E are held fixed barring C and its downstream effects. Okay. Okay, so if you manage to hold fixed all the other causes of variation in E, when C changes, the probability of E changes, then C must be responsible for that, and we think the only way C could be responsible for that is that there are singular causal processes going on in which C's are causing E's. Okay. Now, if you take this as relativized to test populations, it's relativized not only to situations but to test populations. Okay. If you want to, my view is, I would say C causes E in S simpliciter if it does so in any test population in S. Okay. There are various ways you could do it. I mean, you could say that if there's some test population in S that this is satisfied, it causes E, or it has to do it in every one, and those are just variations on how one uses the term causal law. The way I use it, that if C causes E in S, if it doesn't any subpopulation, in any test subpopulation, has the effect that it can be both true that C causes E in S and C causes not E in S, because in one test situation it could cause it and another not. If you don't like that, you could ask that it do so in all, and there have been many variations on that. We're not really doing probabilistic theory of causality today. Okay, so what's important here is that there are at least two understandings of this theory. Okay. What's important is that the first one explains, on the one hand, we can see it as an answer to my question about what a causal law says. The law C causes E in S on this probabilistic theory, not my theory about singular causation, but on the probabilistic theory of causation, C causes E in S says that the probability of E given C and K is greater than the probability of E given not C and K for some test population K, which is a subset of S. Okay. On the other hand, okay, we can see the probabilistic theory of causality as providing a sufficient condition for the truth of a claim that says something else more immediately about causation. And that's what I try to do when I talk about singular causal processes. I offer an account of what the law says in terms of singular causings that will occur in the long run, because we're doing probabilities. Then I show for various kinds of causal systems that when the probabilistic theory is formulated appropriately for them, the increase in conditional probability is indeed sufficient for the related causal laws to be true, where I mean the causal laws that say this, that certain singular causal happenings will happen, I mean, ones that start with C and end with E, and actually tell you what the probability of that is. Now, these two understandings of the probabilistic theory can also help make clearer my concern that we should, if we can, offer an account of what causal laws say. Many discussions nowadays settle for describing some central characterizing features of causal laws. And that's been the game in philosophy of science for about over a decade and a half now. Often these descriptions themselves refer to causal laws, as in the probabilistic theory, right? Because here in the probabilistic theory we're told that C causes E just in case it increases the probability in a test population, and to tell you what a test population is, I have to refer to the other causes, which means the other things that occur in the antecedents of causal laws. So if you thought of it as a definition of causation, it would be circular. I mean, it really does define causal laws using the notion of causal laws. That doesn't mean that it's not an interesting characterizing feature that restricts the notion of causal law dramatically. So often in these descriptions refer to causal laws. In this case, the descriptions cannot serve as proper definitions. That's not the concern I'm raising, however. What I want to know is what a causal law says, and what it says could very well include something about other causal laws. Okay. Now, the account I offer of causal laws is empiricist. Oh, sorry. I'm continuing the virtues. The account I offer of causal laws is empiricist in what I take to be the most important sense. That's stressed by Otto Neurath. Sorry, I suddenly realized I don't have a picture of Otto Neurath, and since he's my hero, and I've got pictures of everyone else, and you'll see, I don't know why he's not there. Okay, well, the account I offer of causal laws is empiricist in the sense stressed by Otto Neurath. It is this worldly. Causal laws do not describe relations between universals, nor structures behind the happenings. They describe what happens in this world when the causes are instantiated here. This account of what causal laws say also dovetails with a panoply of our most favored methods for testing causal laws. Not just RCTs, but also various statistical methods used in econometrics and other social sciences, the Mark method, controlled experiments, and tests looking for invariance under controlled interventions. I take this to be a strong argument in favor of this interpretation of what causal laws say, since it is essential to good philosophy and to good scientific practice that metaphysics and methodology march hand in hand. So when I tell you what causal laws say, that should march hand in hand with seeing why the methods we use to find out about them are methods to find out about just what I've said they say, and vice versa. So metaphysics and methods should march hand in hand, or there's something wrong on one side or the other. Okay, so either the scientists or the philosophers aren't doing their job right. Now, my worry is that, contrary to expectation, causal laws cannot provide the kind of information we need to predict what will happen as we attempt to change the world. For this reason, an account of causal laws that meshes with methodology matters, since we seem to assume that what we establish with our best methods for testing causal laws is knowledge that we can use directly in this way to change the world for strategies. And much of what I often now, I think in the last few months, have been talking about strategy by pun. So you establish something you call a causal connection, and then you believe that if you got some word like cause in a premise, you can draw some inferences about strategies, right? But you never make sure that the very thing that your method will entitle you to assume is the very thing that your inference requires in order to be a good inference. So just because it's got the same words like causes in it, we're just making the bridge by pun, and that's a bad idea. Okay, and a rich metaphysics will. It's a rich metaphysics that usually allows you, that makes for the bridge, and most of the metaphysics that's built into our doctrines about causality won't do it. Okay, so let me turn to what I'm going to add-on accounts versus intrinsic accounts of causal laws. So there, it's not just me. This kind of worry about causal laws is something that a lot of people have cottoned on to from different directions, and there are fixes for it. Not everybody. Oh, goodness, I'm sorry, I need to go back a minute. Virtues, before we leave virtues, because I realize I've, back on the characterizing features. I realize I left out an important one. So we had that list of what about causal laws, and one of the ones the really important one I've left out is that causal laws are in most of, I think in the domains where it's appropriate to use the terminology, causal laws are responsible for any regularities that are obtained other than by just happenstance of finite frequency accident. And that's whether they're probabilistic regularities or universal Humean regularities. Either they are themselves just enactments of the causal laws, or they're due to the operation of causal laws. And this is a really important fact about methodology, because a whole lot of our statistical methodology, right, it looks at regularities, it looks at correlations, and then you reason backwards from correlations. You don't take correlation to be immediate mark of causality, but basically once there's a correlation, a real correlation and a probabilistic dependence between two variables, we look for a causal story that lies behind it. And you see this, for instance, in Bayes-Netz's methods, where it's just assumed that if there's a cause-effect relationship, there's a probabilistic dependence between them. And if there's a probabilistic dependence, if they're not themselves cause-effect of each other, then there's some causal story to be told, like they have a joint cause in common. So it's an important feature of causal laws that they're responsible for and you can derive from them, a full set of them, any of the regularities that hold by law. Okay. Now, let's go on to fixes on the problem that causal laws do not provide effective strategies. Economists, at least from the time of J.S. Mill, have worried about the usefulness of causal laws for policy prediction due to their instability. Okay. There's J.S. Mill. Mill worried about naturally occurring variations in both background arrangement of causes and in the underpinning structures that support causal laws. Okay. Early econometricians and more recently Chicago School economists like, Robert Lucas, worry about the likelihood that active policy intervention can undermine the structural arrangements that support the causal laws. So Lucas's picture is that there, and you'll see this again tomorrow, that there's that what's really going on in the economy is agents, rational agents interacting on their preferences in the face of technology, fixed or not fixed, but given technology and changing technology and what he calls exogenous shocks. That's what's really going on in the economy that gives rise to a lot of macroeconomic regularities, which are genuinely causal laws. It really is the case that the antecedent, like the Phillips curve, that rising for a while it really was true that rising inflation causes lowering unemployment levels. But as soon as the government, says Lucas, as soon as the government tries to use this causal law to improve unemployment, okay, they break the underlying structure that makes the causal law hold in the first place. So this is the kind of worry that economists have, that the causal laws that these underlying structures give rise to are genuine causal laws, but we can't use them. Right? They're okay. So. Now, the worries I raise here about the usefulness of causal laws for policy predictions echo worries about the stability of causal laws by economists. To explain my worry, I shall review a few further recent accounts of causality that aim to provide central characterizing features of causal laws, focusing on accounts that treat economic causes, since it's these accounts that are most alert to the problems of fragility of causal laws that worry me. Okay? Begin with a probabilistic theory of causation, which provides a provably sufficient condition for the designated cause to appear in a true causal law. I mean, that was what for a given population S, focus on some particular test subpopulation K, so we can repress K in the. Sorry, let me back up. And I will repeat what I said. The probabilistic theory of causation provides a provably sufficient condition for the cause to appear in a true causal law for the effect, where causal laws are understood in the way I described. Okay. So I can do a little representation theorem. You'll notice I do a handful of representation theorems to show that. Now, I'm not going to show that, but I want to show why you might think that if you believed in the probabilistic theory of causality either as a sufficient condition, as I say, or you actually believe that that's sort of how what causal laws say. I mean, that's what a causal law is just something, a shorthand way of telling you that the probabilities increase in the right places. Okay, it looks as if the fact of this probability increase is really good for our ability to use causal laws. But it's not, and that's what I want to show you, is don't be misled. You might not, you didn't even get so far, maybe people who haven't done this before to have gotten misled. But so let's look at this. For a given population, oopsie, okay, for a given population S, okay, we're going to focus on a particular test subpopulation K, so I can repress K and we don't have so many symbols in the equations. Okay. Now consider what use we can make of this knowledge of this causal law, that C causes E in K. What use can we make of that for policy predictions about the effects in K? Okay, let's see. Well, let's back up. So what use can we make of this about the effects in K on E of changing C? That's what we think we're going to do. Right? C causes E in K. We'd like to get more E or less E, so let's change C. That sounds like a great policy. And the probabilistic account of causality seems ideal for providing an answer. So here we are. Increase the probability of C, and the probability of E will increase, because you can just, this simple formula here is, this is true simply by definition of the conditional probability. So if you increase the probability of C, the probability of E should go up. Okay. That looks good. Okay, so if the probability of C increases, so should the probability of E, supposing that the probability of E given C is bigger than the probability of E without C, which is what the probabilistic theory of causality demands. Does everybody see why you might, you're happy with that? No? Yes? Okay. Now, that's the idea, but it's just not true. Okay. The formula is for, this formula up here, is for a given probability measure P. Okay. The probability of C, P of C, cannot change, right, without P itself changing. And if P changes to some new probability, P prime, okay, the fact that the probability of E given C is greater than or not C under the old measure P determines nothing about the relationship between P prime of E given C and P prime of E given not C. Okay. So knowing that C causes E in K, and hence that the conditional probability there, under where P holds, does not help us predict the effects on E of manipulating C in K, because that means that as soon as you start manipulating C, you've changed from the old probability measure in which that was assured, that the one probability is higher than the other, but as soon as you actually change the probability of C, you've destroyed that probability measure, you've moved to a new one, and God knows what happens. Right? Okay. Now this is exactly the problem that one of my heroes, econometrician David Hendry, is concerned about. As with the probabilistic theory of causality, Hendry focuses on the conditional probability of the effect on the hypothesized cause, P of E given C. His primary attention is to cases where C is what he calls strictly exogenous to E. I'm only going to tell you what that means so you don't get fussed. You don't have to know what exogenous means. It's the add-on that he makes that matters. But it has to do with statistical estimation. It means that the conditional probability, the one we're interested in, P of E given C, can be estimated without attention to the marginal probability of P of C. So, now, but for the relationship between C and E to be causal, however, Henry requires what he calls super exogeneity. Okay? P of E given C must be constant across the envisaged changes. So if it were constant, of course, the conclusion we wanted in the first place would hold. So what he does is he just says, he doesn't accept the probabilistic theory of causality, which doesn't have this built in. He just says, look, I'm not going to call it causal. Sorry. I'm not going to call it causal unless something else is true. You've got a stability of the fact that it is causal. I mean, that's all. Requiring that P of E given C be stable across the changes, that just is, you know, if it was, so that if it was bigger than E given naught C before, it'll be bigger than E given naught C after. That's just another way of saying, if you hold the probabilistic theory, that it just is stable. We're not going to call the causal law stable, call something a causal law that satisfies the probabilistic theory for being a causal law here. We're not going to call it a causal law unless it happens it's also a causal law here. Okay. So that's why I call it an add-on account. Okay. P of E given C must be invariant across, but for him it's across the envisaged policy changes. C causes E does not count as a causal law unless the conditional probability remains fixed across the manipulations envisaged to change C. So this is an example of what I call an add-on account of causality par excellence. A criterion that's sufficient to guarantee a causal law on its own. Remember I said the probabilistic theory of causality is provably sufficient for being a causal law in the sense that I outlined. Okay. So a criterion that is sufficient to guarantee a causal law on its own is provided, as I indicated, the probabilistic theory with its emphasis on P of E given C is provably sufficient for a causal law to obtain. So you start out with a criterion that's sufficient, and then invariance is added on as a second demand before the label causal is allowed. Okay. One can, of course, quarrel with my account of what a causal law says, insisting that the account is not complete until invariance is added on. Okay. But recall the demand for a connection between the content of a causal law and our best methods for testing causal laws. The additional invariance requirement is not part of our standard methods from the Mark method through Bayes-Netz's methods to RCTs. Okay. Now, James Woodward also has an add-on account. For Woodward, okay, two demands must be fulfilled for equations like CP to be labeled causal. The first he calls level invariance. The equation must remain invariant under changes on the right-hand side variables by intervention. So you've got a causal law, effect on the left, causes on the right. If you, by a kind of David Lewis kind of miracle, you change one of those causes, don't change anything else, just at the last second you change one of the causes on the right-hand side, then the equation should remain true. That is, you know, E should take the new value, right, that's dictated by the new value of C. That's level invariance. That's a really good test for causation. Okay. Intervention, as I said, is something like a miracle from the Lewis account of counterfactuals, a change that affects nothing other than the causes and its downstream effects. Woodward defends this account, this condition on causality, with examples in which it is violated by relations known to be spurious. So how does he defend that this is a necessary and sufficient condition? In level invariances, well, he doesn't say it's necessary and sufficient, I do. But how does he defend it as a condition? Right? He looks at cases where well-known counterexamples to call the things that aren't causal laws and shows it fails. That doesn't actually show that it's a condition on causality. What we want to know is whether all spurious relations violate it. Okay? Is level invariance a sufficient condition for causality? Okay? And I prove a representation theorem, again another representation theorem, more complicated this one, that shows that it is. I begin with some axioms that a set of causal laws should satisfy, and that they do satisfy on my reading of them, like asymmetry, irreflexivity, and then the thing that I neglected to put in my list, that any functional relations that hold are generated by genuine causal laws. The theorem shows that any functional relation generated by a set of causal laws will be one of those causal laws if and only if it's level invariant. So something is a causal law, okay, if and only if it satisfies level invariance under these handful of axioms for causal laws. Okay. I don't go all the way back. I mean, those axioms are satisfied by what I say a causal law says, but you don't have to go all the way back to my reading if you're happy with the axioms. So if you've got another reading, as long as you assume asymmetry or reflexivity and the assumption that any functional relations are generated by causal laws, I can prove that level invariance is a sure marker that an equation represents a causal law. But Woodward doesn't think so. Okay. He demands more. Okay. Okay. He demands what he calls modularity. And modularity says that there must be some way to change each variable in a causal law without changing anything else except downstream effects. So essentially, what we show is that what I can show is level invariance is that if you were to change it, the E would change in the. If you were to change it by a miracle, if you were to change any of the causes by a miracle, the effect would change in the right way. What Woodward requires in addition is, and moreover, you can change every single one of those causes in the right way. Okay. Now, why? Well, Woodward is clear. This addition allows us to. You can change it in the right way, and since the thing is level invariant, the cause it stays the same. Now, why? Woodward is clear. This addition allows us to use the law for manipulation. Okay? That is, I mean, it tells you now you can change every one of these by miracle. So, if you've got a miracle to hand, you can manipulate any of the causes to produce the predicted effect. Okay? Now, that's why I take it Woodward calls his account indifferently an invariance account and a manipulability account. Now, as an answer to my worries, I think that this is, and it's an add-on account, right? I mean, level invariance is sufficient for causal law, but he won't call it a causal law unless you can actually manipulate it without breaking it. Okay. Now, as an answer to my worries, Woodward's add-on is far less satisfactory than Henry's condition. For it underwrites the use of causal laws for predicting outcomes, not for manipulations we envisage making, as with Henry, but interventions which are very special kinds of surgical incisions. Okay. Note, though, that, so the only time you could ever use, you're ever guaranteed you could use one of these laws is if you've got this really, really special way of doing it. That's kind of David Lewis' last-second miracle intervention to change the cause, which is not the way we ever do it. Okay. Now, you should note, though, that these kinds of surgical incisions, these miracle interventions, are the kinds, essentially, that are demanded in an RCT. So what Woodward is really getting from his modularity condition isn't actually genuine usability of the law doesn't provide us with strategies, but what it does ensure is that the law is testable, because you can actually change every one of the causes and see whether or not the effect changes. Okay. So he just confuses, I think, usability and testability. Now, even if modularity did ensure usability, it goes no way to showing that causal laws are useful in themselves. Level invariance already provides a sufficient condition for an equation to represent a causal law. Modularity, like super exogeneity, is an add-on. Now, to reinforce this, turn to an account of causality offered by macroeconomist and methodologist Kevin Hoover. Okay. Now, Kevin Hoover, I like Kevin Hoover because manipulation theories are all the rage, and Kevin Hoover is the only person who's got a real manipulation theory, I think. Okay. So Kevin Hoover, and he has an account that is not an add-on account. Hoover defines causality directly in terms of the effects that can be achieved by manipulation. So this is Hoover. C causes E if and only if anything we can do to fix C partially fixes E, but not the reverse. Now that's a manipulation theory of causality. Now, although this definition secures a connection between causation and manipulation, and it does so with no add-ons, the kind of relations it calls causal would not count as causal in everybody's books. And here's a simple example. So just assume that the black arrows, I've actually given my book on causation a little machine, right? That of which has, you know, real machine description as real machine components, where the black arrows are mechanical causation. You know, you push that and the next thing moves. So the black arrows are mechanical causation. Okay. And we can manipulate u, ux and uz. Now, given that, and that's all we can manipulate, given that anything we can do to fix y fixes z and not the reverse. So y Hoover causes z, which doesn't bother me because I can manipulate y to manipulate z. I mean, it happens inside the machine. X is getting manipulated as well, but it gives you the right outcomes about what you can do with manipulation, but it's not what everyone would call causation. Now, I don't mind because I'm a causal pluralist, even though I've told you the story about causal laws and what they say. That's only actually one of the various accounts of causality I would countenance with different ones for different purposes. But it's one I would do with causal laws. Okay, so anyway, here we are. Okay. Now, the dotted lines are Hoover causes. Now, Hoover does not need add-ons. Hoover causal laws, by their very nature, provide predictions about strategies for manipulating the world. But many will not want to allow that Hoover's is an account of causation at all. Okay, so this is just a contrast, an add-on account with one that really just goes for it directly. So what's wrong with adding on invariance assumptions? Well, we could add it on as an additional requirement for the use of causal laws. Okay, so one thing is these guys, Woodward and Hendry, they want to add it on before they'll call something a causal law, something that I think we have every good reason to call a causal law in the first place. They won't call unless they have add-on invariance. Now, I'd be happy if you added it on not to what you meant by being a causal law, but if you added it on as a requirement for the use of causal laws. Something like this. Warning, do not use this product for predictions, for predicting the consequences of manipulations without ensuring that it is invariant under those manipulations. Okay. But I think it would be a bad idea to add it on as a requirement on the truth of causal laws, and that's for a number of reasons. Okay. As I stressed, this would break the connection between the metaphysics of causal laws and our standard methods for testing them. Of course, we could throw out our standard methods for testing them, but then we'd have to have something call something else the stuff that our standard methods test. Okay. It relativizes the concept to the manipulations under which it is supposed to be invariant, okay, the add-on account. It breaks with standard usage of the concept of causal law that we put to other purposes. We want to know about what I call causal laws for systems that are shaky, where attempts to manipulate the causes may undermine the laws. Snowflakes and spider webs, undiffusible bombs, and old-fashioned children's toys that break if wound up too tightly. And also for systems that we never intend to manipulate, nor never could manipulate, like the processes in the sun that produce light and heat, the planetary system, and the innards of my car engine and computer, where I firmly intend never to go. Okay. Now, once we allow, another reason is once we allow invariance to be added on, causal knowledge seems to have no special role at all. Remember, we're doing all this expensive stuff to get causal knowledge, and if you don't call something causal unless you've got invariance, it turns out that causal knowledge has no special role, okay? Because any claim that's invariant under a proposed manipulation of some factor will provide correct predictions about the results of manipulating that factor. Okay, so if you've got invariance, you don't need causality. Look again at CP, and suppose it is functionally correct, but is not a causal law. So take away the little c over there, so this is going to be something that's functionally correct. It's not a causal law, it's a spurious correlation. Okay. If we insist that the functional relation be invariant under a particular manipulation before we call it a causal law, but let's not think about causal laws, let's just think about invariance itself. If you're going to insist that a relation be invariant, let's insist that this relation that's not a causal law, I should have taken the C out, this relation that's not a causal law is invariant. If we insist on invariance of the relation, then imagine that it's supposed to be invariant under a particular manipulation, say of W. Now, whether the equation expresses a causal law is irrelevant to what we can predict about Y. I mean, if I say this stays true as I vary W, well, it stays true as I vary W, and I can use it to predict what happens to Y as I vary W. It's trivial. So if we insist on invariance of the relation, any relation is as good as a causal relation for predictions about results of the manipulation. And if we do not insist on invariance of the relation, causal relations have no guarantee to do the job. Now, none of this would be so critical if causal laws tended to be invariant, if they were always invariant or almost always invariant as a matter of empirical fact. But they do not. That follows from my observations. Causal laws are both fragile, they break readily when we try to use them, and they are local. Very different causal laws hold in different circumstances. I think we can do far better if we focus instead not on the frequency with which causal laws are stable, but rather on what kinds of situations make for stability and whether we can recognize them. So I'm going to give up altogether on the idea that causal laws, as causal laws, are invariant. They're most useful to us when they're invariant, so when are they invariant? And not just say, oh, most of the time, or enough of the time, or I'll just bet on it this time. I think there are actually cases where we know that they're invariant. And so I start with capacities, and I'm not going to tell you much about them, but I mean, that's the job for today, is to finish with talking about capacities. Capacities, unlike causal laws, are what I call capacities. Other people call causal powers, and I use the word capacity when causal powers were really, really, really out of fashion a long time ago. And there was so much kind of bad press for causal powers and so many different views of them that had been done in the past and nobody would think about. I made up a new word, which was capacities. Capacities, unlike causal laws, by their very nature, they give us levers on the world. If a cause has a stable capacity, it will play the same causal role in different circumstances. Remember last time I talked about causal rules because RCTs results only travel if the cause plays the same causal role in the new situation as it did in the old. So if a cause has a stable capacity, it will play the same causal role in different circumstances. So it can appear and in the same form in a great variety of different causal laws. Now, the concept of a causality or of a capacity characterizing capacities is twinned with that of a contribution. Capacities are identified by the contributions they make. They are matched one-to-one with their contributions. They are thus what metaphysicians, I think, nowadays call single-track causal powers. If X from our causal law, CP, has a stable capacity to contribute Bx to Y, then we can rely on X to contribute Bx to Y across a variety of different circumstances governed by different causal laws. So all the different causal laws will have Bx in them, but they could well have, or will have, different alphas and different W's. Some won't have any W's, some will have just totally different W's. But if X has a capacity to contribute this to Y, then this will appear in a huge variety of different causal laws. Gravity is a prime example. So masses of size m have a stable capacity to contribute a force of g mm over r squared to the total force on another mass regardless of what other kinds of pulls and pushes the other mass is subject to. So no matter what other kinds of causal laws are true of the object, mass will always contribute, make a contribution of this size to the total force. The total force is the effect here, y. Now, knowledge of capacities and their contributions helps us to change the world. A capacity, when properly triggered and not interfered with, will produce its associated contribution. Except some are probabilistic, and that's an aside story, okay? So when a cause has a stable capacity, we can reliably predict what difference it will make, regardless of what else is going on. The relations between capacities and their contributions have a number of important features then. Okay? Invariance is built right in, not added on. Okay? Sorry. They are not fragile. They do not break easily under the manipulations we make on them. And it is in the nature of what a capacity is that it produces its contributions no matter what else is going on. Okay. We have good empirical reason to think that this is a category that applies in nature, and that the good empirical reason comes from all of our analytic sciences. So physics and economics all work on the analytic method. You find what a cause does in isolation, and you assume, you try to find that about those causes such that what they do in isolation is what they'll contribute elsewhere, so, like the force of gravity. Okay. So I think we have good reason good empirical reason to think that capacity is a good category to use to describe the natural world, and moreover that capacities are common in nature. They're not universal, but they're common. Okay. We know that we can get reliable knowledge of them, though not by using just the methods for establishing causal laws. That was the point. Causal laws are something different. These have invariance built in. They're a totally different kind of beast that we study in different ways. Nice thing about them is we can make use of them. They provide the tools to build what I call nomological machines, which I'll talk about next time, which are structures that give rise to causal laws. So new machines give rise to new causal laws, and by identifying machines, we can tell when a causal law is stable. Okay. And that's what we'll do next time. Now, or, that's what I claim. But, can we make use of them? Recall how the scientific revolutionaries made fun of the Aristotelian powers of their predecessors. So here's a kind of conventional dialogue from a scientific revolutionary making fun of an Aristotelian scientist. What makes heavy bodies fall? Gravity. Oh, well, what's gravity then? That which makes heavy bodies fall. You can see this in the old documents. Okay, so the connections between capacities and their contributions are not enough to allow us to predict what happens under manipulations. To do that, we need to have some way of ascertaining when a capacity obtains and when it doesn't. You've got to have some way of telling a capacity is there other than just by sitting around waiting for its effect to happen. Otherwise, it's not any use to you. Okay? Now, so to make use of capacities, as I claim we can, we need to have some way of ascertaining when a capacity obtains and when it does not. But nature has been good to us. Okay? For many capacities, we do have just this kind of information. Hard won, but we have it. Mass, which we can independently identify as a feature, is associated with the capacity to attract massive objects. Negative charge with a capacity to attract positive charges, and with a capacity to repel negative charges, etc., etc., etc. Physics is rife with these, and economics purports to be. I mean, if you could take seriously what they do, it would be rife with capacities too. Capacities can be useful to us just because, in many cases, nature supplies secure ways to recognize them. There are features that we have independent methods of identifying that guarantee the presence of the capacity. Okay, what is central for my purposes here about capacities are the two facts I've described. Okay. Capacities reliably produce their contributions when triggered, and for a vast number of capacities, we have learned how to tell when they are present and when not. They are associated in a systematic way that we know about with features we know how to identify independently. Together, these two facts guarantee that we can make reliable predictions about what differences will result when we manipulate the capacities. Now, that's the end of what I was going to say about capacities formally, but because we had this yesterday, I've added on a bit that will bring us full circle. Here we have Esther Duflo and Anujit Banerjee. They're big movers in the Jamil Poverty Action Lab, which is located really centered around the MIT Economics Department. They're hugely influential. There's good bet Esther Duflo is going to win a Nobel Prize in economics next time around. As I said, they're the good guys. They really care about development. They argue that we should be doing small projects because we can figure out what the effects of small projects will be, etc. They are very keen on RCTs. Okay. World Bank should not do any project, fund any project that's not had a successful RCT behind it, as if somehow that means it will work the next time. Okay, so I distinguish in looking at this literature and evidence-based policy between three kinds of causal claims. It works somewhere claims, general claims, and it will work here claims. RCTs establish it works somewhere claims. Okay. We want to know it will work here. And it sure looks as if the conduit is through, they think, is through general claims. They just kind of think it's a default that if it works somewhere, it works generally, so it will work here. Okay. So let's just have a look here. Duflo and Kremer. Second paragraph of a paper. I wasn't cherry picked. I just found this. Use of randomization in the evaluation of development effectiveness. That's the kind of paper, of course, I wanted to read what they had to say. The benefits of knowing which programs work extend far beyond any program or agency, and credible impact evaluations can offer reliable guidance. Okay. Well, which programs work seems to me to mean it works in general. Impact evaluation, that's all about, we talked about that last time, that's it works somewhere. Reliable guidance is, it'll work here. And we flow seamlessly from one to another. This is what I meant by inference by pun. Okay? This is strategizing by pun. Okay. So think about laws versus capacities. It plays a causal role there, here, somewhere. Okay, that's a causal law claim. Okay. It plays a causal role widely is a claim about that there's a relatively stable capacity to produce the related contribution. I mean, they don't actually think you're going to get the same effects, but that every time you introduce this cause, it'll make the same difference. I mean, every situation, they admit, does have lots of other factors going on. So the W's will be very different, so there'll be different causal laws, but they think, every time you introduce it, it'll make the same difference. That's the hope, right? That's a capacity claim. Okay. So, but the problem is, right, that the causal laws that are established, they're fragile and local. We saw the case of Bangladesh versus Tamil Nadu. I mentioned Lucas, who says you can break causal laws easily. Okay. Now, RCTs establish causal laws, but for generality, you need capacities. Okay. So, conclusion, causal laws are fragile and local, and for generality, you need capacities. Thank you.
Thank you very much. First of all, I am as anti-human with respect to causality as you are. So whatever you think of my remarks, they have nothing to do with any effort to defend Hume here. Now, you've really been into both physics, economics, and medicine. But I'm a bit suspicious that you seem to me to treat them all alike. I have two comments to make. The first is that you wrote that all causal laws are situation dependent. As I have learned, they speak about causality in medicine and economics. I would say yes, but you seem to bring in physics as well, and then I can't follow you. If it could have been the case that Newtonian mechanics were true, then well, his laws are to me completely universal. The third one, action equals reaction, each and everywhere at every time. Second law, resultant force on a particle with mass m equals the resultant acceleration. And I can see that you must regard many universal laws in quantum mechanics as non-causal laws. But are you really prepared to say that Newtonian mechanics, not even that, if true, contain situation-independent laws? That's my first question.
I'm, in fact, prepared to say it, and I have said it, and that's part of what's the argument in the book called The Dappled World. But let's not, you don't have to be...
I know the book a little.
Yeah, well, so let me back up. In Newton's law, like the F equals ma, I think that I think I can defend that, contrary to what many people claim, it is a causal law. It tells you that when a force is exerted on an object of mass m, that will cause it to have an acceleration a. And I think if you don't give it the causal reading, then you don't get the power out of it that's necessary to justify the uses to which we put it. So you can't actually build the machines we do with it if you don't take it as a causal law. So I'm like you, right, I have to take it as a causal law. And in that case, it might be, you don't have to be as radical as I am. One could just say there are some, right, invariant causal laws. Most causal laws that we run into and use all the time are not invariant. And it's because they're not invariant that we have this problem. And I actually think most of the ones that I really understand and aren't invariant, I can explain the nomological machine that gives rise to them. I mean, I can explain, what they depend on. Right? So if I went along with you that Newton's theory is really true, pretend it's really true, and also could it be universal? Absolutely, could be absolutely universal. I happen to think that none of them are. Right? But okay, and then you could the situation relativization would be you would just write the word anywhere there, but I want to leave it in because I want to call all those other things causal laws where there's a more restricted domain. So I mean it's just a trivial fact that if you say it's relativized to situations, you're entitled to sometimes let the situations be anything.
Okay.
So,
yeah. Okay. The second question, if I understand, has to do with now medicine and economics. Yesterday you talked about RCTs, and then you continue today and mentioning them a little. But if I understood you right, all the people that you referred to were economists, and therefore when you talk about causal criteria and so on. But in medicine, some people have put forward similar list. Hill is the most famous, I think. I wouldn't regard them as neither necessary nor sufficient, but they are used and called criteria. So how can you be so sure that what economists say about the social sciences, also about the economy, is applicable with respect to the RCTs of medicine? I would...
okay, well, about the RCTs, I can be confident because you can try to construct for yourself what... I mean, here's the job, okay? So I've got two two things I want to say. The first is, let's think just about RCT. Here's the job. What does a causal law say such that RCTs could possibly be the gold standard for finding it out? Okay. And if you take causal laws to have the characteristics I ascribe to them, then RCTs are provably, in the ideal, and an ideal RCT is provably a good way to find out about causal laws in the sense I say. Okay. That's about RCTs. About other methods, it turns out that actually econometric methods are provably good for finding out about medical causal laws. Provably good. Now, what about Bradford Hill? Well, Bradford Hill gives a lot of criteria that he says are, I forgot what the words are, but you're not to take them as either necessary nor sufficient, but they're things you should look for. And if you've got a lot of them, you should assume it's, if you don't have them, if you fail to have many of them, you should. But some of them are that the effect is big. Well, we know very well that that can't be a necessary condition because there are causes that produce little effects. So Bradford Hill has a kind of set of conditions, and half of the conditions are, I don't know whether literally half, sorry, I'd have to go back to the list, but a large number of them are conditions that I can prove are either necessary or sufficient for causal laws and that look like CP. Okay. The other ones, I think, you can see why they'd be rough indicators in some circumstances. Like this thing about being big effects. It's not a sign that something's a causal law. The role it plays for him really is that if you do something like any kind of statistical method for finding out causes, okay, it's very, very difficult to, you have to have a huge population if your effect size is small. I mean, so if the cause only makes a small effect, then it's very, very much more likely that you'll get a small effect size by accident if you've got a small population. So some of the criteria that Bradford Hill states are, okay, some of them are reasonable, some of them are either necessary or sufficient for causal laws in my sense, some of them are things you could see why they, under the right conditions, would either be necessary or sufficient, if this particular case satisfies certain assumptions, and some of them, like the large effect, that the effect should be large, are ones that don't have anything to do with actually whether it's a causal law or not, but whether or not our conventional methods will, given the size of the populations we normally have, be good for finding it out. And Bradford Hill is very, it's very often cited now. And the evidence-based medicine people are going back to looking at Bradford Hill, because they're trying to loosen up a bit. And so it wasn't. The side conversation should be. It's about something that's really at the moment very important. I did all that technical stuff. There's got to be some objections to that. There has to be some objections to. I'm waiting for Bengt to say something back there.
Now, you mentioned determinism and deterministic laws, probabilistic laws, and okay for me, good. Both are there. But then, in another way, you talked about, as is necessary, about manipulating factors and manipulating factors that affect laws when you talked about this Phillips curve. Now, for me, the word manipulation brings in something beside determinism, deterministic laws and probabilistic laws. And many philosophers think so, namely agency. And what's beneath me and my suspicion that can you really move as easily as you do between economics and medicine has to do with this fact that, well, if you take the body goes on, but economics is very much about agents. You see what I mean?
No. Sorry.
Put it in this way, simple way then. For me, we have some kind of free will. We are free agents, and therefore there is an aspect in the social sciences that is missing in the natural sciences and in part of medical science.
I agree with that, and that's why I think an awful lot of causal laws are, I mean, that fits naturally with thinking causal laws are situation relative. So there are certain kinds of not only social but physical causal laws that hold in the situation where I don't exercise my free will to come along and mess things up. So there's no problem there. What happens in the economics cases where these guys who are economists don't have agents with free will. They have agents who are absolutely determined by whatever it is to act rationally and greedily, and that's how Lucas gets his models to work. He's got a rational expectations theory, and the agents aren't. I mean, they're just doing willy-nilly. They've got a set of given preferences, and they just do what it takes to maximize their expected preferences in the face of their expectations about the exogenous shocks in the technology. Now, that's one reason why I think probably economics, I don't believe in rational choice theory or rational expectations. I'm very wary of, sometimes the models are right, but like you, I'd want to, before I bet much on them, I'd want to really look at the model, see the situation, and so forth.
Okay, so I mean, this is completely a completely confused. I don't even know if it's a question, but could we go back to where you talk about these capacities?
Yeah, that's why I got the. It's so small.
Yeah, I think you should just continue. This one and then down one, I think. I guess.
Is that one okay? At least
I think so. I think this one is okay. Yeah, it's coming. So, I mean, I just want to know more about these capacities because I'm not really sure I understand the difference between these causes in the causal laws and then the capacities. So, when I was sitting here, perhaps this is completely wrong, I was thinking that in the causal laws, we are on a different level of description, you might say. So it's like some of us metaphysicians would say that when you go to the capacities, you go to the truth makers for the, or something like that. But could you say something more, first of all, about that relationship between the causal laws and the capacities? Because maybe it's just me, but I wasn't.
No, I think when you're if we're thinking in the formal mode, that it's just a different level of modality. That ascribing a capacity is very different kind of modal form than whatever it is to be a causal law. Right? And that you might, you can write causal laws out. I mean, let's just take a causal law, and then C can the cause can contribute something in this situation that you could never expect it to contribute in another situation. Mothers contribute to the education of mothers contributes to in Bangladesh, in Tamil Nadu, to the infant's nutrition, but educating the mothers does not contribute. Produce the right contribution in Bangladesh. So it's not the case that every time a cause is part of the overall story about why the effect is the size it is in one case, that's because that cause, you can take what it's doing there and think, oh, it'll do that everywhere. That's a very special case that it'll do that everywhere. And that's the thing for which the label causal power is reserved, or I reserve.
For that which happens in a particular situation?
No, that when what happens in one, this is not a definition. I mean, it follows from the notion of a capacity that what it contributes in one situation, it will contribute in all of them, or all across a range. That's just not true of causes in general. So,
it's just like a subset of the causes, and then you call those causal powers because they are invariable?
Well, I don't think that causal powers are a subset of causes, but that's partly, depends on one's ontology.
Yes. I think my question is a question on ontology, actually, because...
Well, a property, I mean, here's an ontology one you could have. You could have properties, and properties the obtaining of a property can be a cause. Okay. So the obtaining of educating the mother, in this case, was part of one of the causes that produced the child's nutrition. Okay. So that's a feature in the world. Okay, it's a feature in the world, and it's when it occurs in this situation, it does cause something else. So it is then appropriately labeled a cause, or it is a cause. Okay. Now, I would say that it brings with it, or not, a causal power. So but some people think that properties are, you can't think that properties are, I would say it brings with it a causal power.
So a causal power is not the same as the instantiation of a property then?
No. Causal power...
It's a separate category?
It's a separate category.
That comes along with instantiations of properties?
Yeah, so one of the things, and it might be, so this is a dispute that metaphysicians worry about, is if you've got two categories, you've got kind of inert properties, whatever those were, whatever it was that Hume was supposed to have and that David Lewis believes in, and John Ehrman and those guys, that you've just got these inert quantities, qualities, factors, you've got these inert ones and they don't have any causal powers. Well, I think that there's another category, there are causal powers, and that in the cases I know about in science, where you want predictability, right, we talk about the causal powers when we can independently identify a property that they're always associated with.
So, so then I have a question, then I'm going to...
Can I just finish
that?
Sorry.
Yeah.
Okay. So, I don't have a doctrine about whether their, causal powers need always to come with properties. Right? Some people think that they're, they have to, and then they try to ground them in them, and I think that I think is a mistake, and I can argue against that. But whether or not you always need I just think we don't know. That's an empirical question for me. What I do know is that there are some things what I do believe is there's some things I know, like having the property of being negatively charged always has with it the power to attract, the capacity to attract positive charges. Having the property of being a mass has the property, have a gravitational mass has the property of attracting other gravitational masses. Okay, so that, yes, now you wanted to ask.
Yeah, so then just a small question, because if you go to the literature in metaphysics, because it sounds to me like you have causal laws that are not, necessarily successful, so to speak. They can fail. But once you have the power, there is this reliability, as you say. So it will perform. If you have identified a causal power, then you go somewhere else and you find that causal power again, you know what it will do if you poke it,
Yes.
It will do it. So there's a kind of success story behind the causal power that's not the case for the causal laws. But this doesn't really square well with some of the things that metaphysicians say about causal powers, because they seem to think, the causal power theorists seem to think that causal powers are precisely the sort of things that have the capacity to do X, but necessarily they don't have to do that. They can be... So that they are not, in this sense, these success machines.
And I think that they're mistaken. Well, I think there is something we have good reason to use this category, and that the masses always attract. Okay. Now, so there are two remarks. Right? One is that one of the reasons I call the capacity view a causal power view is because I think Hume wouldn't like it. Because Hume said it doesn't make any sense to make a distinction between the presence of a power and its exercise. Okay? So he thinks there's the presence of the cause and then there's the presence of the effect. But I've got three things. The presence of the feature that brings, the presence of the capacity, the presence of the power, the occurrence of its contribution, and the observable effect, the effect in the set of features that Hume would admit. So, you know, when the object is accelerating downwards, when the Earth is pulling it downwards, the contribution of the Earth to its downward acceleration is there. The contribution of the magnet is there, and the bloody thing isn't moving. Okay. Now, you can try to save Hume by saying, yes, it's moving up, but it's moving down. But there are more complicated examples with circuits and things where which you can only make sense of, I think, if you say, look, there's the power, there's the contribution, and then there's what I call manifest result. But usually powers people get confused between whether the manifest result is what I call the contribution or the observable or the Humean, the feature which occurs in David Lewis's world. Right. So, sorry, now why did I say all that? It was to explain why I think it's one way in which it's a causal powers view, is that it lets in things that I think if you're Humean you really ought not to have in the world, because they're and moreover, okay, another feature is that if you do it the way I do it, which I do in order to make sense of our powerful results in science, if you do it the way I do it, then I identify the power with its contribution. So there's an analytic connection between them. That doesn't mean that it always produces its, but the power it is defined by, back and forth by its contribution. It isn't gravity unless it makes heavy bodies fall. So I do exactly what the scholastics say. Now that doesn't mean that it would have to be the fact that gravity, if gravity has to be the kind of thing whose contribution is making heavy bodies fall, it doesn't mean that it always has to, the fact that there's an analytic connection definitionally between what the power and what the contribution is doesn't mean that it always has to make that contribution. But in fact, I think we have cases in science where it does. But then I don't know if you noticed, but at some point I said, I hedge for Finkish dispositions and all that a power, if properly triggered and not interfered with, will, and I think many things like mass don't need triggering. They're hard to interfere with. I don't actually think that most of the cases are really interfered.
I think I was confused by the fact that it produces contributions despite what else goes on.
The what else is going on is that gravity is making its contribution even if a magnet's pulling it up. But if you genuinely think it could be interfered with, it won't do it if it's interfered with. So the formula is capacities, when properly triggered, produce and not interfered with, where you can imagine that because I believe in capacities, I believe that it's not, there's a real fact of the matter about whether it's been interfered with or not. It's not, it does it unless it doesn't. Right? It's that being interfered with is a proper happening.
So things are much clearer to me now, so thank you.
Well, thank you, because hopefully that made them clearer to other people. Sorry, having challenged Bengt but I didn't think you were going to let me get away with all this stuff, Bengt.
Well, you stress the connection between metaphysics and methodology, and yet I think you haven't really touched the very heart of the metaphysical question, which for me is the real causal connection in the individual case. I'm not so much worried about causal laws or causal powers, which could be construed as sort of general lumping together of the real tricky stuff, namely what in an individual case distinguishes a genuine causal connection from mere co-occurrence. And I would like, if you would like to go back, I presume you're familiar with German Hessel's example about argument against the probability theory, about contraceptive pills.
Yes.
That may cause blood clots. However, on the statistical account, if women take contraceptive pills, the probability goes down because it screens out pregnancy, which is a much more efficient cause. Yet, in those cases where there nevertheless are blood clots, it seems indisputable that they are caused by the contraceptive pills.
Yeah.
And that has to do with what is functioning in that individual case. And if we can come to grips with that, we will, besides solving a metaphysically interesting question, we may just look at causal laws as sufficiently general clustering of the occurrence of such things. So that seems to me be the very heart of the matter that really frustrates me, that I don't understand.
Okay, so let me say several things. I want to talk about singular causings because I think that's the interesting issue, but about Heslow's birth control pill cases, this is a kind of typical thing, and just to connect it with the standard literature now. So the probabilistic theory of causality, and as Suppies did it, and Bayes-Netz theories both assume that if there's a relation, a causal relation, the cause increases the probability of its effect. Bengt has just given an example where the probability doesn't go up because the cause both has a route by which it would, if this one weren't occurring, it would increase the probability, but it has another route by which, if this one weren't occurring, right, it would decrease the probability, and the two balance out. The guys who do Bayes-Netz method say, that doesn't happen, or it has a set, it happens, then they've got some, artificial, sorry, I'm being rude. They have a mathematical argument that says it's a set of measures 0. That doesn't happen. I think it happens all the time. Kevin Hoover, I think we do it, you deliberately make it happen when, when one of these causal pathways is deleterious, then you try to do anything you can to enhance so that shows that I think Bayes-Netz, I wouldn't want to turn a Bayes-Netz, as I've tried to, I wouldn't want to turn a Bayes-Netz I wouldn't want to turn the Bayes-Netz axioms into one of those characterizing features of causality. I think they only hold in very special systems. So that's the first thing. Second, when I endorse probabilistic theory of causality and say I can prove that it fits with my reading, and my reading's got singular causings in it, so it looks like it's wrong because some of these women are caused to have thrombosis, right? And some of them are prevented from having thrombosis. The singular causings are going on, and it's not reflected in the increase in probability. If you actually look at my formulation of probabilistic theory of causality, it essentially says, look here, when you can infer a causation from an increase in probability is when all the other sources of changes in probability have been controlled for. Not just all the other causes, right? But all the other... now, in this case, we know how we can control for it. You can hold fixed something on this wing, and then this one will show up. You can hold fixed something on this wing, and that one will show up. How you might have noticed I said that at one point the way to formulate the probabilistic theory in this situation, and it will differ from domain to domain, what's the right way to formulate it. So, okay, so what I put there, right, is not the the right way to formulate a probabilistic theory of causality if you want my representation theorem to hold. It's the right way in certain systems in which you can prove the representation theorem. Okay. Then lastly, the interesting question is the metaphysics of these singular causings, and I don't have any metaphysics for them. And now I'd like to suggest that I don't need one. That the world is full of happenings like the cat slapping up the milk and my pushing the glass over, etc., that are, well, maybe I need a metaphysics for them. They're there in the world. It's not a problem that one has to say, you know, how to get this causal relation in out of other things. These causings are going on all the time. Now, why are some things that happen causings and some things that happen not causings? That I don't really have a view about. And I think that we have, there are pushings and pullings and shovings, and then there's beings to the left of, and the first ones are causal and the other ones aren't. And the pushings, pullings, shovings, droppings, etc., all have a family resemblance. Right? They involve any of those things Anscombe says. Is the Anscombe? Where's our Anscombe person? She left. I was going to get her to defend it. All right. That there are a number of rough criteria, right? But I mean, then we're on ground. I don't have a strong. I don't have a seriously defensible claim. But there are a lot of criteria. The effect comes out of the cause. There's a continuous process. There's the first makes the second happen, or is in some sense responsible for it, etc. And if you've got something on the metaphysics of singular causings, that would be great for me.
Of course, sometimes, for example, courts of law have to decide on what's the cause in a singular case, and I would like to have philosophy to have something to say when that's justified or not.
Yes.
So.
And the problem is, I wouldn't want to have to say that the thing that David Lewis says is that every time there's a singular causing, there has to be a causal law. I mean, there has to be a feature you can not you can identify, but a feature, an identifiable feature in the cause, the start of the sequence, and an identifiable feature in the end, such that those two features are always connected by causal law. I wouldn't want to be committed to that, so which is part of the point of taking singular causings first. So I've got a real problem with the law cases, but I do think we have Mark method, right? And then we do have causal laws. We can call it local causal laws that hold in this situation. You can call into play. We do have Mark method, and we do have it needs a cause and nothing else in the mystery story. I don't think you were here when I talked about mystery stories, but where Ackerley was the cause of, or wasn't the cause, I forgot, of because, but the idea was that he was because all the other possibilities have been ruled out, and there was a spatiotemporal root, and the kind of things that allow this kind of person to be the cause were their mode of opportunity, etc. I guess that means we have a lot of subject-specific knowledge about causes. People tend not to murder other people unless they have the opportunity. They tend not to murder people unless they have motive. They sometimes do, etc. Yeah.
I don't.
We can't go upstairs anyway till dinner's ready.
Yeah, that's right. So I'm just gonna, isn't causal powers among people like George Molnar and those guys, aren't they introduced precisely to deal with these kind of singular causal relations? So that the idea is that, I mean, the underlying metaphysics is exactly these particular powers. So if you can, now from the epistemological point of view, if you're in a court of law and you can prove that there is this happening and there was this manifestation, and when you look at the happening, you can actually see that there was this power and that there were no interfering factors and blah, 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 then this would actually be, very good reason to think that this is a causal relation and not a non-causal relation. Whereas if there is the power, but there are interfering factors, or there is no causal power, no particular power in this case, but there is the happening and what you could call the manifestation, then there is no such reason. So, I mean,
I was with you until then.
Okay.
Okay, those are all reasons.
Yeah.
But the idea that there's no such reason because there can be local causal laws, right? And local causal laws can be like educating the mother.
Yeah.
Is in Tamil Nadu,
yes,
right, is a partial cause of the nutrition level of the child.
So you think that there can be causal law, true causal law without any powers?
Yeah.
Aha.
Well,
that's interesting.
No, what I think is that there can be true causal laws where the cause, right, doesn't have the power to contribute what it does in that case. Now, the reason I said no is because I've got this more complicated doctrine that I was being made fun of here, quite rightly, that most causal laws are ceteris paribus laws, and they depend on an underlying structure that gives rise to them, this thing I call a nomological machine, that I'm going to talk about next time, so that, and then I think nomological machines function by powers making their contributions in certain arrangements. So the powers have to come in at a lower level in order to get most causal laws, but then when you've got the causal law, I don't think there's any doubt that educating the mother can play that causal role in that setting, and that can be a reason to think that educating the mother in this case did do it. I mean, this kid's nutrition went up, we educated the mother. Of course, that could be an accident because it's not 100% causal connection, but we have good reason to think that it was causal between the two, because there is actually a causal law, and it's causal in lots of cases in Tamil Nadu. On the other hand, if you do think that there are ungrounded causal laws, not grounded in nomological machines, then to the extent I buy that, then you can have causal laws without causal powers. So there really are, for me, two, I don't just mean for me, I mean I would like to claim that I don't just say it, but that the whole picture makes sense together as a way of making sense of science. And of course I come at it not from the way of trying to make sense of the singular causings, but trying to make sense of the science. And so I start with the singular causings and build up the powers, right? I also don't like the fact that they think that causal powers have to have grounds. I mean, the guys who want to have grounds for them, like Bird, Alexander Bird has that's what Rom Hore had. That's one reason I didn't talk about causal powers, because I didn't really want to be mean to, I didn't want to disagree with Rom, because he was the good guy. He was talking about causality. Right, but I don't think they had to have a ground. I thought that wasn't radical enough, that causal powers, they're not grounded in a causal, a factor that's then connected with causal law with the contribution.
These are ungrounded.
Yes, his are ungrounded, and lots of them are ungrounded. Lots of them, yes, and they're identified by their causal profile, which I think is a mistake. That's a story. You and I can do some metaphysics.
I agree.
Yeah. Thank you all for the discussion, which is why I came. today I want to talk about the power of nomological machines, as you see. Some of you weren't here last time. At any rate, it's always good to review. When I started my career in philosophy, I think I mentioned that it was at a time when you really couldn't talk about causality. The positivism in philosophy was at its height, and causality was very, very much out of style, whereas right now it's very much in style. And so I felt very brave when I first started writing in defense of the need to use causal language and causal concepts in science. And this is from my first paper on the subject. And the paper started with this quote. It simply wouldn't be true to say, Nancy L.D. Cartwright, if you own a Thai life insurance policy, you'll live longer. But it is a fact, nonetheless, that persons insured by Thai do enjoy longer lifetimes, on the average, than persons insured by commercial insurance companies that serve the general public. That is a quote from my first paper, but in the paper I was quoting a letter that I received, a sales letter, from the Thai Craft Company, which is the company that does U.S. academics insurance. And of course, it wouldn't be true to say that if I own a Thai life insurance, I'll live longer. But it is true that persons insured by Thai do enjoy longer lives because professors tend to live longer than the population at large. Okay, so their idea was that there's a correlation between having a Thai life insurance policy and living longer, but buying such a life insurance policy is not an effective strategy for living longer. And that's what worried me, because at the time, decision theories about what will happen were I to act in certain ways commonly used the conditional probability as a measure of what's the probability that if I were to act, I'd get the result I expect. And the conditional probability simply is a correlation. And it doesn't reflect a causal connection. So the thing we learned to say was the conditional probability is not the same as the probability of a counterfactual or subjunctive conditional. So P of R given A is just a correlation. It's true that the probability of longer life given you have a Thai craft insurance is high. But for an effective strategy for living longer, you should do something that's connected not just probabilistically with the result, but you should do something connected by causal law. That was my claim. Okay, so yesterday I told you about my despair that causal laws, I realized quite late in life that causal laws do not, after all, provide effective strategies because they're fragile. They're easy to break when one uses them. I wind up my great sadness as a child was I loved those little toy soldiers and other mechanical devices, and if you wind them up, that causes them to march or to walk or to fall off the end of the table, but not if you wind them too tightly. And the very act of manipulating them in order to achieve the desired result is very likely to break the mechanism that allows the causal principle to be true in the first place. So causal laws are fragile, as I've known ever since I was a very young child. Okay? And they're also local, as I've illustrated in particular with this recurring example of Bangladesh and Tamil Nadu and the integrated nutrition program, but there are millions of examples. Okay. Now, the other thing that I argued yesterday is that invariance is no rescue, that a lot of contemporary philosophers are very keen on invariance. They won't call something that otherwise passes all the tests for a causal law unless it's what I say is tempered, like tempered steel, so it doesn't break. So they take whatever I would take to be reasonable criteria for causal law, and then they add on invariance, but I think invariance is no rescue because causal laws aren't especially invariant. And if you just refuse to call things a causal law unless they are, it won't hook up with methodology correctly. And moreover, you need another name for the stuff that I call causal laws, which are the kinds of things that our methods are pretty good at finding, our methods that we teach in method. You know, I teach in the London School of Economics and Political Science. And there's the Methodology Institute that teaches every PhD student in LSE methodology. And if you go and watch that they teach, what they teach for how to do the methods for causal inference, right? They're the kind of methods I've been talking about, which are geared to establish what I call causal laws. So anyway, I don't think causal laws are invariant. Okay? And if invariance is added on, you don't need causal laws. After all, if your principle's invariant under the manipulations you're going to make, then it makes accurate predictions. It doesn't matter whether it's a causal law or not. Okay? So that was yesterday. Today, what I want to do is to urge that something I call nomological machines are a prime source of invariant causal laws. Okay? But coming full circle to the concerns I've had all along about, for instance, how evidence-based policy is conducted nowadays, different machines will imply different causal laws, so that you have to beware when you're trying to extrapolate from what you've seen a causal law you've established in one place to another, because you're very likely actually to be moving from a causal law that's generated by one machine over to a situation that should be modeled by a different machine. Okay? That's the story. So RCTs, beware. Okay, causes and strategies. I don't know if this is maybe no joke for people who, I mean, I have both a British and an American passport. And this is the special connection between Churchill and Roosevelt. So where is the special connection? Okay, well, what I want to say is, let's not ask, where is this special connection at, but when is there a special connection between causes and strategies? And that's what I want to argue, is that there is a special connection when, and maybe Ingvar is going to be a little more cautious about this than I am, maybe only when there's a nomological machine. But there may be some causal laws that are just causal law simpliciter. They don't need nomological machines to give rise to them, and they don't need nomological machines to ensure their invariance. But most of the ones that I see people using are generated by nomological machines. Okay. So the causal laws that support, no, I'm reading from this, I'm sorry, you're supposed not to do that, but this is the thesis. The causal laws that support our day-to-day strategies are generally, or for the most part, or often enough that you should pay attention, are the temporally asymmetric, conditionally stable input-output relations arising from the successful operation of a nomological machine. Okay. Well, what's a nomological machine? This is not, isn't going to provide you an independent way to identify it. It just tells you what it is, and it's going to circular that my claim is true of it, because a nomological machine is a stable enough arrangement of components whose features acting in consort give rise to stable input-output relations. That's all a nomological machine is, but a nomological machine has, for the most part, will be made up of components, and the components have what I argued for yesterday at the end of the hour as capacities. They have capacities to make certain contributions, and in the machine arrangement, the contributions combine to give rise to the output. Okay. So long as that's, of course, depends on the machine running properly, and if the machine runs properly, then the causal laws it generates are stable or invariant. And they depend on the machine staying intact and running. Okay. So, example, this is one I try to make use of almost every day. Dropping a piece of bread and pushing the lever causes a piece of nicely browned toast in that machine. Okay. So, this sequence has the earmarks of a causal law. Okay. And it's invariant. I mean, if this isn't a causal sequence, I don't know what is. I put the toast in, and it causes and I put the bread in, and it causes, it's part of the cause, right, of a nicely browned piece of toast 2.5 minutes later, and it'll pass any number of RCTs or any of the other methods that they recommend you use, and it will moreover pass a physics experiment. So I think this is a good causal law, and it's invariant. So long as we push the lever on the toaster and not the lever on the floor of my car, which makes the car go faster. Okay? The toaster, and it's invariant so long as the toaster is intact. And intact means indeed also being plugged into the wall, and having in Britain the electricity needs to be turned on and off at the wall. So when I give this kind of talk to visitors, I always have to remind them that being intact goes all the way through to being plugged into the mains and having the switch on. Okay, so the sequence not only has the earmarks of a causal law, it is a causal law, and it's invariant, and it provides an effective strategy. Pushing that lever on that machine is a really, really good way to get a piece of brown toast. So the causal law is, but the causal law is local. As I said, it's local to that machine. Pushing the lever elsewhere, pushing the lever on the playground will raise children at the other end of the seesaw. Right? It won't produce you a piece of toast. So this causal law is local to and guaranteed by the toaster. It's because of the structure of the toaster that the causal law obtains. And okay. So here's another machine that we're all familiar with, and it gives rise to this other causal law that I've been alluding to, that if you step on the lever on the floor of my car or the floor of your car, that causes the car to accelerate. And again, it's a causal principle that's invariant so long as the structure of the car is intact. And there's some other causes. It's like plugging the thing in. You might think that plugging the toaster in is one of the helping factors. And here you might think having petrol in the engine is one of the helping factors. But at any rate, having all the helping factors in place, including stepping on the throttle, causes the car to go faster. And it's this machine, right, that does that for you. Okay. Here's another one. Naturally occurring machine, not one we built, nasturtium seed. And if you take the nasturtium seeds, helping factors that I talked about yesterday, you add water, air, warmth, and light, you get nasturtium seedlings. Okay, that's a causal principle. Nasturtium seeds plus water, air, warmth, and light at the right timing causes seedlings to germinate and start to grow. And that's guaranteed by the structure of the nasturtium seed, and it's going to be true so long as the structure is intact. Okay. Now, here's a question that's worried me for a long time and that I've ducked. I always say things like the machines give rise to causal laws, they generate them, the causal laws depend on them, but what kind of a relationship is this? Okay. That relationship is causal, and on my account at least, and you might have a different account, it means that the causal law that describes that is really talking about singular causal happenings. That if you water these nasturtium seeds, that will cause seedlings. If you water those nasturtium seeds, these will cause seedlings. That regularly, if nasturtium seeds are watered, that causes seedlings. So I'm not so worried about that, but what's this relationship? It's not causal. I mean, it's just not the kind of thing that can figure in a cause. Now, when I've talked about problems of fragility of causal laws, some of my colleagues get really cross, and it's mostly the Bayes-Netz colleagues. So there's Clark Gleamore and his group, and they think that, and Judea Pearl, and they really don't want to hear about anything you have to use other than Bayes-Netz methods. And Bayes-Netz methods really are very sophisticated ways of causal Bayes-Nets methods are very sophisticated ways of making use of probabilities to infer causes, on the assumption, of course, that I mentioned yesterday, that every time you get some kind of a regularity, it has to have some kind of a causal explanation. But they don't like the fact that I say, well, exactly the same problem with Bayes-Nets methods that you have with RCTs. When I'm talking to RCT people, I say, how come you don't use Bayes methods? But when I talk to Bayes-Nets people, I say, both you and the RCT guys have a problem of your laws being local. And you're doing a great job at establishing it works somewhere, but you mustn't act as if by doing that you've established it's going to work here. Here, there, or everywhere, that this is universal. They don't like that, so they say, what's happened is your equations are misspecified. Right? So the equation that has a variable for the seeds, the water, the air, the warmth, for the water, the air, the warmth, the light, and the seeds, and has a variable over here representing whether there are seedlings or not. That equation really should have another variable in it that talks about the structure of the nasturtium seed. So you just kind of up this into the antecedent of the causal law. Now that I just think is again, since I've got a view about causal laws, I think that's crazy, because you now have something in your causal law that you can't attack by any of the methods we use for testing and establishing causal laws in the natural and social sciences. It's among other things, these guys all talk about probabilities, and they have to be dealing with a variable set over which they put a probability measure. And there is no probability measure about what the probability of there being that kind of machine, or this kind of machine, or this kind of machine. There are a dense infinity of dimensions of machines possible in the world, and this just makes no sense about having a probability measure over them. And moreover, the relationships between the machine and the outcome are just different from the relationships between the putting the bread in, or stepping on the throttle, or the water, air and warmth. And for instance, if you can't use any of those probabilistic methods, you don't use Mark method, there's no transfer of energy, or whatever you think the transferred quantity might be if you've got a process theory of causality. So it's just a bad idea to try and think of this as a causal relation. So what then? Well, I said I always just ducked it, but I've been working with a colleague who has a simple answer, because he's been reading the other so-called mechanists, both my colleague Bill Bechtel and Mackimer, Darden, and Craver, MDC as they're called, and they have a view of mechanisms as being structures, as I do, but they're not so worried about causal laws and stability as I am. What they're very keen about is getting activities into the world. And what they have is a view in which the machine itself goes through a sequence. The machine itself engages in activities and goes through a series of states and ends up in a final state. So my colleague John Pemberton and I have written a paper together, but all that's interesting in the paper to me is his idea that he's solved my problem, I think, okay, because this is how he puts it. So what happens in the machine is that you have a change process. Okay, you've got the original arrangement, and then the start arrangement is it either just starts of its own, or it's triggered, or you put in an external, and as we say, exogenous input, like the bread, and push the lever. So I'm an exogenous input and push the lever. So you start the machine starts somehow, and the various capacities that the features of the machine bear produce their contributions, which in the arrangement of the machine combine and give you an end arrangement. So the machine arrangement provides a context in which the capacities of all the parts exercise. Okay. It begins in the start arrangement, and then each capacity produces its canonical contribution. The contributions combine, and the overall change is a combination of the contributions in this context. It's what he calls a change process. That's not now very surprising. So there we are as the okay. So when the capacities exercise, arrangements change into new arrangements. And that's what's going on. Okay. So here's a number of examples. You've got a simple pendulum start arrangement. The change process is the bob exercises its capacity to attract or be attracted by the earth. The string exercises its capacity to pull the bob towards the pivot, and the bob moves around. Okay. So, among other things, the arrangement matters. It's not just that you've got a bunch of parts that have capacities and you throw them together in a bag. It does matter a lot about the arrangement, and that's another topic that we can go into, but it's not the topic for today, but it's an important fact about nomological machines. In this case, the contributions made by each of the parts we can think of in terms of them being component forces, and they combine in this case. There's a well-known rule of how contributions combine is they add by vector addition, and we might, right, if we wanted to do a more realistic example of a real pendulum, have a machine that has more detail in it and in which you get damping and so forth. Okay. Here's another one. Okay. And the reason for bringing this in is that just to make clear to you that this is a familiar phenomenon. Everyday empirical learning also uses change processes. Like children learn to blow toy boats, toy windmills. They learn to fly kites, to recognize washing on the lines, trees being blown around, etc., etc. And there's a change process story here. So the wind exercises its capacity to push blowable things. The blowable thing exercises its capacity to catch the wind and move. And together, we've got movement of the blowable thing. So we've got a start arrangement. The capacities exercise. That's the activity, right? The capacities exercise. They might do so. As I said, they might need triggering. They might not, but they just exercise. The contributions are produced. The contributions, the simultaneous occurrence of the contributions in the arrangement they're in constitutes the end arrangement, the activity. The end arrangement. Okay. So the capacity of the wind to push then has a stable contribution here. Okay, and then having learned that, the child learns that and then can extrapolate, and you can use that stable capacity of the wind in other reasonably similar nomological machines to get reasonably similar results. So one of the things we learn is we learn sort of simultaneously about what kinds of things carry what kinds of capacities, and also what's actually going to happen in certain kind of circumstances, because those circumstances are like a nomological machine and they repeat. Okay. Another example, I'm not going to go through all of these examples, a toilet cistern. Here you have, I wanted to use the toilet cistern one though because I've been talking about start arrangement and end arrangement, but it's a continuous sequence, and you can think of it, you can divide it conceptually into a large number of steps. And we usually do in these mechanical devices according to sort of known rules of combination. So when the handle is turned, the lever pulls up the lift rod, which opens the outlet valve, which releases water from the cistern, which lowers the ball cock, etc., etc., etc. You have this change process from start to finish, and it gives rise to the ordinary, everyday observed rule that if you push the lever on the toilet flushes. Okay. So it's a neatly sequenced exercising of capacities. The contributions of each component combine in the machine arrangement to produce the change process, one step after another. Okay, so that's a nomological machine. Here's another one that I don't really understand, but John and my colleague John does, and I have a student, Adam White, who's working on this. They both use this as an example. So I'm sorry, I've given you an example that I don't understand, but it has the same structure. Just so you know, I've got the nasturtium seed. You realize it's not a matter of actually, and the wind. It's not a matter of actually machines like the toilet system that are the toilet cistern that are made out of what were classical machines, levers, pulleys, etc. Now, okay, so then how, I've answered the question, but let's just summarize. How machines give rise to causal laws is the start arrangement turns step by step into the final arrangement. And the basic singular causings, if you're going to use this approach to thinking about causal laws, then the basic singular causings would involve the whole arrangement. Here's what happens. The start arrangement causes there's a continuous evolution, but the start arrangement causes the next one, the next stage, which causes the next stage, which causes the next stage, which causes the end. So you've got a singular causing, and and then the basic causal laws. These are only basic in the sense that since what's happening in a causal law is the causal law is a description of what kinds of singular causings happen regularly. The basic causal laws will describe these singular causings, okay, but then we've got a sequence of basic singular causings, and that of course means there'll also be regular sequences among aspects of the arrangements, so things you focus on. And then these get described in further laws. I mean, the whole machine is going through a series of stages, but we can focus on some aspects of the start arrangement and some aspects of the end arrangement, and those will be regularly associated through this causal process. So we can describe those in causal laws as well. So there's no, these further causal laws, they're just another way of describing, leaving out a lot of information, the basic causal laws. Okay. So we focus on aspects when we write down causal laws that we find salient, and especially the reliable input-output relations that are good for manipulation and prediction. I gave examples of really mechanical machines and biological machines. There are also, but they're more, what do you call it, easily to be intruded on, socioeconomic machines. That we do have a great number of social regularities that arise from the structures of our society, the socioeconomic cultural structures of our societies. And it's because of the structure of society in Tamil Nadu that educating mothers about nutrition and ensuring they have supplemental feeding for the children improves childhood nutrition there. And it's a different structure of the society in Bangladesh, and that's why educating the mothers doesn't work in Bangladesh. Now, about socioeconomic machines, just I do study a lot of economics, and a good number of economic models, particularly economic models in theory, are simply blueprints for socioeconomic machines. You build a model and derive in the model that some causal law obtains. It obtains so long as the kind of structure that's described in the model obtains. And then you can, of course, ask, does this structure that obtains in the model look anything like anything in the world, so that you could expect the causal law that's described to appear. So, for instance, the models tend to describe how agents and institutions interact to give rise to these causal laws. Think about Lucas's rational expectations models. I mentioned Robert Lucas, Chicago School economist, who is responsible for a lot of the Republican views, or he backed up a lot of Republican views over a number of years. So it's maybe a bad idea to cite him, but he had the logical structure is very clear. What Lucas says is that, look, the government should not intervene. Why? Not just, because we all should be free, but because the government doesn't know enough to intervene. The government, when it intervenes, has got to rely on some established causal laws. And they, what do? They look around and they look to see what causal laws you can establish using our ordinary methodology. And you find a bunch of them. But what happens is that when the government wants to manipulate the cause, right, there's no way for the government to manipulate the cause in those laws without breaking the machine. And so the very law that the very causal principle, the very regularity the government's depending on, right, to predict the outcomes of its manipulations, no longer true when it manipulates. So that's his story. And he defends this by producing a number of rational expectations models for some of the principles governments have relied on for manipulation. And a rational expectations model talks about, sorry, there should be an apostrophe in the agents. But the underlying structure is one in which he describes agents' tastes and technology and exogenous shocks. Exogenous in this case means they're shocks that the agents can't predict. And given the assumptions he makes about agents, how they act, given their preferences, the technology, and these exogenous shocks, basically they act so as to maximize their expected utility. Given this assumption, he derives, for instance, a Phillips curve. Okay? And the Phillips curve is the standard curve, standard line that gives a trade-off between inflation and unemployment. And there was a long period when observational data supported the Phillips curve, and that governments did try to use inflation as a lever for manipulating unemployment, for improving unemployment generally. And that's a good idea, because what you can do from this rational, it's a good idea. It sounds like a good idea, because what you can do, if you just look at what I've said so far, is he really does have a rational expectations model in which he derives that the Phillips curve holds as a causal principle. I mean, he wouldn't say a causal principle, but I say that. But what happens is that in the model, it really depends that these are exogenous shocks, that these are not predictable. And the claim is that as soon as the government's going to manipulate inflation to control unemployment, the changes in inflation are predictable, and they're recognized by these hugely intelligent agents as the price rise they're seeing is not being a price rise, so they're going to get more for their products, but just inflation. And then they act differently, and the Phillips curve breaks down. So that's the story. Okay. So rational expectations model is one of these blueprints for a socioeconomic machine, and it's supposed to be a real story. Okay. Now, why should you believe in socioeconomic and nomological machines, apart from that I've just told you a really plausible philosophical story and given a lot of, I hope, examples to win you over? Well, one thing is because science is actually concerned with them. Okay? So look here. Here are some of the core activities of science. Once you begin to think of the core activities in terms of nomological machines, a great deal of science is devoted to identifying arrangements. So you identify arrangements like identify nasturtium seeds, right? So you can predict the local future. Identify the planetary system and its structure, or the neuron, which is what I said I didn't understand, how you identify the structure and the arrangement in the neuron in order to make local predictions. But I do understand how, by understanding the structure of the cistern, I can predict that the toilet will flush. Okay. So we put a lot of work in science into identifying and understanding arrangements of what turn out to be arrangements of what I would call nomological machines. We put a lot of effort in science and technology and in social engineering, though probably not enough in social engineering, into constructing arrangements. Okay? That's in order to control the local future. We do that when we want to test theories, as in laboratory experiments, but we also do it, as we've seen, in everyday machines all the time, in toasters, cisterns, etc., etc., etc. We put a lot of effort into learning how you can intervene on arrangements in order to amend the local future. For instance, we fertilize crops, or we genetically modify those nasturtium seeds. And we model. A lot of the effort in science is in modeling the arrangements in order to predict and understand the causal laws and understand where they're invariant. You know, so we model the planetary system. Lucas models the economy under certain idealizing assumptions, and so forth. So I think these are all very familiar activities of science that get quite readily cast as having to do with nomological machines, and they don't. It's hard to make sense of what people are actually doing if you don't think that there are any such things. We spend a lot of effort developing knowledge of capacities. One of the things that's really important that I mentioned yesterday, particularly with Anna Sophia, I stressed it again, is that we learn markers for capacities. So we can independently identify whether something has a mass, and once we know it has a mass, we know it has the capacity to pull other objects towards it. We can independently identify whether something's got a charge, and then we know that it has the capacity, if it's negative, to attract to attract positive charges and repel negative charges. You independently identify. Well, maybe I shouldn't give any social examples because they're all suspect about what carries capacities. Okay, so we identify markers for capacities, and that's a large part of what I think science is doing. We work hard to identify the contributions of capacities and how contributions combine in various arrangements. That's what engineers do when they build new devices. It's what laser engineers did when they built lasers, is that there were some capacities that were known from abstract quantum theory from the time of Einstein's A and B coefficients, that if you get something into an inverted state, you get more atoms in the excited state than in the de-excited state. You can get spontaneous emission, but that wasn't enough because they had to learn about the capacities of certain materials and certain newly developed kinds of mirrors in order to actually make an arrangement in which they could control the local future and get laser light. Okay. Contributions of capacities, one of the things I studied in early electric theory is how various components, capacitors, inductors, resistors, how their contributions combine in a circuit. That's a sort of simple thing you learn. Okay. And you also, I don't have in the list here, but you also spend a lot of time deciding whether something, a cause, is operating only locally or whether it really has a capacity, and if so, what it is. And then we do characterize collections of things in the world as known nomological machines. Okay, so that's the one whole set of activities that we do in science that make sense if, and I think more or less only if, you think that we're dealing with nomological machines as sources of invariant causal laws. Another thing that, another aspect of science that I think really matters that nomological machines make sense of is, although I've stressed so far a lot of I've stressed so far a lot of different methods for establishing or testing causal laws. The ones that use probabilities are really what I would call that evidence. They're showing that there's a causal law there, that there are certain singular causal happenings happening. You know they're there because there's a difference when the cause is there that isn't there when the cause isn't there. There's a difference in the effect, and nothing else explains it, so there's got to be a causal relation. That's that evidence. It's just evidence that there's a causal principle. But we're not happy. I think these new RCT guys sometimes act as if they are, but in general, we gather a variety of different kinds of evidence about causal laws and principles. We gather what, how, and that evidence. So science makes use of what evidence, which involves capacities and the arrangements that can give rise to change. How evidence, which is, we describe how the cause evolves into the effect, and that evidence, which is the regularities or direct evidence that the regularities in causal principles obtain. So the what evidence is evidence about the underlying structures that give rise to causal laws. We're very happy with Kepler's laws for planetary motion because not only are they very well, do we have a lot of that evidence by doing observations of these elliptical orbits over and over again, but we can actually produce what evidence, what it is that produces those elliptical orbits or generates them or gives rise to them is the arrangements in the planetary system and the capacities of the massive objects to attract each other. So we do an awful lot of work on what evidence. How evidence is the unfolding of the causal process, and in general, it's not just enough that you have, it's not enough to really assure you, I think you've got a causal law, just to see that you think there's sufficient, that whenever the cause is changed, the effect will change ceteris paribus. You'd like to be able to see what's the sequence of continuous changes that get you from there to here. That's what you do in the Mark method, and it's what you do in process tracing, which is very common in biology. Okay? And then there's the obvious that evidence. So I think the focus on nomological machines also accounts for and makes sense of the use of these three kinds of evidence, why all three kinds of evidence are good kinds of evidence for the truth of a causal law claim. Okay, so that's sort of to argue that science does deal in nomological machines, even though, of course, scientists don't use those terms. Now, we started out talking about strategies. So I want to review why nomological machines are so useful for strategy. Because you should be a bit wary. Remember yesterday I told you about capacities, and I said, well, capacities will invariantly make their contributions. Maybe there aren't any capacities in nature, but insofar as they are, they're going to make their contributions if they're not interfered with, because that's what it is to be a capacity. Right? Now, maybe there aren't any capacities, but I reminded you of the scholastics, right, who made fun of the Aristotelians who, like me, believed in capacities by what makes heavy bodies fall? Well, gravity. What's gravity? It's that which makes heavy bodies fall. Well, gravity is the very thing that has the capacity to make heavy bodies fall. But if you can't independently identify it, it's no use to you that there's that capacity in nature. Happily, in science, we have learned that that capacity universally comes along with the feature of having a gravitational mass. Okay. So it took an additional argument to say that capacities, it's not just enough that they provide for invariances. It's not enough to make them useful to us. Right? We have to have somehow know when they're there. And same thing with nomological machines. So the nice thing about nomological machines, like capacities, I mean, God was good to us and provided at least a lot of the capacities with markers. and markers we can have come to learn about, and markers we can recognize. So for a nomological machine, we can come to recognize the machines, and we can recognize them via labels. So my toaster comes with a label on it in case I'm an idiot that says this is a toaster, not a car. Right? Don't step on the lever and expect to accelerate. So we've got labels on the ones we build, and my nasturtium seed package has, there's no label on the seeds, but there's a label on the package that says these are nasturtium seeds. So I know what they come with labels. Or there are other visible or measurable signs. There needn't be, but experts can look at a nasturtium seed and they can tell it from a sweet pea seed or a tomato seed, or because there are external visible signs that tell you that this seed has the right structure inside that when you plant it you'll get a tomato seedling, and this seed has a quite different structure inside that when you plant it you'll get a nasturtium seedling, and other people can tell the difference by looking. So we can learn to recognize the machine and what it is by labels and just by visible signs. We can come to learn and recognize the canonical input-output relations from that machine via the manual that comes with it. Push the lever. Don't expect to just put the bread in. Push the lever and then you'll get the toast. Or more complicated manuals. Trial and error, scientific study, and we also learn what endangers stable operation, and you learn them in the same way. The manual says don't immerse this in water, don't let it get too cold, don't let it get too hot. You learn about nasturtium seeds that you shouldn't store them at, in temperatures that are too hot or too cold, etc. Okay. And we learn that what endangers the stable operation, and there are very often markers by which we recognize damage. So not only can experts sometimes tell, they can't always tell if the nasturtium seed's been stored at too high or too low temperature, but they can tell if I've smashed it with my hammer. Right? So here's some examples where you can tell by looking. There are markers for damage. So here's a nomological machine, and you know it's damaged. There's another one, right? Let's return then to further reasons why nomological machines are so useful for strategy. That all had to do with really recognizing the machines, recognizing when they're intact, recognizing when they're damaged. Now, the other thing that if they're going to be useful to us is we don't just recognize that the machine is there and intact, but that we can, for many of them, we recognize the nature of the inputs that will give rise to the kind of outputs we're interested in. Because for the nomological machines that supply strategies we actually use, okay, the input causes are ones we can learn how to manipulate. So I can manipulate the giving water, air, warmth to the seeds in order to get the seeds to that whole complex to produce nasturtium seedlings. I learn that the vending machine I've got to put a pound coin in if I want to get out a bag of crisps. I've got to put the pound coin in actually and push the buttons B1. And then I get crisps, and if I push the button B2, I get a chocolate bar that I want. Okay. We learn about inputs. I mean, if we're going to actually be able to use these, we've got to be able to find inputs that we recognize, that we know how to manipulate, and moreover that we can manipulate without breaking the machine. Unlike Lucas's view about the economy. Can't manipulate the economy without breaking it. But for the machines where I think that we have causal laws that provide us with strategies, we are able to manipulate them without breaking the machine. So I don't want to say that there's no claim here at all that all nomological machines have inputs that we can manipulate without breaking the machine. It's just rather that that again, God has been good to us. Also, we create a lot on our own that have this characteristic that we can recognize them. We can recognize when they're not damaged. We can recognize what to do not to damage them, and we recognize what inputs we can do that will produce the outputs without breaking the machine. And some of those inputs are actually ones we want to do because those are the outputs we want to get. So, okay. So the conclusion is that we rely on causal laws. We often, generally, I think for the most part, for strategies rely on causal laws that are generated by nomological machines to produce predictable results. We do this because they're stable, these laws, relative to the successful operation of the machine, and that we can learn to recognize these machines and what it takes to obtain an effective strategy from them. Caution. Okay. The causal laws, if I'm right that the causal laws we rely on are generated by nomological machines, that means there's a good chance they don't travel well. Right? The causal law that holds here won't hold there. The one that holds for the toaster won't hold for the, if I step on the lever on the floor of my car. If I educate mothers in Tamil Nadu, it doesn't work in, that causal law doesn't work in Bangladesh, etc., 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 etc. Then RCTs, remember what RCTs do, they give evidence about causal laws, so they're not a very powerful tool for predicting what happens in new settings. Okay. Now I don't want to, so I'm just coming full circle now to how I got started being worried about the heavy emphasis almost exclusively on RCTs in evidence-based policy, increasingly widely, and we talked yesterday about development economics. They're fine, they're really good at establishing it works somewhere, and I don't mean to say that we can't learn that what works somewhere works elsewhere. It's just that we are now enjoined to focus over here, and we're not doing anything to discover the underlying nomological machines that would allow us to bet that it works over here. So I'm going to close with some good news, just 1 second of good news. Okay. Nomological machines give rise to invariant causal laws, and we've built a lot of nomological machines, right? So you can, if you've got an invariant causal law, I mean, here's the sort of standard trivial idea. You can jiggle the end of an invariant causal law to make changes at the other end, but you're kind of stuck with the outputs that are guaranteed by the inputs you can jiggle for that causal law. So if you want serious change, you can build new machines with new causal laws, and you can get a lot of really good builders to build them for you. Thank you.
Yes, if I remember correctly, I think in your book, The Dapple World, you defended the view that the macroscopic world can't be reduced to, or it's not even supervenient on the micro world. So when you said God had created the micro world, he had also to create the macroscopic world.
Well, he had to construct capacities for things in the macroscopic world, yeah.
So, and then your talk about nomological machines seems to be in tension with that view, because speak of components and combine, giving rise to regularities. So my question is really, why isn't that a tension between these views?
Because when I did the toilet cistern, I didn't mention anything about string theory or quantum theory or electrons and positrons. I talked about rods and levers and pulleys and chains so some of the sometimes one does. I don't want to deny that you ever have reductions. I think they're few and far between. But usually, when you're talking about when you do these machines, the components that have the capacities are more or less all at the kind of same level. If you had believed in levels, at the same level as the
as the machine
As the machine
itself,
itself.
although there are proper parts.
They're parts, yeah. Okay. It doesn't. No. Knowing the behavior of the electrons, knowing everything about behavior of electrons, if you knew nothing about any of the capacities of macroscopic objects, says me in the dappled world, right, you wouldn't be able to predict the outputs of the of the toilet cistern. Now, I mean, you know, that's a radical view. I didn't argue for it here because, you know, you can buy all this, right, without having to take on board my really strong views about there's never any cases I've seen. There's all just promissory notes, right? We can all do all this with fundamental physics, and you can't do anything with fundamental physics. The people who say that never actually look at or show you how you the models that produce predictions about, say, laser light, where you put you always put in information about the capacities of macroscopic objects, you put in Newtonian capacities, etc. And then, you know, everyone says, oh, that's only for a shortcut. You know, if only we did it properly, we wouldn't have to do that. And you know, anyway, I'll believe it when I see it.
Yeah, so, but couldn't you have the same line of reasoning regarding the molecule or atoms in relation to their parts, and that they combine into machines, and so you have some kind of reductionism or supervenience?
Yeah. So one of the, sorry, yes, exactly. And I didn't take it out for that reason. I just, John has a slide on making water out of hydrogen and oxygen. And he thinks that's a nomological machine. That I'm not sure it is. That's the reason I left it out. I mean, I didn't leave it out because it might argue against the reductive view in the dappled world. It's that I don't understand how that works, much more than I don't understand how the neuron works. I don't understand how that works because I don't quite see, just like John Stuart Mill, I don't quite see how I get the qualities of the water out of the capacities of the water, hydrogen and oxygen, in the particular combination they have. So this is part of the reason for stressing arrangement. So John thinks that you can get the capacities out of, there's something about the capacities in that arrangement that allows, you know, that machine to go through that process that ends with all those characteristics of water. And so if you, I'm just speculating, right? So my co-author, he thinks that's a case where there's a sense in which you can do a reduction. The problem about the reduction is that it's really clear the arrangement matters, and I don't know how to think about arrangements yet. You know, because it's not a reduction if it doesn't come out from below. I mean, if the arrangement is something you have to put in at quite a different level, then, yeah. Okay?
I'm very much in all the 4 lectures I think I'm very much in agreement with what you
You could
have
like
said.
them and disagree with every word, of course.
Sorry?
You could like them and still disagree with every word.
Yeah, but now comes a question and then a kind of further thought. We're about the same age. I have followed your writings more or less over the decades. And from the start, one thing I did not approve of, disagreed widely because for some reasons, no need to talk about here, they were important to me. And that is that in your book, How the Laws of Physics Lie, you very explicitly claim that in vector addition, it's only the resultant vector that we should regard as real. The rest is mere help for thinking. Now, here on your slide with the pendulum, Newtonian mechanics came in, and there you said the contributions are added via vector addition, and you, at least to me, spoke as if each and every contribution was as real as anything can be. So Simple question. Have you changed your mind? I would be very happy about that. Or how do you explain the consistency between your slide here today about the pendulum and I guess it was your first book, was it? How the Laws of Physics Lie? Yeah, okay.
Given it was what, 1970 something, 1979.
Yeah,
it was my first book.
Yeah,
we're not that old. I've changed my mind, or what I've done. I've changed my mind. I think that's the thing to say. But I can also kind of explain what was going on. Is that, and I think you see this in other people. I accused Rausch of something which is structurally the same. I said she wants to do an objective theory, but we're so in the habit of having subjective theories of evidence and that, you know, I think she's just without realizing it imported the things from the views that she really doesn't want. Yeah. And I think that's what I was doing in How the Laws of Physics Lie. I was not sufficiently, even though I did causality, I mean, it was bad enough to do causality. Now, if you listen to me, there's all these different modalities out there in the world. There's singular causings, there's causal laws, there's statements of capacity. They're all different kinds of modalities. Well, I didn't. I mean, first, I didn't realize that. I certainly didn't. It wasn't like it was in the back of my head, but it just wouldn't have. I mean, I just wasn't imaginative enough to think that. So I was using John Ehrman, David Lewis kind of standard of occurrence. And what seemed to me was that you couldn't have the components occur and the whole thing occur in the same sense of occurrence that those Humeans wanted. I mean, you see it, but I was just explaining it that since we raised the question, everyone else. You could think a wall and the bricks that make it up all occur in the same sense of occur. But I don't think that component forces and the total force can. Then, you know, people think they can. I think that's just concealing that they're talking about contributions and capacities. So I now use lots of other examples, like the circuits, where there's just no way in which you can think. You learn the contributions of the resistors, the capacitors, the inductors, and you don't add them up in any way to get the current, the total current. You use some other rule of combination that would never occur to you to make you think that all those little components are really just there, you know, the way the bricks are in the wall, as well as the total current.
Yeah, but I thought about mechanisms, and I think if I had known your term nomological machines, I would, in a paper I wrote 15 years ago, have used the term logical machines. And the idea is extremely simple, therefore I can't resist putting it forward here. Think of two cogwheels. They have to move in opposite directions. And to me, this truth is as obvious and as epistemologically certain that the sum of the angles in a triangle is 180 degrees. They have to move in different directions. From this, you can say or think, if you put a third cogwheel onto both of them, this third cogwheel have to go opposite to both of them. That means it has to move in two directions at once, which is logically impossible. Therefore, three cogwheels combined cannot move. And that, I think this kind of, so to speak, logical thinking plays an important role in engineering thinking when you construct arrangement, to take one of the phrases. So I think there is very much to do with your notion of a nomological machine that has not been done. That's, so to speak, the simple point of this little remark. Yeah.
I think you told me that at some point, perhaps at this other conference, because I've taken that on board. It's just that I'm reluctant to do the work it takes to think it through. You know, what are the ceteris paribus conditions? What are your, I mean, you're assuming that a cogwheel has, in a sense, a certain geometrical shape by definition, and I think you're right. I think it does, and we claim there are cogwheels in the world, and etc. But no, I agree with you.
Now, again, this is not so much a question. I just want to understand a little bit. Maybe it's a continuation of Tobias's line of questioning. So I have a question about the inside of these machines. So one question, or one thing I was wondering about is that at times when you were talking about these machines, you described them as mechanisms in the sense, I mean, very nice to think of it as you lower a lever and then this happens, and then that happens, and then this happens, and that goes up and that goes down, very mechanically. And so almost like a sequence of mini causal transactions, you might say. And then in the end there is this major cause. And then, of course, I think perhaps what Tobias possibly was after is that then, of course, you could, then in every nomological machine, you could like subdivide the individuation of machines would be like you have this machine, but you might as well slide this machine up and you get these smaller machines, which you in turn may slide up, because inside every machine you have the seedling for smaller machines, so to speak, so that you get further and further down the line. But then at times you speak as if what happens when you push the lever of the machine, whatever kind of machine it is that there are these capacities that combine. Now there it sounds as if, you know, all this talk about, so there it sounds as if what happens inside the machine is much harder to predict or say anything about, in fact, so that you can actually identify machines and you can see that if you push the lever, something happens, and then you have this predictable result. So you have something coming in, something coming out, and then something happening in the middle. You cannot really tell what, because it's not this first this, then this. There are all these capacities that are kind of starting to work together, and perhaps there are what we might call emergent effect. I mean, they seem at least harder to quantify, harder to understand, perhaps. So. Yes. Do you have a comment on this?
Yes, I have a comment. If you take the change story, so let's escape and go back to where there's a change story. I don't know whether we need the picture, but we have one of these change stories that John likes so much. Let's not do that one. That one's too unstructured. There's that one. Now that one may be too mechanical for us. The image that I think is now the right one to have is that the machine starts in a start arrangement, and it does go through a sequence of changes. And the sequence of changes is a series of things you might call machines themselves. So if you have, might go, when the handle is turned, the lever, which has the capacity to pull up the rod, pulls up the rod. Well, you could just have a little machine, that's all it had, right? It had a lever and a rod, which is not doing anything interesting, but pressing the lever pulls up the rod, because the lever is a lever and pressing one end raises objects at the other end. And that itself would be a machine with the input-output relations that pressing the lever raises the rod. But then the next step, depending on, I mean, it could just depend on the structure that's already there, but normally it depends on there being other components with other capacities, produces the next step. So you can slice the machines up like this, temporally, and have machines all along the way. But you can't slice them up by going to their parts. So that's, you know, one thing is to slice them temporally this way. Another is to say that every input-output relation caused by a machine is reducible to its parts all behaving at I mean, the reducible thing is it's reducible to its parts behaving in certain ways, but what we're doing at this stage is ascribing irreducible capacities to the parts. So the The handle is attached to a lever that's attached to a rod. Okay, those are the three parts. Okay. Those in that arrangement, the lever always has a capacity to raise an object at the other end when this object is pressed. So these three, when they're hooked together, so that the one is a lever and pushing this is pressing on the end of it and the other, that's simply the capacity of a lever to raise an object at the other end is it makes its contribution. Right? Now the reason I would talk about a contribution there is you might actually have something pulling on the other end and you're pressing and it's trying to pull it, but it's not doing it because, and maybe it breaks for that reason. So you need to understand that the contribution is there even though you're not getting the predicted output. So the components have contributions, and if you go to the force one, which was where? Was that the back with the one, this one? There's the canonical case, but I don't think it's really, I don't think much of life is like this, where you have parts. The parts have features, like being massive. Those features bring with them capacities to attract and be attracted. And we have a rule. Right? I mean, those capacities we know, not only we know, but it's also a fact that they don't need to be triggered. So they're always, the bob is always attracting and being attracted by the Earth. So the only thing you need to do is release the bob. And those capacities produce their contributions, and the contributions are the total force that adds vectorially. I don't think I went down to microphysics to do that. I stayed all at the, I mean, I would just claim you can't get any of this out of microphysics. So I can slice the machines like this, but to go from one stage to the next, you have to have components with capacities that combine, that produce contributions that combine to give you the end point of the first stage.
Okay, so just one small question. So
yeah.
Suppose you have this machine which consists in some kind of transfer of energy, or I mean, but what it basically is you push a lever and something goes up. So how would a microphysical machine look then? I mean, how would that kind of machine look on that? There are machines on that.
I don't think there are any microphysical
okay.
There aren't any microphysical levels.
No,
levers.
First of all, okay.
So are there microphysical machines? Yes. So I think that there are it's not enough, of course, to have a bag of atoms in an excited state, or an atom over here and an atom over there and an atom. You have to have a collection of atoms in an excited state.
But suppose you have this lever and this happening. You have this machine inside of the machine, but you don't describe it as a lever. You describe it in terms of excited, I don't know physics, so excited atoms jumping back.
Well, that's the question. That's the question in the dappled world that I didn't discuss about what the arguments are that you can't reduce that. The arguments that it ain't reduced right, anywhere. I've never seen I've seen 2 or 3 reductions. Right? All this stuff about how you can reduce just is promissory notes. And I claim I can make a perfectly consistent account of why we have the successes in science that we do without the big metaphysics that says it's all physics from the bottom up. I mean, the metaphysics just takes what you see is what you get, and what you use in your models to make accurate predictions is what you suppose. And I think I can sit down and tell you what I think how to put these fundamental laws with the right ceteris paribus conditions in, so that I can explain what the bounds on their domain is. It isn't that they hold in this room and not in that room. It's that they hold when all the causes of the relevant effects can be described in the concepts available to the theory.
But I mean, still, even you agree that there are things like atoms
Yeah,
Yes.
sure.
So I mean, so this is more a question about the individuation of machines. So what you're saying is that when you have this machine, which is the toilet cistern, then at the same place you have another machine, of course, a distinct machine, which consists of these atoms and whatever.
Well, I don't know whether I have a machine. I do have a machine that consists of atoms. I have the toilet cistern. Whether or not the facts about the atoms that are admissible in microphysics are enough to give you a prediction about the input-output relations of the toilet, that's the question that is the question of reduction. And I'm happy to start now and give another series of lectures, but for me, that's old stuff. I mean, that's what I did in this book that Tobias has mentioned, the Dappled World. So I just don't think it's the case. Right? When I look at the way you do, you actually, I believe in quantum theory. I think quantum theory is wonderful. I'm happy to have my eyes operated on with lasers. I think it's absolutely phenomenal. I believe, I don't understand what it would be to believe in a theory. What I think is it's a fantastic tool and particularly in the hands of my friends who are laser engineers, and a fantastic tool in helping us to build lasers. It was really important to understand this thing about spontaneous emission will stimulate more coherent radiation. That's something that is kind of a lesson from quantum theory. The idea that you can use quantum theory to predict the behavior in a laser, that I don't believe. And when I look at the models for lasers, the anecdote is, I used to go to these laser engineering courses, and I wanted to study lasers, and I wanted to study them theoretically, because I knew I wasn't any good at experimenting and stuff. I wanted to study them theoretically. I still had to go to the engineering department at Stanford, and they did teach quantum theory, but they didn't, it just didn't, and it doesn't carry through all the way. So these guys say, well, you know what the arguments are. They say, we can't be bothered. Right? Why should we? We're getting what we want, and that's just an exercise. Leave it to some philosopher to write out the real reduction. And I don't think anybody's capable of it. And I think because the reason is that the laws we're very, very lucky, and we found some regularities, some putatively exceptionalist regularities that hold, so long as all the causes that are relevant to the effect in question can be described in the concepts of the theory. Then if you're one of these reductionists, you think everything can be described in the concepts of this theory, and there's no evidence for that. So it's just like Hume. Right? If you just looked at the world around you, you'd say that God was a turnip. Right? You can stand there and say, I'm sure that there's an explanation, and that all of this, there is an intelligent designer, and we just can't see the design. But it's not the natural inference you draw if you looked at the way the world actually is. If really you knew that there was the Hume argument. It seems to me it's exactly the same thing for the reduction. That, well, if I absolutely knew it was right, I can explain away why we don't have any of these reductions. We're just not clever enough, right? And we don't bother. But why I should think that it's the case, if given the way the world is, it's not. And then, of course, there might be metaphysical arguments, but I am prepared to engage you with those because I don't think they're going to be good enough for reduction.
Take this after.
And the part whole, I don't think part whole relations don't get you that you can get the characteristics of the wholes out of the parts.
Right, so this is probably also just more a request for explication than a question.
I hope it's about this, though, not about the.
We
just had a long lecture on a totally different project.
Along the same lines, though, as Tobias and Anna-Sophia's questions. So I'm very glad you brought up the MDC model. And I was thinking, so I started reading about that as a way to understand what it means to explain something in cognitive science, where I work. And there are the ideas, so you have, normally you can do input-output psychology, but then the idea is, well, if you start looking for mechanism, you do something more, and they explain that quite nicely. And so I started thinking about your toaster, and then how that relates to the policies in India. So you had the toaster, and you said, well, then I can look at the manual and see how I press the lever, and then I get brown bread. And that would be similar maybe to the policymaker who looks, well, I want to improve some general human development index, and I institute this nutritional program. Kind of, it's kind of a same level of description. And then when I was a child, we had this toaster at home, which was broken. So it was classic, you press down, but then it wouldn't stick because the spring was broken. So, but we knew the spring was broken, so we could put some wooden object into the gap there, and keep it down, and you manually removed it, and you got the toast out. So that would be kind of knowing the capacity of the spring, and thus being able to know part of the mechanism involved, something that the policymakers in India, obviously, or in Bangladesh then didn't know. So really what I'm asking about here is like levels of description and explanation. So it seems that by going deeper down in the mechanisms, we were able to explain the use of the toaster better. And this was similar to your call for the problem with RCTs, that they assume too much about the capacities. But then it would seem that we would want to go deeper in this more reductionist sense to understand these mechanisms and capacities. And looking at the manual about the toasters.
Yeah, but you all have got, you've got only one sense of deeper in your heads. Right? Here's another way to go deeper. Yes. There are two ways to go deeper. One is to talk about the itty-bitty parts and their physics characteristics. Another way to go deeper is to talk about the parts and their capacities that you simply ascribe to them because they're in this case, they're macroscopic characteristics, and the thing's got a mass. Right? I'm not going to talk about space-time curvature and GTR and the fact that if you thought that was a universal theory, you wouldn't think there were any forces, right? And knowing masses wouldn't do, is just a shorthand. So going deeper can be, let's look at the inside of the machine. And then, of course, you want to think about components, but they don't have to be components at any different. I don't believe in levels of description, so it's kind of hard for me to. Because I don't have a reductionist, I can't understand a reductionist program. I don't have the idea, but other people talk. It's at the same level of description. I'm going to talk about levers to the cistern. I'm going to talk and your toaster. I'm going to talk about springs and little bits of wood that play the role of blocking a return action and so forth. So I do think it's really important. I mean, that was why I said that it's really important to have evidence. The nomological machines are the what evidence. What is it that's responsible for this holding? And you want to understand how it works in order to fix it when it breaks. Build a better machine, do know whether you could expect the same causal law in new cases, because if you've got it looks like a toaster, but it's a toy toaster, etc.
Yeah, but so my worry then is, when does the policymaker know when to stop, when to accept the causal law that's been proposed, or when to go to? So I mean. So obviously when I just want to operate the toaster, I obviously don't need to know about the springs, and even when I know about the springs, I don't need to know anything about spring constants. I mean, so I agree with you there. I mean, there's no need to always go try to do some sort of reduction.
No,
I'm not proposing that.
If somebody else hasn't doesn't know about the machine, okay, you don't know when. So this was the thesis. You do you do all of the stuff, which is that evidence, RCTs. Bayes-Nett's methods, process tracing, etc. Well, process tracing I've called Howe evidence, but you know Howe and that evidence. And that tells you've got a causal law. You've got a causal law so long as whatever the machine is that generates it is intact and it's the same machine. I'm a new policymaker. So I'm enjoined to use evidence. Well, what I hope is that I can go to a scientific warehouse, which is what they offer, and get the evidence out. What's in the scientific warehouse turns out to be a lot of policy, a lot of pieces of evidence about that things have worked somewhere, and no pieces of evidence about what the machines are that give rise to that. Now, if you're a policymaker, you're not particularly the guy who's going to be especially, I mean, I assume that, right, that part of the problem is that scientists are being urged to do RCT, that development economics now, to do RCTs, which is to fill the warehouse with only evidence about only one premise in the argument you need to get it works here. The second premise you need is, in a sense, same machine. And if you don't have any evidence about the same machine, you're winging it. You're just winging it. So somebody has got to have evidence that the causal law travels, or there ain't evidence. So when does the policymaker have to do it? Never, hopefully. When does the scientific community have to do it? Always. Anytime you start with a premise, it works somewhere, and you end up with a conclusion, it works here, and you want to use this as evidence for that, it's only evidence relative to the other premises. The helping factors are here, and it plays the same causal role, which it will if it's got the same machine. And when there's no evidence for the other two premises, then you don't even have a clue whether the first premise is actually evidence for your conclusion. Then you certainly don't have very good reason for adopting the conclusion. You might adopt it because you don't have any other better idea what to do, and it's not very costly.
But so then it hinges on knowing that it's the same nomological machine or not, right?
That's, I mean,
and
well, all you have to know is that it plays the same role, the causal role here as it does there. But the easiest way to know that is to know you've got the same machine giving rise to it. But if somehow you had a backdoor way to find that out, I mean, it won't. Except for Ingvar's handful of causal laws that just hold everywhere, anywhere, and don't need a nomological machine to give rise to them. It won't hold here. The thing that held there won't hold here unless we've got the same machine. I mean, you could accidentally have a totally different machine that did the same thing. I mean, there are resilient toasters with totally different structures inside that all brown toast. But you know, that I wouldn't bet on that if I. Okay? No.
I have a question about the future of this project, and I want to say something about the background first. How it is at present. I guess there are quite a number of theories, somewhat like your theory about nomological machines nowadays. You have talked about Mackamer's view on mechanisms, and there are many others. He talks about activities, but you could go to Stuart Glennon and he would talk about capacities, and you have people who combine these views, like James Tabry talking about both activities and the other stuff, capacities. So
I'm always glad when I hear the word capacity because it helps me get a raise. It means
right? so now I have two questions.
I mean, it's an idea that's spirit of the times, right? But if you use my word, then my department will say, citation.
Yeah, it's nothing like that. But so I have two questions about the future. The first is about this mechanistic or the machine project. Will it be unified? The terms differ? Or the ideas so different that there will be a number of theories in the future as well? That's one.
Yes.
And the other
can I
is more important, perhaps.
Well, let me say something about that.
Yep.
I've not a clue, because that depends on whether some philosopher decides to go out, and I can unify them. I mean, I understand what the differences are, and a lot of the differences have to do with, remember I said that I didn't think evidence was a natural kind. I don't actually think mechanism is a natural kind either. I mean, this particular concept of a nomological machine is, I mean, I think there are nomological machines in nature, but then there's a lot of other things that are very similar to nomological machines that are MDC mechanisms and Bechtel mechanisms, and Glennon's are kind of close to mine. So whether you come up with, somebody wants to bother to come up with a more abstract description that gets most of them in, and then explains what the, what role the differences are playing. I could give that job. Sorry, it's just that I know the literature fairly well, so I'm making a bet. I could give that job to a graduate student to write a thesis, and then they come out with a nice PhD thesis. So I think they can be categorized and unified in a sense, but I don't see any need to do that. And I don't know. I mean, I'm only returning to this stuff about nomological machines that I did 15 years ago, or 1989. How long ago is that? That's 15 years ago, I guess. I'm only returning to it because what I've noticed that I've now been doing evidence-based policy is that it's just the stuff that you actually need, right? This stuff I did for fun, in a sense, or because there were intellectual problems driving it, now seem to me there are practical problems. So I think you could unify it. I'm not going to do it. I'm kind of bored by nomological machines, right?
Yep, no, that's fine now. So the more important question perhaps is if you have any ideas about the future projects, how you will be able to put these kinds of theories into work. Of course, the lectures is a very good illustration of how you can do it, but if you would like to say something more about...
I think that, yes. I think it would help to really spend more time understanding, looking to see if I'm right, that you can understand the difference between Tamil Nadu and Bangladesh by reconstructing it as a socio-cultural economic machine. It might be that this idea that works very well for these kind of machines and biology, and looks as if, if you could only say the right things, would account for the stability of the law in Tamil Nadu and the fact that it doesn't travel, right? So, I mean, I think that I've given an account that is plausible, but I mean, I certainly didn't produce a blueprint for, I didn't do a model from which we derived the behavior in Tamil Nadu, and then showed that with what was missing in the socioeconomic practice over here. I think that's a really important project to do, and that we shouldn't be doing it by doing rational choice theory, and that it involves institutions, and institutions in more than just the sense of rules and roles, but certainly more than the sense of rules. So my next project, that I have no ideas how to go about, is to try and think really in terms, I mean, one can understand, you can go and read anthropologists and study the Bangladeshi society and understand what's going on, such that this causal law didn't work there, didn't hold there. But that's different from giving a philosophical reconstruction and saying, look, this is a really interesting and important way to think about it, is to think in terms of the parts and their capacity, the institutions, the people in the institutions and their interactions, so that you can, you in a sense could have predicted it. I mean, people could have predicted it on the ground because they just had good sense and could see, but whether this is a general good device. So that's, I think, for me, that's the next exciting project, is to do that some way other than doing rational choice theory, Christina Bicchieri kind of thing on rules, etc. And if anybody has any help on it, that would be great.
I mean, really, this was the best point at which to stop, but I'll continue. Just that
that's good.
I'm just going to say,
really disappointed if we didn't have a discussion.
I just want to say that I think the last thing you said, I really agree with it, and it seems like a very good idea to go to, instead of doing just RCTs, what you should care a lot about are the underlying structures of machines that give rise to the regularities you find in one situation, and see if you can transport them, or if there is any chance at all of perhaps even manipulating the situation in here to see if it can turn into the right kind of machine. Yeah. But then I think that one thing that I think you need is more on the identity conditions for machines, because I mean when you were asked about the identity of the machine, what makes it the same machine, you actually made reference to the causal laws they give rise to, but that's not, I think, I mean, that's not the way to go, because then
the same machine means it's got components with the same capacities in the.
Yes. I think all of the work will have to do with what do you mean by component, and probably it will depend on which kind of machine it is. Is it a socio-economical machine, or is it a toaster?
Why do I have to worry about what I'm
sorry, because you
why do I have to worry about what I mean by component?
I think you do if you want to be able to manipulate a situation into the right kind of machine. So if you have, for instance, a toaster, and you say it's a matter of the components and their capacities, then I think it matters if you individuate the component in terms of, if you have this toaster, this machine, and you think, I have this lever, it weighs so and so much, it has this particular shape, maybe that doesn't matter. So what matters? At what level of description? I won't use that, but I mean, at what level of abstraction should I describe the machine in question so that I will be able to transport it, or perhaps...
Well, I know exactly what the answer to that is on the doctrine I've been defending, but it's not an operationalizable one, so but it's one that should suit metaphysicians. I think that I really think that we should think of the world in terms of single-track capacities. And single-track capacities, then what you need here is a lever. Right? Now, it might be that it isn't a lever unless and of course it'll weigh something. And it might be that if it's not enough that it's a lever. It has to be a lever of a certain weight. But I mean, the description of the machine says that if there's a lever there, and this and that, and nothing interferes, that's what's going to happen. So that's one of the advantages of single-track dispositions, is single-track capacities, is that that's the level of description. I mean, you want the capacity that is conveyed by the lever, the one that makes this contribution.
I think the problem is then that the term lever is not specific enough if it can mean something that doesn't give you the right result. So I mean, for this to be an operationable, like a thesis that you can transport and that you can use in order to fix things in Bangladesh, for instance, I do think it will matter how you individuate the parts of your machines, and how you identify the relevant parts and how you describe the relevant parts, so that you will be able to. So, and I'm not sure that it's not possible to do that. First of all, in a case from case basis, of course, it will be different. But why shouldn't we be able to formulate some general kind of rules for how to go about that? I mean, I don't know how to do that now.
I despair of them. So I do talk about this. I think that it's not a matter of how not being a metaphysician, I don't really care about and don't think much about in terms of individuation. So we might be getting at the same thing. Lever is not operationalizable. Right? Lever is an abstract concept, and it's not
specific enough.
It can be very different things. It can be a seesaw. and it can be a tire jack, and but lever is what matters, is that it be a lever. Then in each new situation, you have to be able to figure out what constitutes being a lever. I call that the problem of generally, if you want a machine or a description that is likely to have very broad scope, a causal law that has a very broad scope, or a machine description that has a very broad scope, you'll have to use very abstract concepts in it. The problem when you use very abstract concepts is what concretizes them looks different from one place to another, and the abstract science that tells you that if you've got a lever, okay, so in the Bangladesh case, I just didn't do this, but one of the things that is in the longer paper, right, is that I think there is a nice causal law that is true in both situations, and that's that if you educate the person who is, and then I'm going to give you an abstract description, in charge of procuring the food, dispensing the food, and holds the child's interest as central in doing so, then educating that person, if there is such a person, will improve nutrition. I think that's something that travels more wide, that has a broader scope. I think it's true in Tamil Nadu. It is because the mother was that in that case, and it is true there. I think it's probably true in Bangladesh that if you could, but there isn't any such person there.
Yeah.
So
you have to create one.
So you could make one.
Yes.
I mean, you might be, change the, if you
But
did.
this is exactly what I mean. So I think we are on the same page. So I think that's the key. The key has to do with, describing clusters of capacities and saying, like, how many parts in this nomological machine needs to have, do we have to have one part in this machine with all of the capacities? No, we have to have...
I just don't think I think this is not a metaphysical but a scientific enterprise.
Of course, but
one
I
has
thought
to
you
learn.
were more interested in...
Yes, so you have to learn in a new situation what concretizes it. So I call that going up and down the ladder of abstraction. And that one of the problems with RCTs is that, did I talk about this already? Because if they're going to have the rigor they're supposed to, you have to make sure everybody gets the same treatment. So you give very, very concrete descriptions of the treatment. And very, very concrete descriptions are not likely to be the ones that travel. I mean, the treatment satisfies both a concrete one and an abstract one. The abstract one's likely to travel. If you make it too abstract or you abstract the wrong way, you get the wrong result. I mean, we all know that about co-extensionality, that the same phenomenon has an infinitude of descriptions, and you've got to settle on the right one for
exactly.
For
so
the travel.
Then I was thinking perhaps that's something that you can do in general. So, or do you think it's from case to case where the right level of abstraction?
Okay, I think that in the mechanics case, and in so I think we've given up a little bit when we stopped talking about axiomatizing theories. I think that's not such a necessary thing to do, but when Hempel did that, and they talk about internal principles and bridge principles. Now, I think what a bridge principle does is it tells you a concrete description at one end and the abstract description at the other. So you know that you've got F sub g, the force of gravity. Well, I'm allowed to write gmm over r squared, that's abstract, whenever I have two massive bodies separated by distance r. I can write q1, q2 over r squared when I've got two charges separated by distance r. And so the fairy story was that in a really good science, you have bridge principles, so that everything is pre-settled. Right? That you just go to the science, and it tells you exactly what the concrete description is, and you can look to see if any of these hold, and then you know what abstract description to put on, then you can do your... well, no other science is like that, and the rest of physics isn't really like that either. So, but that seems to me the enterprise that you have to engage in. I just don't think I have any ideas about how, but I agree with you. That's my vocabulary for a problem I think we share, and I don't know how to go about it. But I think it is a scientific problem.
Thank you. So in your book, The Dappled World, your description of nomological machines there, you place emphasis on the shielding conditions that are characterizing these nomological machines. It seems to me that in the examples you've given today, you haven't really talked about these shielding conditions, and it seems like in the Bangladesh example that this is actually quite relevant to consider. I mean, it's not only the interior of the machine, but also how the machine is organized with respect to the rest of the factors that might influence the capacities, things that...
Yeah, I mean, that might disturb it. Yes, well, I did say twice that on 2 slides that the structure has to be intact and that it has to perform properly. And that's just another way of referring to shielding conditions. The shielding conditions are what the actual physical or social stuff that ensures that it's intact. So the planetary system is fairly, comes shielded. It doesn't come shielded. There's no shield around it. It's just far away. So hardly anything of the right order of magnitude gets in. I think you're right about the socioeconomic, sociocultural, political, economic cases that even when you get a fairly stable social arrangement, it's easily, the arrangement itself is easily upset. But then some of them aren't. I mean, some things are terribly hard to change too. So.
About this economical example you had, the one with the Phillips curve, and with the cistern and the toaster, that's fairly obvious that that's concrete physical objects that we are talking about. That is, they're placed in some sort of relation to each other. So it's physical objects. But the example with the Phillips curve, I mean, that seems to be more like a model.
Well, the Phillips curve represents a real regularity between rising prices and falling unemployment levels. Now, prices are constructs out of real prices. The price index or the inflation index is itself, you might think it can't be causal. I mean, I have a different view, but it certainly is constructed out of things like real prices in these 20,000 shops that the guys from the Bureau of Labor Statistics went in and sampled. And unemployment certainly is something that you go and you count. You count the wrong things, but you go and count. And then there are, the index is constructed, but it's constructed by rules out of real stuff. And whether what's doing the causing is the constructed entity, or people's belief in the constructed entity. I mean, the constructed entity in social cases, this is kind of hacking point of all those social theory of knowledge people, that the fact that we construct an index, the index becomes a real thing that has causal efficacy because we somehow, I mean, we treat it as if it's a real thing, and we have beliefs about it, and we act in response to it. So whether or not it's a physical thing that could cause me to do something, it certainly is something that it's announced and we behave differently. and the story really is about people seeing prices rise. And the reason the Phillips curve holds, right, people see prices rise and they think that they'll make more money if they sell more stuff. I mean, they don't have the products, they're sold out, right? And the prices seem to be going up. So let's make some more. So let's hire people to make some more. So I hire people and the unemployment level goes down. And then that's when prices are rising by things I can't see, and I mistake them. So I'm just telling you that there really is a causal story there, right? And it works kind of the way John Pemberton says. It's you can follow through the changes in the machine, right? That as long as people don't recognize that the price rises are just inflation and think they're real price rises, they'll do this, that, they'll open jobs, unemployment will go down. Then government manipulates it, everybody recognizes it's just inflation, and people behave differently. But all that, I mean, it happens to be a nice case where I think there's a totally conventional kind of causal story to tell.
I would like to express our gratitude on behalf of the Department of Philosophy with this diploma.
Thank you. It's a diploma for?
It's a diploma for being this year's Pufendorf Lecturer. And you will also get a medallion with
yes.
Samuel von Pufendorf and your name engraved on it.
Oh, great. Thank you. Oh, that's great. I'll put it beside Stuart's Tanner Lecture one, yes? Right. Thank you. No, thank you.